Good morning, ladies and gentlemen. Thank you for being it's we begin with the inaugural session. I request our seminar chairman and president of SGAT, Dr. O.N. Mahanti, to kindly come to the dais. I request Mr. S.S. Mahanti, chief guest of this morning, kindly take the chair. Dear Dr. Debashish Bhattacharya, invited speaker, please come to the dais. Mr. Rajiv Kumar Bhatnagar, for the invited talk. Please occupy the dais. And then we'll go for lighting the lamp. Let's. Mr. Mayank Gupta. And Ms. Samiksha Das. Can I? Samiksha Das and Mr. Mayank Gupta. Yeah, please wait till when they come back, you will offer the bouquets. Mr. Mayank Gupta and Samiksha Das. Please. Yes. So I request Ms. Samiksha Das to kindly greet the guests on the dais with bouquets, please. Mr. S.S. Mahanti. Dr. Dr. Debashish Bhattacharya. Yeah. Yeah. Then Mr. Rajiv Bhatnagar, please. Next. And our president, Dr. O.N. Mahanti. Honorable President,
ଯେତେବେଳେ ଆମେ ଯାଇଥିଲୁ ମୁଁ କହିଲି ମୁଁ ବାହାରକୁ ସିଧା ବି ମୋ ସାଙ୍ଗରେ ଆସିଛି ମୁଁ ଆଜି ହୀରାଖଣ୍ଡ ଯିବାକୁ ଆମେ ଫେରୁ ନା ନାଇଁ ସେଦିନ ମାନେ କଣ ଯାଇପାରିଲେନି।
I welcome the guests, starting with Chief Guest, Mr. Shashi Shekhar Mahanti, who is the Managing Director of SR Minment. He was CEO and Managing Director. Actually, he is CEO and Managing Director and Chairman of Nilachal Ispat Nigam Limited. He was Director Technical in preceding years at Steel Authority of India Limited. He was Executive Director, Project and Business Planning at Steel Authority of India Limited. And he was Managing Director of Sale at Bucharest Steel. Actually, we are not able to cover the entire credentials of our guests because that will take away the entire day. So we are making it brief. And in the process, what we are doing is actually, we are trying to measure the temperature of blast furnace with a clinical thermometer. So it will not work. And next, our next guest is Mr. Rajiv Kumar Bhatnagar. He's Executive Director, Projects, ArcelorMittal, Nippon Steel. Mr. Bhatnagar has a BTech degree in Metallurgical Engineering from IIT Kanpur, completed his postgraduate degree in Industrial Engineering from Indian Institution of Industrial Engineering. Later in the career, he completed International Executive Program from INSEAD, France. Mr. Bhatnagar joined SR Steel as a head of technology in August 2010 and took up the role of CEO of the Hazira facility since July 2011. Well, again, I'm being brief. Our next guest, a speaker, he is our invited speaker, is Dr. Debashish Bhattacharjee, BE in Metallurgical Engineering from Jadavpur University, MTech in Metallurgy from IIT Kanpur, PhD in Material Science and Metallurgy from University of Cambridge, UK. He carried out 2 postdoctoral research engagements at the Rolls-Royce University Technology Center, Cambridge, and the University of Birmingham between 2002. Okay. He joined Tata Steel Research and Development in 1996 and headed the function as Chief Research and Development and Scientific Services till 2009. As I said, all blast furnaces. So I will be very brief and then go over to we have now a small event of releasing the souvenir of today's proceedings. So I request our chief guest, Mr. S.S. Mahanti, to kindly release the souvenir. Thank you. The souvenir is an product of the efforts of our 9 invited speakers today and our 7 sponsors. This has given rise to the problem. I will give you a brief sketch of Society of Geoscientists and Allied Technologists. Well, I begin afresh. Honorable President, the chief guest of the inaugural session, Mr. S.S. Mahanti, Mr. Rajiv Bhatnagar, Dr. Devashish Bhattacharjee, dignitaries of the dais, and ladies and gentlemen. The Society of Geoscientists and Allied Technologists is a not-for-profit professional body dedicated to the cause of geoscientific studies and sustainable mineral development activities in India. The first one. SGAT started in 1980 by a handful of eminent geoscientists from the state of Odisha. SGAT has grown in size and activity spectrum by attracting scientists and technologists into its fold from a range of disciplines such as geology, geophysics, mining engineering, mineral processing, metallurgical engineering, environmental science, and engineering, and so on. The society engages in dialogues with various government and private bodies having a stake in exploration, mining, downstream mineral-based industrial activities, environmental issues, etc. It facilitates interaction between academia, industry, policymakers, regulatory bodies, to name a few. Through seminars like this, SGAT has instituted several national awards annually to researchers in geology and allied sciences. One of the philanthropic activities undertaken by Society of Geoscientists, the second slide, second or third. You are going to the last slides, no? Beginning, what is the beginning? The story of SGAT. First slide. One of the philanthropic activities, this is what actually I was speaking about. Activities undertaken by SGAT, which is a very significant program of SGAT over the past 3 decades, is directed towards instilling awareness about geology, mineral development, and environmental science among the students, both at school and postgraduate level. Environment cum Mineral Awareness Program and Mineral Development Awareness Program. This is from the Mineral Development Awareness Program, which was only 14 days ago held in Joda and generously sponsored by Tata Steel. Program, it has set up, now coming, just scroll the slides and come to the next. I'll tell you, please. Yeah, these are the active, members who organized the MDAP program in Joda with the sponsors from Tata Steel. Next, please. Next, please. Next, please. These are the students who participated and won trophies. Next, please. Okay. Yeah. So these are the, now this is the inauguration of our museum, Rock and Mineral Museum, which was, inaugurated by our minister. Then your photograph is here. This, the inauguration of the museum. In order to meet the host of challenges ranging from exploration to environment, a number of subject specialists were brought together by SGAT, and a comprehensive compendium on geology and mineral resources of Odisha was published by the generous support of the OMC, and the book was released by His Excellency, the Governor of Odisha in March 2021. This is the book. It's available. The book is available. It is originally priced at 1,500, but now we have actually made it a concessional price of rupees 800 each, and is available for procurement. Anybody interested can buy it here. The book is also on display on the rear corner. And it's a 760-page book, contains everything about mineral resources and the geology of Odisha. The society, in fact, this book, I have to mention that this book is the 4th edition of the one which was published in 1995. The society has been playing a significant role in assisting the government of Odisha on multiple fronts, particularly while formulating the state's exploration and mineral programs. Responding to a call, SGAT lent its support in preparing the vision document for mineral development in Odisha for the year 2020 and again for the year 2030. And I think, please, let me try. No. This is a bulletin, is biannually published twice a year, wherein we publish the articles from researchers on geology and allied technology. In this, we also encourage participation of younger students for their research work to be published and shared. And then we also, in order to motivate them, we have launched a prize for the best author, only confined to the students, younger generation scientists. And then we come to, I think Tata Steel will understand us better if I say that in addition to all these activities, we also organize seminars. This happens to be the 66th seminar today. And these are the titles of the last 5 years, whatever we had. And except for the year 2021, 22, we didn't have because of the COVID restrictions. Thank you. I conclude this. And now I request. Yeah. So overview. Now I leave it to our president, Dr. O.N. Mahanti.
Thank you, Dr. Farooq. A very good morning to everyone present here. It's my great pleasure to be standing in front of you and be sharing my thoughts on the seminar itself, an overview. But let me begin by saying that what can I tell about a seminar on a day, 9th of September today, when the G20 is taking place in Delhi. When the G20 has seen all the state heads assembled at Delhi, and we have all the heads of or most of the heads of the steel companies here. So we have a small G9 here, if I can call this way. So thank you very much, all the delegates, and particularly our guests from various steel plants. So be that as it may, most important thing is the steel, this particular seminar, we have named it as the sustainable steel production in India. So when we talk of the sustainable steel production, we always think of the fact that can we do without steel, or whether the steel has become an old commodity, because these are the standard myths. There are two standard myths I begin with. One is it's a sunset industry. So it's setting anyway. The other materials, competing materials, composites and so on, which are coming up. And the second myth is there's nothing more to learn since Bismarck discovered steel. There's nothing more to learn really, because we know everything about the steel because 120 years, 130 years it has been in circulation. And as a matter of fact, I don't have to go very far or labor the point that both of them are absolutely wrong. It's not a sunset industry. If you look at the growth of steel across the globe, 10 years back when it was about 1,500 million tons, and today the world is witnessing about 1,878 or let's say 1,900 million tons in 10 years' time. And it is growing. It is still growing. So that was myth number one. And the second one is the past 15 to 20 years. But that's, of course, not my main topic right now, but in the past 15 to 20 years, those of us, and Dr. Devashish Bhattacharya is one of the pioneers, of course, in that, namely the new steels, the new generation steels. These have come up only in the past 20 years or so. If you talk of the transmission-induced plasticity or twin-induced plasticity or the quench partitioning steels and so on, who would have known them 20 years back? But they have all happened. So generation 1, generation 2, and today the advanced high-strength steel generation 3, they have all come. And therefore, the myth number 2, that nothing new is happening, is very, very untrue. After all, steel would be nothing if not for the developments with which steel is associated. As far as Government of India is concerned, or we are all concerned, we know for the past 5 years we have been enjoying this quote unquote the second position. It's actually not quote unquote, it is truly the second position formally and officially. 125 or close to that million tons. But if you look at the fact that it's only about 78 kilograms per head, we still have to go a long way because the world average is way above 233 or thereabout. So therefore, what is the milestone that Government of India has set? They have said by 230, we'll have a 300 million tons of production. But in between, in the interim phase, we should have about 160 million tons so that we will be able to achieve the $5 billion economy. And in the $5 billion economy, we are talking of the construction sector, the aerospace sector, and particularly the automotive sector and the energy sector. Everywhere, steel has to be there. And that's the reason why Government of India also wants, or the Indian steel manufacturers would like to see, the champions of all of them are practically sitting here, that to go to 160 from 125, I don't know, somebody's telephone. So that's actually what I'm trying to say is, in short, it is very justified. The targets of 300 million tons by 230 or 160 million tons in the next 3 years or 4 years, in order to meet the $5 billion economy and so on, these requirements are absolutely justified. What is, however, very worrying and worrisome is the fact that if we contribute, if the steel globally contributes to roughly 7.5% of the total CO2 that is generated in the world, something has to be done. This is what the world community thinks. And in India, therefore, a large number of initiatives also have come into play. And many of the champions of steel companies who are present here, they would have attended in, I think it was 19th, between 19th to 21st. I don't know how many of you are there. You were there, of the FICCI and Government of Odisha, the seminar that took place over 3 days. And that was also all about sustainability, only about a few months back. And it was a 3-day-long program in which a very large number of participants came and spoke. What's happening internationally? Internationally, even bigger things are happening. So if you are looking at SSAB, they would say that we will be the first steel company in the world who would give the green steel to you, produced with the green hydrogen. And they have indeed shown it also. And they actually show a vehicle, and they say this is the world's first vehicle, which is a green vehicle made from green steel, the green steel made from green hydrogen, and so on and so forth. And today they also show a small watch. It's a wristwatch. And they say the first wristwatch, which is the green wristwatch, because we have produced it from green steel. This is what has happened. So I don't have to tell most of the people who are present here, the hybrid technology, which they say is the hydrogen breakthrough iron technology, is the technology which they are saying is the pathfinder for the future. And not just enough that, because the POSCO people also have come out with their own brand, which is the Hydex process. Probably they have not gone that far. But the interesting aspect is the international collaboration between these two companies, who are the SSAB. Of course, the SSABs is not just SSAB. It is LKAB and Bhatanal. That means the energy producer, the iron ore manufacturers, and the steel company together, they have made it a success. But the interesting aspect internationally is that I think in October last year, I don't know if some of our colleagues who are present here were present, But October last year only, as late as October last year, SSAB and POSCO together formed the Iron and Steel Hydrogen Forum. And there are a large number of steel companies who are members of that. And this Hydrogen Forum actually discussed about how do they take some of these technologies. And I liked one epithet which was actually given by Choi, J.W. Choi, who is the CEO of POSCO. And he was talking about the co-opetition. The co-opetition essentially is the cooperation and competition. And co-opetition, rightly so, essentially because unless all steel companies and all stakeholders join hands, we cannot actually achieve this. So much about why we intended to have this program here. But the next question is, if there are internationally so many things happening, nationally also so many organizations who are holding, what is the great news about this particular conference? I would go as far as telling that SGAT, as you have seen, this building is ours. It's a modest building in that sense. Initially, we debated when we have these stalwarts from the steel industries, should we hold it in a 5-star hotel or here? Then we decided, no, we must hold it here because this is the ground reality as far as we are concerned. So we decided to hold it here. And this particular community talks of the geologists, geophysicists, mining engineers, mineral processing engineers, chemical engineers, metallurgists like me, which is why it's called the Society of Geoscientists and Allied Technology. So I come into this fold as an allied technologist. So it is the question of the tail wagging the dog situation, where the allied technology is the president right now, not a geologist. But we are all together, as I said, unless we all work together. Thank you very much that you are all here. And I'm grateful to all of you, the delegates and the steel plant chiefs who are here. And I'm sure this will be a rewarding experience for as much as for the delegates as it would also be for all the members of SGAT. Thank you again.
I would request Dr. Debashish Bhattacharya to present your invited talk. Please, Debashish Bhattacharya, please.
Others can't see.
We just only you can sit down here. That's it. We you sit down there, you want to take charge here. And the other we can see.
Yeah, I'll use that. So, Dr. Mohanty, Mr. Mohanty, flanking the screen. Hi. Mr. Bhatnagar, Mr. Rajiv Kumar, Mr. Patnaik, Dr. Ramanuj Narayan, Dr. P.K. Banerjee, Mr. Farooq. Friends, a very good morning to all of you, and thank you to SGAT for inviting me here and giving me the honor of making the first invited speech today. So it's a real honor, and you said tail wagging the dog. This is, I don't know what, the tip of the tail wagging the rest of the elephant, in a way that a metallurgist is taking the first talk of a geologist forum. So I'll have one slide on geology. I promise that. So that way I sort of get a honorable entry into the forum. But before I move on, I must say that most of what I will talk is known to people. Dr. Mohanty has spoken about hydrogen. We all know about the need for decarbonization. So there may not be much new, but maybe what I'll talk about will throw a new perspective on how difficult this hydrogen CO2 affair is in the world, and what do the numbers look like. But even before that, what I'll talk about is, when I speak on these things, many people in the audience, including some of the board members in companies, say, really, is this happening? Is this a ruse? The world has been warm before. So what's new? So I'll start by quelling that doubt. You know, the world is becoming warmer and uncomfortable human habitation. Yeah. So that's what I will start with. And you know, we always prepare our slides at the last minute. I prepared in the last 1 hour, so I was better than that. Which means that some redundant slides appear, and the first one happens to be a redundant slide. So I'll quickly try to skip over that, and it doesn't work. Yeah. Oh, it skipped over. Very good. That shouldn't be seen. Yeah. So you've got a preview to my next slide. You know, mass extinctions happen. And the Earth has seen several mass extinctions over the last 500 million years. So it's nothing new for the world. And every time a mass extinction happens, about 70–80% of existing living beings get obliterated. But what replaces them, I don't know if they're better, but definitely larger in number, larger in diversity. And after every mass extinction, exactly the same thing has happened. More number of species and families have come in. The humans came in after the last one, after the one at 60 million years ago. So which means we, in a way, need to thank mass extinctions that we exist today. Now, one of the features of a mass extinction is rapidly number of species and genus and families start to disappear. And this is what we are seeing today. If you look at across living beings, fish, reptiles, birds, mammals, amphibians, I've just put dodo as an example because everyone knows the dodo or knows about the dodo. There is an acceleration in extinction of families. It's not just one species or one genus. It's a whole family of animals that are getting rapidly extinct today. So this is a question that I keep getting asked. The Earth has been hotter before, so what's new? But it has been hotter, true, and that's when humans didn't exist. That's when the dinosaurs existed, right? And of course, at that period in time, you could across the periods of time, you could correlate temperature to the CO2 level in the atmosphere. And in around about 60 million years ago, Earth was hot, you could see alligators on the north and south poles. But the Earth gradually cooled down, and roughly about 800,000 years, 100 million years ago, it stabilized at a carbon dioxide level of about just less than 300 ppm, which is not much, 300 parts per million. And okay, where should I point? There I should point. And if you trace the temperatures of the last 800 million years, you'll see the temperatures have cycled, and the temperatures have cycled, and so have the CO2. And these CO2 measurements are made from ice core samples from the Arctics. So you know exactly what the CO2 was at a particular time in the history of the Earth. The CO2 level has always been less than 300 ppm. It's only in the last 100 years, roughly, that the CO2 has started increasing rapidly, and it correlates very well with industrial activity of human beings. So much so that you can see the rate of acceleration. Today, as in maybe last month, it was in the news, it has reached 450 parts per million. Doesn't sound much, but it is way above what was comfortable for human beings on Earth and life form as we see today on Earth for the last 800,000 years. It's highest. So things are changing, and things are changing to be uncomfortable for human beings on Earth. And we are leaving a permanent footprint on Earth. As you look back, and this is my geology side. There are geological timescales, and there are stamps for geological timescales. You know that at a particular time, certain things happen, certain sediments have certain characteristics. We human beings are leaving our fingerprint in our time scale. We are leaving plastics behind, which will take Some of them will take millions of years before they ever, if ever, they get obliterated. We are burning fossil fuel for power, which is leaving fly ash, which are getting deposited under the lakes and ocean, and they are leaving a permanent footprint on Earth. The nuclear test that was done, most of you must have seen Oppenheimer. That was done in US. The first nuclear experiment was done in the air. It was not done underground. Plutonium traces of that are found not just in the vicinity, across the world. That is a fingerprint that we are leaving behind. So now, technically and acceptedly, we are in the Anthropocene geological area. The Anthropocene is marked by plastics, marked by nuclear waste, marked by fly ash, and marked by fast increase in temperatures and CO2 levels. So, ladies and gentlemen, that we are entering into a hot phase is fact. And because of human activity is fact. So let's not be in a doubt that we have to do something for us, because the Earth takes care of itself. It has seen multiple extinctions and it survived. It even flourished after each extinction. The species that were existing at that time did not. So human beings may not survive a mass extinction. The Earth will. So what we do today is for us. Earth will take care of itself. Okay. So this is the scenario as painted by various bodies. In order to maintain a 1.5 degrees centigrade stability by 2100, we need to come down to 0 gigatons of CO2, man-made CO2. That's not going to happen. That's given. That is not going to happen. It is now given that we will have to strive towards a 2 degree, which means we will have to stay, is it? Yeah. At about 50, today we are about 34. So allowed to about 50 gigatons. It's not going to happen. What is more likely to happen is about 100, and an accepted temperature rise of about 2.5 to 3 degrees centigrade. And symbolically, the effect on human environment is picturized there. I mean, there'll be less vegetation, less green, more hot, more need for water, discomfort for human beings. But if we do really not much, the temperatures are going to go to 4 and above. And that's when things get really troublesome for us towards extinction. So we need to make efforts to restrict to about 2.5 degrees centigrade. 1.5 is out of question, won't happen. So can we restrict to 2.5 is the question. Now, much of it is because of, as I said, human activity. And human activity today gives about 34 gigatons of CO2, largely coming from power, from automotive, from agriculture, industry, etc. Now, we know that the world has a technology solution in power and automotive. So you can see that number of electric cars is going up, assuming that the electric cars will be driven by green electricity. And batteries will have green components inside, and assuming that much of grid electricity will be green as well, and we see the cost of green electricity coming down, renewable electricity surpassing fossil-based electricity in many countries, it is safe to say that power and transportation have it sorted out for the next 25 years. Over the next 25 years, by 2050, largely transportation, other than air transportation and power, will have reduced their CO2 footprint. What would be left is much of industry, and some of the more difficult to abate industries are the steel, cement, etc., and airlines. So just to look at what happens to steel. So today, out of the 34 odd gigatons of of CO2, man-made CO2, steel makes about 3.6, roughly about 8-9% of 10% of the man-made CO2. And as I just said, power and automotive would have sorted themselves out. There'll be other other sectors also which would have become greener. So the overall footprint of CO2 would have come down by 2050. If it is business as usual for steel, we would be 40% of man-made CO2. Now, I don't think society is going to be very benevolent on us at that point in time when it sees that one particular industry sector is giving 40% of human-made CO2. So it is absolutely imperative that sectors such as us, steel, do something today so that over the period of the next 5, 10, 15 years, we are able to put technologies and policies in place which will enable us to reduce the CO2 footprint. Now, if we go further down, just bear with me, some part will be a little technical. I'll try and be as simple as possible. So today the world makes about 2 billion tons of steel. The largest CO2 footprint amongst the many technologies of steel production is from the blast furnace basic oxygen steel making route, which is in short called the BOF route. Roughly, you can see from the graph, don't need to look at the numbers, just the graph tells you the predominance of the BF-BOF route in CO2 footprint. The other predominant route is the electric arc furnace route, which, given green electricity will come in the future, will have a very small CO2 footprint. So our focus is in BF-BOF route. And this is the one slide primer for iron making, after which there will be a quiz. And you need to answer all the questions correctly. Now, I don't think we will subject the audience to that. So the crux of the BF-BOF route is the blast furnace, which is in the middle. The feed to the blast furnace is coal and iron ore, essentially. Coal is put in either as very fine ground coal through the bottom of the furnace, along with air, oxygen, and some lump coal in the form of coke, not drinkable, from the top. And that reaction happens. So the coal, the carbon in the coal takes the oxygen from the iron ore, gives iron, and the result is, of course, the CO2. So essentially, this is what causes the problem. You're taking oxygen out of iron oxide, producing iron and CO2. So obvious answer to all the problem of CO2 is to replace carbon. If you find something that is equally efficient as carbon, can we replace that? And of course, the whole world is looking for the alternate reductant. And Dr. Mohanty mentioned it is commonly hydrogen, could be others also. But then we don't stop thinking of only replacing carbon, because what happens? What is plan B? What if you can't replace all the carbon? And you can't, right, in the blast furnace. So while there is a carbon direct avoidance route, where you avoid the direct carbon through alternate fuel injections, any carbon dioxide that is coming out can then be thought of as being captured. But once you capture, what do you do with that? You use it to fix the carbon dioxide. And in both these sides, whether it's on the feed side, you need hydrogen, as Dr. Mohanty mentioned in his opening speech. And on the other side, on the carbon capture and utilization side, you need hydrogen for utilization of the CO2. So there's a lot of hydrogen needed, ladies and gentlemen. And we'll see what are the bottlenecks in hydrogen. And of course, there are other routes, such as use of scrap, use of other iron making technologies. And we'll talk about it a little bit, not much. So this it looks like a complicated diagram, but this is one diagram that gives you the status of all carbon direct avoidance routes in existence today and their technical maturity. So this is the, if you go from the center, outward, so from blue to gray, you grow from lab scale to almost near implementation scale. And this rainbow is divided into three sectors. The makeshift sector, which is very easy to implement in an existing plant and existing setup. Retrofit, which would mean some modifications are required in the existing setup, so maybe some additional equipment. But the existing setup remains. And transformational is you need entirely new setup, entirely new plant, a new technology. In the makeshift, as you can see, most of the technologies that are being talked about today, that is use of scrap, use of biochar, use of hydrogen in blast furnace, use of coke oven gas in the blast furnace, and what I've not put here is even DRI, are in a more mature stage. And we all know that. In the retrofit, something like easy melt, which is dry reforming of methane using coke oven gas, is at a more demonstration level scale, not at a high level. And in the transformational, which will actually change the face of iron making in the world, such as molten oxide electrolysis, electrowinning, Helios. Helios is a sodium-based reduction technology. Who said hydrogen is the only other reductant? All these are at a lower technology readiness level. So you can see that what you can implement quickly today are more in the makeshift area, but then they have lower efficiency of potential reduction of CO2. So as you move from left to right, the potential of reduction of CO2 increases. So there is no clear winner here. You have almost ready to implement technologies, but they have lower efficiency of CO2 reduction. You have high efficiency of CO2 reduction, but they are 10, 15 years away from full maturity. Given this, it is obvious that you cannot replace carbon in a blast furnace. You will need CCU and S, that is carbon capture, utilization, and sequestration. We will talk less about sequestration because I don't need to explain sequestration to the audience here. Geological formations that will enable sequestration are not proven to be in existence in this part of the country. So let's forget about sequestration for now. Maybe next year when we talk about this, people would have new insight and we would be talking about sequestration. But till then, we will talk about carbon capture, utilization, storage, etc. And there are multiple ways by which you can do CCU, which is use CO2 to methanol or ethanol, CO2 to syngas, or mineral carbonization, where you put CO2 into slag and make an aggregate which will replace cement and concrete. You can make carbon forms out of CO2, which are more valuable and can be used in electric batteries, electric vehicle batteries. You can do artificial photosynthesis, so on and so forth. Now for all of these, or except for the mineral part, mineral sequestration part, where carbon dioxide is fixed in slag, you will need some sort of organic molecule to be formed. For any organic molecule to be formed from CO2, you'll need hydrogen. And this is perhaps the most basic of the things that you can form, is methanol. You'll need catalysts and temperature and pressure and all that. But important thing to note here is that if you do the basic chemical calculations, 20 odd million tons of CO2 to be captured as methanol will need 3 million tons of hydrogen, green hydrogen, ladies and gentlemen. And 22 million tons is what a 10 million ton plant produces. Any 10 million ton plant, if you're going to capture that CO2 and make methanol out of it, will need 3 million tons of green hydrogen. How much is that? Today, the world produces 3 million tons of green hydrogen, the whole world. That amount of green hydrogen will be needed by one 10 million ton plant if you want to use CCU for capturing all the carbon dioxide. So here's a bit of insight into what these numbers mean. And I've just taken a 2030 scenario. And I just assume that blast furnace BOF route will be about 175 million tons in India. You may argue that it will be 200 or 150 or 250, but let's take 175 million tons of BOF route in India by 2030. It would mean at the rate of 2.3, and I assume a lot of improvements would have happened in the plants to reduce CO2 incrementally, will be about 2.3 kgs of CO2 per ton of steel. Actually, it's not kgs, it's tons of CO2 per ton of steel. Sorry for that mistake. So roughly, India will need about 400 million tons of CO2 to be handled. Now assume that by 2030, of course, national target is not zero. So the national target is 0 by 2070. Some companies like us have taken a target of 0 by 2045. We will not suddenly achieve 0 in 2070 or 2045. We will have a roadmap to go to 0. So we'll have a target of, say, 1.8 by 2030, which would mean 315 million tons of CO2 to get to net zero. Oh, to get to 1.8. So which means by 2030, we have to abate 85 million tons. This is not net zero. Net zero would have been if you take 1.8 all out. Yeah. So 20 million tons, and I assume by carbon direct replacement, which I showed earlier, all the mature technologies come in place. So roughly about 5% of your CO2 gets addressed by the mature technologies. 20 million ton will be addressed. You still have 65 million tons of CO2 to come to 1.8, not 0. And that 65 million tons will take 9 million tons of hydrogen, green hydrogen. 9 million tons of green hydrogen at $2 per kg. And it is not $2 per kg today, it is around $6 per kg today. Assume it will become cheaper. $2 per kg is $18 billion for all of India. The meaning is, by 2030, just to abate enough carbon dioxide to get to 1.8, India will need all of world's production of green hydrogen. And it will add about $100 per ton to the cost of steel. And this is only cost of hydrogen, not the cost of making methanol, not the cost of storage of hydrogen, and not any other costs. So you can see how much feasible this is. So obviously it is depending only on hydrogen is not feasible. So of course, our efforts will be on multiple fronts. Some, the usual suspects, like use more scrap. And of course, as a country, we are limited by how much scrap we have. And as the world, and the entire world will face the same problem with green hydrogen, limited availability. So scrap will be in demand, and therefore it will be premium commodity. You'll have natural gas-based DRI and EAF. But then as soon as you go to DRI and EAF, you need high quality ore. Again, a supply issue. You will probably go to then DRI and a remelter with a BOF. So the remelters are small scale today, maybe suitable for ferroalloys, but not at the tens of millions of ton scale of steel. So need scaling up. Biomass is an issue of supply again. So all the commonly known usual suspect technologies are limited somehow or the other, right? Which would mean you need new levers. I've run out of time, I guess. Yeah. The world is running out of hydrogen and now we're running out of time. So essentially, working on new high efficiency electrolyzers, maybe 100% efficiency electrolyzers, looking at cheap storage and transportation of hydrogen, alternate ways of CCU and S. So today, we, for example, today spend about 200 crores on just looking at these alternate routes. Some examples: coal bed methane in blast furnace, hydrogen in 40% through 40% of 2 years in a blast furnace, use of biochar through PCI, and some of these experiments have been done in the plant of Mr. Rajiv Kumar here. We're looking at alternate routes to production of hydrogen, non-electrolyzer route, such as chemical looping technologies. And we are looking at storage of hydrogen. We often ignore the cost of storage of hydrogen. How do you store hydrogen? Either as liquid hydrogen, it is minus 235, which means energy and cost. Or you store as pressurized hydrogen gas, which is again cost 700 bar. Or as liquid ammonia, which is minus 32 degrees centigrade, again cost and highly poisonous. So today we are working on technology that stores hydrogen in a bicarbonate formate form using a catalyst. And this way hydrogen can be stored in a non-poisonous way at room temperature, at normal pressure, and can be carried in a jerry can, right? So that pilot plant is now coming up. So this is the CCU pilot plant. We've got the data and we're ready for the next scale up in Kalinganagar. And of course, all these technologies need money. Not only will the CCU, when it comes up, need money, but building up to zero CO2 will need money. And of course, it will need a whole policy change and a new policy framework. And I'm not going to go into the depths of it. I've run out of time. So I think enough will be said in subsequent lectures. I've seen people will be talking about on these topics. So I'll leave it to them to elaborate. Just as a conclusion, so technologies to decarbonize steel are not fully mature yet. Yeah, whether you talk about the usual suspects or the new technologies, they both need investment to be worked upon and made full scale. In the meantime, the steel companies will need to depend on incremental reduction of CO2 and yet seed ideas and bet on range of technologies that will be emerging for the medium to long term. And in these bets, they are bets. You don't know which one will actually succeed. So decarbonization will need technology, it will need money, and it will need a policy framework. With these, ladies and gentlemen, thank you very much for the invitation. Sorry for overstepping, and wish you a great conference today.
So, ladies and gentlemen, we were treated to a very authentic talk, internationally authentic. So that's actually the picture. It looks very grim, but that's the true picture. We will have, now you take over. The announcement is we are switching over to the power transfer. Have you switched over? Okay.
Thank you, Dr. Debashish Bhattacharya, for your brilliant talk. Our next invited talk is by Mr. Rajiv Kumar Bhatnagar, Executive Director of ArcelorMittal Nippon Steel. Mr. Rajiv Kumar Bhatnagar, please. Safety first.
Good morning, ladies and gentlemen. Our chief guest, Mr. S.S. Mohanty, my old friend, Dr. Farooq, Dr. Mohanty, Dr. D. Bhattacharya, and all the esteemed great personalities who are sitting here, who've been working in the field of metallurgy, geoscience, mineral technology, and so on. At the outset, I feel a little concerned because it's very difficult to speak on a technical subject after the speech of a renowned R&D chief, and that too of Tata Steel. So I'm really humbled, but at the same time, I'm very conscious. I can't because I am a person who's been in the firefighting of production most of the time in the projects. But I really appreciate Dr. Bhattacharya. That was a wonderful speech and a lot of knowledge. But this also takes me to some thoughts. I think Dr. Mohanty mentioned about why he chose his own house rather than Mayfair or Trident or something like that. I can assure you, Dr. Mohanty, at least I feel, my team, we all feel much better here compared to a 5-star hotel. I think we all agree. The second thought that I got before I start off with my presentation, I just got reminded of our own teaching from our own God in the Vedas and Srimad Bhagavad Gita. This, I just was trying to correlate with when Dr. Bhattacharya was mentioning about extinctions of various species. One day I was playing a quiz with my grandchildren. I said, can you count how many species you know? And so, and then you start writing. So, sher, cheetah, bhalu, admi, you keep writing. I think all of us together can hardly reach 2,000, maybe 10,000 maximum. But Bhagavad Gita says there are 8.4 million species, 84 lakh योनियां, और उसके बाद हम लोग शायद human being बनते हैं. But I never realized, I mean, I have done a bit of reading there. I never saw that Lord Krishna mentioning about extinctions. But surely, on a serious note, I think there is a subject in biology and botany, people work research, and I found in some literature that by now 3 million species have been actually identified by the scientists. They are yet to find balance 5.4 million species. And there are some 20,000 species on a day basis which are being registered in that field of science. So it's really very interesting. And I sometimes feel that so much that we are talking about CO2, global warming, etc. Is it really a subject of that importance? I'm sorry to mention, but I mean, I think particularly after, we get more and more knowledge from other planets, satellites like Moon and Mars and other places. If there is a shortage of oxygen in Earth, maybe by that time I mean, as Dr. Bhattacharya said, it'll take as of years to reach to a level. If you have to contain up to 1.5 degrees of rays and not go to 2 or 2.5, as you have, I mean, I agree with you. At least on today, we do not see what is going to happen in the whole civilization. But anyway, I think there is a limitation of time, Dr. Farooqi, so I'll come to steel and what small initiatives that we are taking in our company. Of course, just to give you a bit of word scenario, this is a slide which says that that currently countries accounting for more than 90% of world GDP have actually committed to net zero by certain years. It's maybe 21. Okay. This one to forward and this one to reverse. Right. Okay. No, I've got it. So I've got it. So, yeah.
Very feeble.
It's okay. It's okay. So it's working. Don't worry. So anyway, I'll continue. So, and these 93% of global GDP countries actually account for 83% of global emission. And just to give you an idea as to what other countries are doing, what is happening, etc. If you see, this is a pointer. Yeah. So there are just 2 countries in the world. Bhutan is one of them over there, blue, which has actually achieved net zero. They never had carbon, I think. So, so anyway, yeah. And the EU countries are particularly 42 countries which are in law. What it means, it's shown in purple color. Australia also. What probably it means is that there is only well laid down policy law which restricts you to achieve certain levels. So that's where. And then green depicts in policy document, which is India is also part of it. So there are 50 such countries in South America and of course China, India, and Asia. So these are the countries where there is still not a fixed law, but the legislation is under making. But there are policy documents which are either there or which are getting developed. And then, of course, there are 60 countries, if you see, who have still not reached to the level of any commitment or any kind of, legislation, etc. Mostly in, in African continent. And then, of course, Mongolia and some other countries have no target at all as of now. Moving forward, just like to give you a global overview, emissions from the steel industry, because our topic is steel and we are all steel makers sitting here. Emissions for the steel accounts for about about 7% of global emissions, and Dr. mentioned 8 to 9%. Of course, it could be true. So we are somewhere there. And steel industry emissions strongly concentrated in Asia, more than 70%, with China accounting for 55%. And you can see that more or less it is in the same ratio, the share of global steel production and share of global steel emissions, except some variations. India happens to contribute to 6% of global steel production and 6.6% of global steel emissions. Of course, whenever we talk of per capita figures for India, we have a very sorry figure, because our per capita consumption of steel or power or anything per capita GDP is very poor. But this is one area where we are good. Per capita emission, if you see, in that sense, I mean, it's in a lighter vein, I think we do well there. Anyway, so yeah, so this is going forward with our target of reduction. I thought we'll just talk about 5 key stakeholders who can or will press steel industry for decarbonization. So this is regulators, investors, lenders, consumers, and industry peers. We are somewhere here. But government will have to have a very, very important role, particularly when we talk of how much does it cost to reduce 1 ton of CO2. Dr. Saab has already mentioned, very, very scary figures of cost of hydrogen, etc., which are there today. But we expect to improve. Investors are very, very conscious of taking decisions of major funds, banks, and high net with individuals, etc. Lenders are now looking at their credit portfolios, potentially making access to resources more challenging, because they would lend to people who commit some level of carbon, etc. Consumers, prominent industry consumers, have their own decarbonization commitments and will be urging the suppliers to reduce their scope 3 emissions. So we talk of Tata Motors or Suzuki or any customer which a steel industry has will also have started demanding. So here, multiple industry players are set to compete in the decarbonization race, with the possibility of gaining a first mover advantage. I think for the governments, if I may just say that governments can act via incentives and market regulation to ensure competitiveness. So when we talk of incentives, funds to foster technological development and technology deployment, which can be incentive or support for specific projects. These are, and in market regulation, CBAM and quotas, this is carbon border adjustment mechanism, which creation of import tariffs. So some countries will start probably restricting imports if you are not a green steel producer and things like that. So these are some of the market regulation that government can bring about. Then for the industry, I think initiatives from producer and value chain stakeholders, steel producers will have already set some targets in India, and emission reduction levers we have to identify, investments in greener substitutes. There's a long journey, but I think the journey has begun in most of the steel plants. Then suppliers and consumers of the steel value chain, commitments with impact on the steel industry, partnerships for solution development. So these are the issues. Now, this is a picture which just says that globally, steel producers are announcing emission reduction commitments. I've just taken a few, global steel companies, and as you see, the ArcelorMittal group has committed 35% reduction in CO2 and to reach to carbon neutral in 2050. And then accordingly, other companies, Saab, we were talking about SSAB in the beginning, Baowu, POSCO, Tata Steel, and finally the ArcelorMittal Nippon Steel India, which is what today we thought, and Dr. Mohanty requested that we could just discuss a bit about what is being done in AMNS India. So this is all about it. Then if you see we are looking at these levers, we are assessing the sustainability potential in each part of the value chain, which is increase scrap share in EAF and BF, BOF. This has been mentioned already. In raw material, replace PCI with charcoal in the furnace. This was also talked about. Then use charcoal to make coke and use hydrogen as a reducing agent in BF. Now, of course, there has been a lot of talk on these subjects. I would say till now less of action, but yes, at least we are moving in that direction, and there is more and more knowledge every day. Renewable increase 100% renewable energy use, and production mix and new technology. That's another area where migrate production from BF, BOF to scrap EAF. And of course, I've written down some constraints which we can discuss. Migrate production from BF, BOF to DRI EAF with natural gas, and then migrate production from BF, BOF to DRI EAF with hydrogen. Switch natural gas to hydrogen at DRI plants. And availability of economical H2, as was mentioned, is a big constraint there. Install CCUS technology. And finally, increase energy efficiency. This is a subject which I think all of us in steel plants know very well. So increasing efficiency, energy efficiency, when we talk about it, sorry, I think, where have we gone? Yeah, okay. I got transferred to Tata Steel for a while. I'm sorry. Collaboration, yeah. Yeah. Now, I think by the time this happens, I really sincerely feel from my experience that all the technical people in all steel companies in India should actually talk a lot with each other. Leave aside the marketing and purchase guys, then there are some secrets and this and that, but on technical ground, we don't lose anything. We just gain. That's an important thing. So anyway, I'll continue talking from my notes. Okay. Yeah. So energy efficiency, when we talk about it, I go to the next slide. Increase scrap. Are we there? No. I think there was one slide which is. Okay, I'll. Oh, this has come, I think, earlier. Okay, fine. So increase scrap share. Okay, so there are some scenarios which emerge over here. One is economically viable with current technologies already available at scale and incremental operational improvements. Then subsidy in DRI NG plants, subsidy in CCUS plants, and economically viable hydrogen. Now, at AMNS, of course, with the help of all continuous improvement initiatives, our decarbonization strategy is aligned with the ArcelorMittal Group and Nippon Steel and India's energy transition ambitions. So from 2015 to 2022, we have already achieved 33% reduction in AMNS, and this journey is going on. Levers which are already in action are process optimization, all BATs, advanced digitization, energy recuperation, and increase scrap usage step by step. Then more than 45% of our power from renewables in medium term and 100% in long term. This is something which we feel is doable, achievable, and we can see how to do it. So that's, and then fuel substitution, natural gas injection in BFs, coke oven. We started natural gas injection in BFs some time ago, but then again, you know, all these things depend upon the cost of natural gas and etc. So sometimes you have to change that. Now, see, we are also connected to ArcelorMittal at the corporate level in terms of key initiatives that AMNS India is taking. So some examples of projects which are already in progress is one is in the France, where implementation of EF unit and DRI with hydrogen in Dunkirk plant. Here we target 40% reduction in CO2 per year by 2030. In Italy, there is a move to build EF plant of 2.5 million ton. This plant was running with the blast furnace. In Spain, this is a very ambitious project, which is targeting reduction of 4.8 million ton of CO2, the 50% of Arcelor's total in Spain by decarbonization in the ArcelorMittal plant in Lyon, being the world's first net zero large scale plant. That's the ambition. Then development of DRI demonstration plant with hydrogen in Germany. In Belgium, we have a Stylanol, a flagship project in CCU. The carbon rich waste gas from BF is used to produce ethanol. Coming to India, green and renewable energy projects in Andhra Pradesh, Odisha, and existing plant locations. In Andhra Pradesh, we have already moved ahead. In Odisha, we have signed MOU to make 3 gigawatt of power through floating solar. So this we are targeting reduction of 1.5 million ton of CO2 emissions. And finally, in Canada, usage of pyrolytic fuel in pellet plant, replacing part of the heavy fuel oil consumed in the plant. Now, having said all that, I would also like to highlight some issues and challenges that we face when we try to take some decisions on these fronts. Right now, we are actually facing a question whether to go for BF BOF route or DRI EF route in our Paradeep project, which is in the final stages of EC, etc. And it's a very, very tricky decision. I mean, just getting 0.4 million ton of CO2 per ton of crude steel off by putting DRI looks attractive, but then when you put DRI, you have to depend upon natural gas. Hydrogen is far away, I mean, as Dr. Bhattacharya mentioned. And the problem with natural gas is it is so volatile that, in fact, I don't know, maybe many of you know that why SR Steel got into so many problems in the past. One of the major contributors was, it was DRI based plant largely, and DRI was natural gas based, and natural gas spoiled everything. Of course, there are instruments like price hedging and those things available. I was just making a small calculation that if we are able to get hydrogen through a pipeline from Gopalpur, because incidentally, many of you may know that ACME has already entered into a journey, a contract, and they are going to put up a plant of hydrogen and ammonia where 0.5 million ton of hydrogen will be generated. So we're just trying to talk to and get an idea of how much it will cost and what will be methodology, etc. So Dr. Bhattacharya mentioned, I think we are assuming something like $5 or $6. And with that and with the specific consumption of hydrogen that we assume today in DRI, my goodness, the initial figures are coming to something like, I mean, north of 25,000 rupees a ton cost only of hydrogen. All other costs are separate. So, I mean, it's a nightmare to use hydrogen in this shape and size and price. But all the same, we have to make a beginning somewhere. So I think on a practical side, today for a new steel plant, choosing blast furnace looks to be a better option with lots of changes in the blast furnace, by which we can either reduce CO2 or capture CO2 and use. So that's the direction that we are taking. So much is being talked about. So many people are working on this subject all over the world. So it's a very interesting journey, and I hope we will get to the destination that we all want. Don't allow Earth to go beyond 2 degrees. That's what you mentioned. I think marine drive water will start flowing into into the houses if that happens. So with all that, I want to thank everyone that this has been a wonderful experience to share my experience, my company's experience, and thank you very much, all the esteemed guests, Dr. Mohanty. Thanks a lot.
Thank you, Mr. Bhatnagar, for attempting to dampen the fear that Dr. Bhattacharjee has generated. I request now Mr. S.S. Mohanty, our chief guest. I request Mr. S.S. Mohanty, our chief guest, to kindly present his inaugural address.
Thank you, and very good morning to all of you. It's nice to be here. When Dr. Mohanty invites, I think nobody here in the hall or anywhere outside also have any audacity to say no to him. So that is the respect he derives. And for the first time, I am very happy to be associated with SGAT, thanks to Sanjay and Dr. Mohanty, and coming to this hall for the first time. But I am very impressed, and I must thank all the SGAT members for doing it out and doing it in the hall. The third point is I want to tell you that basically I was seeing your SGAT bulletin. I mean I was also being a part of IM, decision-making authorities for last so many years, Indian Institute of Metals. We publish a bulletin known as transactions. I think everybody might have come to across, but transaction as such, when you started, it is an index of intensity of that has now gone almost to 1.6. It started with 0.6 now. When I see your SGAT bulletin, it's a very type of world-class bulletin. I'm very happy that this mass is doing so much things. I think what Dr. Mohanty we need to do is now this need to be publicized all throughout the Indian context. I mean, it's not limited to very few users. I don't know how many users are getting it now to a 10 of numbers, but it can go to a great extent. Coming to the today's topic, after so much presentations slides, and I was asked there is no slide from my side. So I'll be sharing with my all experiences for last 46 years of my industry in the steel. With a 1 year experience in steel industry with the private sector, then I joined in Steel Authority in 78. Mr. Bhatnagar is contemporary, he joined in 77. So from 78 to today, almost you can calculate out in the steel industry how many years experience. That's what I think I'm in today here. So I'm here after hearing from Devasis, from Mr. Rajiv Bhatnagar and Dr. Mohanty's contribution, and going through this this bulletin of seminar. I don't think I'm going to add any value to that, but that's why I decided to speak in extempo on my experiences on the journey where we have been trying our best to decarbonize the steel industry from right from the beginning. Let me just tell you that. Hydrogen was not, we are discussing hydrogen was not that an item or commodity that we are not producing. My first project in 1981, we started commissioning a hydrogen plant, electrolysis plant. 81, I'm talking about, not talking about. And we completed in 84. And that time we produced electrolysis process, hydrogen. And it is in 84 we started using hydrogen in steel making. This is not a steel making, basically a cold rolling process. We're using hydrogen as a protective atmosphere and a reducing atmosphere, both for producing a CrNO and to a part extent CrGO, which you are still discussing. So my old experience goes all belong to an 81 onwards, where we have an hydrogen today. But today topic is very relevant, that sustainable steel making and the future road. I believe that any steel maker who have been, as Mr. Bhatnagar said right from the beginning, have been also associated with steel right from the, from his own early career. We have been given a target that what should be our specific energy consumptions. And the specific energy consumption when you joined from as high as almost 7 gigacalorie per ton of crude steel, maybe more than that, to coming to almost an international level of 4.5 and less than 4, it's a huge transition. And when you're talking about the transition energy today, which is now buzzword for everybody, that we are in the transition energy transitions, I think we must now discuss many things from our side. What as a stakeholder for everybody to be able to help us. When you make a steel making as a whole, I think basically as a operation man, I can tell you, we divide into 3 phases. One is basically your iron making, steel making, and of course, your sap making, your rolling mill, or flat or long, whatever do. This is basic purpose of this. And if you calculate out the energy consumption of every stage, you'll find out you can always apportion to what extent your energy is consuming. And if you go there and the situation there, how much energy you consume up to blast furnace stage when you make a pig iron, and how much energy you consume at the steel making stage when you produce your steel, and at the end, how much the final or finished steel you produce for a flat or long, or maybe further use of the steel by end users. So I am here to tell you about when you make a system green, and we're talking about a lot of green initiative. I think, as rightly said, G20 has started today, and it's such a coincidence. And G20, one of the biggest, the agenda is today is energy transitions. One of the big topic of all the G20 heads are discussing energy transitions. Being a part of a CI and chairman of Odisha chapter, we have been always associated with B20 as a business 20, where we have 3-4 agendas to look after. Here we are talking very specific on the steel part of it. But when I talk about the energy transition, we are talking about, I think you heard about the energy part of it. Let me just tell you, as he said, about 34 gigaton equivalent of carbon dioxide being exposed to the atmosphere. And India gave us almost how much devices? Around 3 million, around 6 million gigaton carbon dioxide to the world. Then 34 is total. India's contribution is around maybe 6, maybe 3 or 3 to 4. What I'm telling is, imagine the steel industry as such in the world generates, which is 1.8 billion or 2 billion, whatever you now say it out, generates a revenue of a $1.5 trillion economy. It's steel industry as a whole. We're talking about steel as a whole. Of course, then out of steel industry, India is the second largest steel maker, though there is a huge difference between China and us. So imagine those percentage of steel. For 1.8, you are talking $1.5 trillion revenue. Depending on, there will be a plus minus here and there. We are also having that revenue generation of steel industry. But when you're talking about the energy transition from a fossil fuel to renewables, and hydrogen being made also out of renewables, it needs a huge type of a cost. And to give an idea, I think he was mentioning about what is the cost of a hydrogen what is the cost of a renewable cost, what is the cost of a part ton of DRA produced. I just given another very rough figure. In the Paris, summit, when we decided we should go by 1.5 pathway, which he mentioned about, and he also showed a figure of 1.5, 2.5. What is the reality and realistic figure? One thing I must be very clear about my experience and my expertise in the steel, that today, when we joined, we didn't agree. But today, I agree that steel can be produced without carbon. That is one, you can say how is possible, you can say theoretical, you can say thing, but it is basically in what cost, I will not discuss. But theoretically, steel can be produced without carbon. Now, having said that, I've accepted that. Now we are discussing many things, how to affect it. And we are talking about transition part, gentlemen. I'm not talking about the effect of today or tomorrow. So to bring that change of a COP26 agreement, and to bring that change of 1.5 over a period of time so that your carbon dioxide emission comes down, the rough figure says every year all the countries should spend around $4 trillion annually up to 2100. Today is 2023. Think about 75 or around 80. So you need a 80 into 4, around 240 trillion money to come to this. The 2001 you find, I'm telling 2070, 2050, 2045. I'm talking the entire world, because ecosystem doesn't come in the steel plant. When you start, I think rightly they were designed this seminar where they're discussing about the raw material first, then the steel making, then the end user, etc. And because from a SGAT point of view, it's a nice thing that ecosystem, if you're not making a green, making an isolated way, steel producer making green to whatever we're doing it out, you are not doing a justice to the climate. And what for we are talking about today is only climate change. And what we're talking about the temperature or water level going up, you're being flooded, so much of rain coming today and not having in August, and so much of disaster happening, etc., because of climate change, and we're worried. And that's exactly said. It was also the opener for knowing that extinction of species going up, and pretty well we also move here 70, 80 on, but the world also, the mass extinction of taking place. How many years I do not know, but COVID has taught us there is always extinction possible coming up. But what I want to tell you, the hydrogen is basically right now thinking of we are talking of a type of a savior for us for doing it out as the steel industry is concerned. But as I said, my purpose of saying, and almost in the government for almost more than 4 decades in the government sectors, I can tell you that the issue that what we can take off to the government and also a part of a CIA, what the stakeholders view we can take to the government where you can able to do something. I'm not going to any such a technical views on this. I can speak on extempo for hours. I can on the steel making each stage, what is the specific energy you can save it out. Already you have seen in the slides, in the existing blast furnace technology, BF technology, what you can save. From 8 gigacalorie per ton of crude steel, now if you're coming to around 5 or less than 5, in Indian context, 5 per 6 steel, and in the foreign complex, less than 4. It is huge changes. It is nothing hydrogen has come so far. It's our own way of doing it out. From the very fundamental thing that your energy is related to your emissions. Whatever you ask for the environmental impact, and you look for how much energy you are consuming. Any steel producer, any metal producer, that's it. And we have a very bad way of consuming more energy, and in steel that per capita consumption of energy, we always see the growth. But in steel industry, right now, and also from the day one, we have been taught how to reduce your cost of production, and cost of production comes down when energy comes down. And energy comes down, environmental comes down. When environmental impact comes down. When environmental impact comes down, carbon dioxide emission comes down. This is the story we have been doing for last 4 decades. But success you are now getting today in a very limited way. But the time has come now for all of us to really move ahead and do something. What are those we can do that? Number one is, at a policy level, I think we have talked about policy level, the India still doesn't have a law or legal binding on those towards the green productions or to the green awareness. We have making a lot of hydrogen commission, but I think in Europe, and as you said, government has already started making it, and United Kingdom is one of the first countries to make a law on the use of the green, and that's what we're talking about. You will find out today. I think the Rajiv is here from Tata Steel. You also got some aid for making it a green steel business in United Kingdom. Maybe whatever small way, but you are. Yeah, but not all that. But I think I was seeing some of the data of other companies also have now asked for started coming from different part of the Europe, and this CBM or trading and all are legal way of doing it. So today, gentlemen, one thing is very clear: the law is coming in any way. That's fine. That's what the government has to find out, and what best steel can producer can talk up. That we can talk up in a transition manner. I mean, in a phase-wise manner, what government and the stakeholder can work together to achievable without burdening the steel industry as a whole. Number one. Number two is basically, as I talked like that, what I have been contributing. I tell you, he has mentioned about SRTMI in your magazines, Steel Research Technology Mission of India, and here is the person standing before you who started and founded as the director and member secretary of SRTMI. The purpose for that time, I tell you, as Rajiv has mentioned, that when you talk about, we can friendly discuss about many of the technical subject, we can still have a confidentiality in the marketing and sales. But we started with all the industries together, and with all the stalwarts, we built up the policy and built a society, steel technology, and SRTMI, so that the industry's common problems can be solved. Like environmental issue. Environmental is everybody's. It cannot be a product specific to MNS or to Tata. I think two biggest steel producer here in this hall. We can always join together for a common issue. And here we are discussing today with the SGST collaborations, where collaboration is being discussed right now. And as if today, when you're talking about the COP26, is again a collaborations. One earth, one environment. I mean, it's not that if you are not doing it now, if you are not funding to African companies, countries, your environment is not going to clear. I mean, you can have your Indian way, leading way, somebody, UK or France taking way, but the environment doesn't change as a whole, as a earth. It will still an impact on the climate change, maybe in a very, not in a very accelerated way, but certainly it will have an impact. Now, coming to another point is, there is one as a policy law. Second is basically incentivize the R&D part of it. What we saw and what I've been told, I think there was very clearly a picture of that. The research and development in steel industry still, I can tell you, has not come to a level where the green steel making will make a commercial application in over at least a decade. So what is needed is a huge collaborative R&D efforts. And there actually you are nobody is going, because green steel making, I tell you, even if you make a law, you will try hard in your own internal resources from your company, but it's too limited, and paucity of the fund will always, debar you to look for R&D efforts, because R&D effort takes long time. So here comes the government, or maybe a combined fund can be a useful way. I think SGST can also be a part of it in making a policy decision, where you can come to the government. That's R&D for green steel making, whether it is a industry, whether it is academy, whether it is a research institutes, whether it is other stakeholders like governments and other institutes, can come together to look for towards an R&D efforts in different established R&D organizations. Devashish was heading R&D. I was also heading R&D of Steel Authority, which was the largest research R&D organizations. But I can tell you this, all said and done, the R&D efforts towards a common goal for the steel industry is not yet to find a place. And I can tell you this, another point I said, when I took the initiative for bringing around 35 educational institution R&D, along with the Ministry of Steel, Secretary of Steel being handing over to Ranchi for almost two days, to find a policy paper, how all of can combine towards some of the common issues like environment. And environmental, now we're talking about implementing a green steel. I mean, it's coming in a different way. But I'm talking about the ecosystem as a whole. Nobody can able to do any achievement. I mean, on the green steel part of it, we can able to steal a lot of papers, a lot of patents, a lot of deliberations. But I don't think you'll have a substantial gain in terms of this. Another good thing I will want to share you. You are talking about hydrogen. I think Mr. Bhatnagar told about the green hydrogen. I had a discussion with the industry secretary yesterday only. And we, in fact, a few days back, conducted one of the Pan-India Green Hydrogen Summit conducted by CII. You will not believe that Odisha has been almost declared as a hydrogen hub. Till yesterday, we have a capacity when I think the Devas told about that there is 3 million ton green hydrogen capacity available in the entire world. I think Odisha has now signed a contract for 3 companies, ACME and Avada and also the Renew, which is 1.5 million ton of green hydrogen in Odisha. Imagine. If you think of it's going to be a good hydrogen hub. So for the steel producer in Odisha, which are thinking will take to 100 million ton when 300 million marks come for the country, and we have a hydrogen available at least right now 1.5, you can go up to maybe more, maybe 3 million ton or 2 million ton, whatever maybe. And that's what the hydrogen will be available. Right now, hydrogen transportation, hydrogen storage, all the things been discussed. We can have a lot of research on also to find a way out. So that's a good point for the steel makers for green hydrogen. If you're looking for green steeling, greening the steel plants. Another point I want to tell about that when you talk about the R&D part of it, when you talk about the legal part of it, third, you talk about incentivize. That means when the industries are looking for investment in the green sector, can government come to capex? And green Odisha government is going to be a big way to take care of the 30 to 40% of the capex. Suppose you want to invest around 100 crores, they will go to 40 crores from their side. So this is huge fill up for the people who want to go to green sectors. And that's what I'm talking about. We as a whole must know these are available. And there are plenty of things when you go to hydrogen mission of India and the government of India is asking for it. Try to understand they are ready to give you some help in the effort that you are making towards. Even if as SGAT or any other professional body you can think of doing right from, as I said, the ecosystem, my ecosystem doesn't end with steel plants. I get raw material, I convert finished to it. I start from mines. What have been a greening you have done in the mine? What have been the transporting that you bring from green to this sector to my steel plant? What after I transport to the users? What has been user has been doing after in the green? On the ecosystem has been totally now being realized. Probably will not get the results. Maybe we may not be here, but I think people or maybe next generation can take up these ideas. We really want a sincere effort to do that. Again, the third point I just said about the incentivize. Fourth, we are talking about rightly said collaborative effort. All industry getting together and doing a collaborative research is a huge idea. And I tell you today, when you talk about this, there are people from other countries also being India's initiative, and they are also trying to fund. I think many people know not. There are many green bonds available. There are funds or private equities or strategic investors have come a long way to open the world. And so that if you want to have something in your mind toward the green sectors, you have somebody to finance you. I mean, you must know those resources where are. And these are available right now and coming. And another big awareness. We are not aware of it. So as a matter of fact, the green sector looks very, very optimistic, as I said in the beginning. I mean, very positive. And as we move on, towards greening the steel sectors, right from steel sector and or ecosystem like transportation, etc. As you saw it, steel, cement, and power. As for the industry concerned, they are the major carbon dioxide emitters. But another sector you talk about the transportation part of it, the mobility part of it. So there also, unless otherwise, and we have also a role, because when you produce 1 million ton, how much you start with, right from the 4 million ton here, and again transport by finished product to this. It's a huge ecosystem of logistics. I think Sanjay and others have been yoga sector also there. So keeping this view, my time to be limited. As I said, because from here we moved to another, mining seminar. I was thinking, being the chief guest, I take the liberty of from here, I finish, I go to the seminar, but then there are seminars available. But I can tell you that I must thank the organizer for organizing a seminar where the topic is very relevant and contemporary. And coincidentally, 3-4 things happen now. Basically, we were talking about he sort of very interesting slide on the part of the extinction part of it in Earth, and we discussed in this few days we put our Chandrayaan 3 in the moon. Okay, and again we sent our Aditya also to Sun. So I think, and now G20 discussing this. So it's a huge coincidence, I can tell you, Dr. Mahanti. I don't know how we fix the date, but it is a huge positivity for all of us. And we are in fact in a state like Odisha, where government of Odisha is taking enough care for apart from the metal and mining sectors, the ecosystem for metal mining sector also being addressed. That's what we are here today. And in fact, if SGAT has taken an initiative and the part of calling all the industries, and 2 big industries are being here, I can tell you the others will not far behind. But coming to challenges, as Debasish told about, and also told Mr. Rajiv Bhatnagar, challenges are plenty. I think, being a technical man, I can tell you technological challenges can be met. I think you can always put your man behind, some cost is required. People who can sincerely work on every plant has got R&D. Very sincerely, people are working something. But then how fast the technology mission come from ecosystem. So if you are talking about this, Dr. I think Omkar Mahanti, you mentioned about that. What is that? Oxide, the EMS. I mean, there is a molten oxide electrolysis. Plant. Next thing. So this technology, could you believe I think he can always explain it out. This technology is a new technology. Could you believe it out? A Boston Metal is a company which has taken a patent of it out and starting to do it out everywhere. They have a huge $1.5 billion of private equity fund and doing it out. But it's a pittance if you look at out. And the cost part of it, you look at out, as you said, mentioned, Mr. Bhatnagar told about, for a DRA going through hydrogen. But if you go for electroprocess, what do you call it? That oxide electrolysis, you just can afford it out. Okay. Where, unless otherwise you get a renewable power to tune of almost maybe 1 rupee, your hydrogen comes down to that extent. And all these things will come, and that one how to commercialize. So time has come now to collaborate each other. 5 points I wanted to insist. One is basically you look about the policies, government policies, laws. Second is go to put an R&D, which is again a huge investment, and go everybody R&D to do that, other will not reach. Third is basically, as I said, collaborative effort among those. And fourth, as I said, unless otherwise you share it out among ourselves, we are not able to get a benefit out of this. So, gentlemen, I just after seeing the all presentations, I thought I'll not repeat those things, and I took this opportunity to speak to you from my mind. And another point I wanted to tell you, when I tell you this, we are missing. I am representing a company today he's going for a $1.5 billion investment, SR, which is producing the pilot, and mostly for it is a challenging one again. Mostly a great percentage of DR pellets, not BF pellets. So when Debasish sort of blasphemous going for a center and others, I think right now we are pushing up what is that green feed that you want to go to the steel industry as a whole. See, unless you give a good green feed to them, and you got a green energy for your the EAF, and you got a green energy for other rolling mill, etc., your green steel is not going to come into picture. So with these words, gentlemen, thank you very much for giving an opportunity. Thanks to Dr. Mahanti and Dr. Farooq. I'm there to available to you to discuss being a part of this and staying in Bhubaneswar. We'll meet together again. I'll take this opportunity also, say, Dr. Mahanti, I'll come again and again this and see whatever we can do that. Thank you very much.
Thank you, Mr. S.S. Mahanti, for the encouraging words. We come to the concluding part of this inaugural session. I have just one little. Our president, I think you make yourself no, means in a position where you can. We have some mementos for our. Yeah. So if you come here, you can hand over to them. Yeah. Yeah. Yeah, yeah. Mr. Mahanti, please. Thank you so much. We cannot actually express in words, but just a token of expression of our gratitude. Yeah, next, this is Dr. Debashish Bhattacharjee. We cannot thank you enough for whatever. Yeah. And last but not the least, Mr. Rajiv Kumar Bhatnagar for giving us hope. Thank you so much. We now break for coffee, and in the coffee session, we give you tea free. Now, but then we have eaten into the time of the coffee break. Instead of 30 minutes, can we make it 15 minutes coffee break so that we have the rest? Yeah, up second floor. Yeah, third floor. So, yeah. Can I?
Hello.
আমি দেখে নেবো তাহলে হ্যাঁ নিশ্চয়ই মানে আপনি ঠিক আছে দেখে নেবেন
Monday.
Okay. Just have a couple of
Yeah, we are only 30 minutes. Why not? अच्छा, okay, technical.
Not technical part. I'm just saying, either Olga two presentation load.
नहीं, मैंने pen drive रे नेबे नहीं. We will email it. Eight.
Once let it start.
नहीं, आपने को तो अच्छी time अच्छी. Because after this session starts, I'll be free.
Because I don't know whether
नहीं,
I have
आपने को
carried the right memory stick or not.
Can you do me a favor? आपने
I think we should start now.
मोते मो लैपटॉप रे देखी तो हाँ. Good afternoon. We are now into this first session of today's seminar. The session is on raw material. We have got 3 presentations, and Mr. G.C. Das, former Director of Geological Survey of India, is the moderator for this session, along with Dr. D.S. Rao, co-moderator. Now, I will request Mr. G.C. Das to take over. Mr. G.C. Das, you come and invite the speakers and carry on with the session.
Thank you, Dr. Farooq. This is the first technical session. We are going to begin, though late. We are running late of time. So without wasting more time, I request Sri Vidyut Chakravarti. Hello. I request Sri Vidyut Chakravarti, partner, mining and metals, KPMG, sir, as the first speaker. Let me just briefly give his introduction to all of you. He is a graduate on mining engineering, and by practice have 22 years experience in consultancy advisory, experience in mining and metal industries, out of which he is serving in KPMG for last 16 years, focusing on mining metal segments. At present, a renounced partner in KPMG, assigned to look after the business in Odisha in particular, and advising in different clients in government, public sector, private sector, and both in India and abroad. The key area of work is on business transformation, business planning, digital enablement, policy decisions, cost optimization, etc., and performance and improvement and capacity building matter. Apart from India, he is also working on the above matter in South Africa, Tanzania, Zambia, Ghana, Indonesia, Kazakhstan, Brazil, and Bangladesh too. So he is the very key man on this first session, that is raw material. He will give you the scenario. I invite Mr. Chakravarti to the forum. Thank you.
Change it. This is the one. This is the one. So very good afternoon, everyone. Yeah, just a moment. Yes, thank you. So good afternoon to all of you. The first inaugural session that we attended in the morning was really very, very insightful from the perspective of, especially on the from the perspective of decarbonization of steel and the iron and steel value chain, from the very renowned industry specialists from two of the largest steelmaking companies and other senior industry experts. This particular session is going to be focused on raw material security, keeping aside the decarbonization needs, because India, unlike the rest of the world, is on a growth path. And whatever growth in steel, and I will come to the slides, that we are going to see in the next decade and beyond in steel capacity is primarily going to be driven by only one geography, that is India. The rest of the world is actually calibrating its production capacities. That's the reality of the world. Okay. So India is in a different trajectory compared to the rest of the world. So our challenges are different. At this point in time, our challenges are multifold. Everyone is talking about decarbonization, which we cannot ignore. But at the same time, we also need to meet our growing demand of infrastructure, the real estate, the transport infrastructure that we need to develop in roads, in coastal shipping, in port capacities, railways, the power, the oil and gas pipelines that we need to build, the water pipelines that we need to have in order to carry water to every household. So a lot of government initiatives are there that have already been announced, which cannot be ignored. And for that, one of the key materials is steel. So we need to add our capacities. So at one hand, we have to meet the decarbonization requirements of the world. We have to comply with the CBAM and the other guidelines that are coming up. And at the same time, we need to add our new capacities. Why it is not moving? The slides. Yes, please. This, yeah. Oh, okay. Oh, okay. Sure. Understood. Understood. Sure. So as you can see in this first slide, so before getting into the challenges that are ahead of us as Indian steel as an industry segment, and the way, what could be the potential way forward? Most of the things are probably known to all of us, but just to put things in perspective, let's start with a few numbers. As you can see, the global steel production in FY23, we produced somewhere around 1,880 million ton. And as the second largest producer, we are somewhere around 9 to 10%. China is definitely the dominant factor. They are going to continue to be the leading producer of steel for at least the foreseeable future, if not for eternity. Okay. Even if India meets its 500 million ton of aspiration by 2047, we can still remain the second largest producer, not being the largest at that point in time. Doesn't matter, we are the second largest, and our graph is only going to grow. But if you look at the overall
mix in terms of percentage as we move forward, and that's a projection till 2030. We are going to be hovering around 11%, 12% only. Okay. But we'll add significant capacities in between these 7 years that are going to operate in. So the next decade is going to be very, very important for us. It's not operating. So if you look at the steel demand forecast for India, in FY 23, our demand or rather consumption was somewhere around 120 million ton. That's the on paper number that we have got. And if you look at the trend of our economic growth, there can be debate around this, but to be on the safer side, 6.5%, and steel has a very good correlation to the economic growth. If we assume 6.5% of growth till 2030 at least, at a minimum, in order to grow as a move towards that 5 trillion economy, $5 trillion economic goal, we will be reaching somewhere around 190 million ton. That's going to be the demand by FY 30. Okay. So even if the NSP 2017 said that we need a capacity of 300 million ton by 2031 or 2031, not just 30, and our production capacity is going to be to the tune of around 300, whereas the consumption is going to be, or production is somewhere going to be 255 million ton, but our demand perhaps is going to be in the region of 190 to maximum 210. That's our estimate. And that's a calibrated estimate simply because of the fact, not just from raw material security perspective, but from two other lenses. And I will talk about it. One is the project implementation timeline that we need to keep in mind. And second is the money, that where does the money come from to add that much of capacity? Financing is one of the challenges. The second aspect is projected demand versus installed capacity. If you look at it, beyond 2030, it is going to be somewhere around 4.2% in those next 2 decades beyond 2030. And we will be, even if in order to reach that 500 million ton of capacity, our demand has to be in the region of around 433 million ton. So 180 to 433, that's a significant jump that we will have to create in order to create the demand within the domestic market as well. Because internationally, if everybody is calibrating its capacities all around, plus the CBAM and other guidelines are coming into play, so our opportunities to export steel and steel products is probably going to be challenged unless we also make significant progress in the decarbonization path and be able to compete with the other exporters of steel, okay, in the global marketplace to have a sizable share of the pie in the international market. If not, our focus needs to shift towards the domestic market, where we need to create new demand. And that new demand cannot be just from the large projects that the government has announced. It also has to be with the focus of downstream and ancillary segments, creating opportunities of further steel demand growth in the semi-urban and urban and semi-urban and rural areas in terms of new type of steel demand that need to be created. It is not just the wires and rods and pipes that will be in demand. It probably the prefabricated structure in order to reduce the infrastructure development timeline that has to have to create that demand, plus the other, downstream products that that the R&D and innovation can come out of, okay, in order to create the demand. Then only we will move from the 80 odd kg of per capita consumption towards that 233, closer to that particular goal. These are some of the announced capacity expansion by some of the steel majors, the ISPs that we have got from the secondary data. If some of the numbers are not just reconciling to your individual numbers, please excuse me on that, because we don't have the absolute insights about your exact capacity expansion status. It is based on secondary research. So as we can see, India is going to add significant capacity by 2030. But more importantly, as we are sitting in Odisha today, and we know Odisha holds more than 65% of the mining and metal assets of the country, it is going to add 60% of that planned capacity expansion in this state alone of the overall capacity that India as a country is going to add in the next 7 to 8 years. So that's the significance of Odisha and the raw material security needs of the state as such in the context of India. One important factor, and Mr. Bhatnagar and Dr. Bhattacharjee talked about the challenges around BF-BOF, the potential upsides on the path of decarbonization if we can move towards DRI, EAF, and the associated points. I'm not a technical expert in that, but the reality remains that the planned capacity expansion is mostly in the BF-BOF route. So our process route percentage mix, if you look at 2030, okay, is going to be significantly dominated by BF-BOF route only. Okay, we are not going to add significant capacity on the EAF side. IAF is anyway the GIGO route, as they say, which is predominantly dominated by MSMEs. And hopefully that will percentage-wise is going to reduce in the overall mix. Now, raw material requirement, and these are again number that I'm quoting from NSP 2017, even though we may have a little bit of different view in terms of various raw materials that is required based on the capacity expansion that we are seeing as against the 300 million ton that NSP had predicted. But if 300 million ton capacity is required, we will need around 440 million ton of iron ore, 160 odd million ton of coking coal, 136 odd million ton of non-coking coal, then 86 million ton of limestone, then scrap, in the overall mix that has been envisaged during the policy formulation was around 16 million ton, even though the current school of thought is that the scrap could be available in the range of 40 to 50 million ton by 2030. If we can work as per the steel scrap policy that is on the table, and we can create the requisite ecosystem at the state government level to collect the scrap and process the scrap and make it ready or available as a raw material for the steel making, for the steel plants to consume it as a raw material. Then, of course, ferroalloy and other refractories, which are in the tune of around 3-4 million ton. So iron ore and coking coal, thankfully, you are endowed with a lot of non-coking coal in our country, and the power sector is predicting its, and as the focus is shifting towards renewable more. So non-coking coal, even though the grade and the calorific value can be a point of discussion, but we are endowed with enough resources across the states. So the main focus of challenge is on 3 raw materials. One is iron ore, second, which is predominantly domestic for us as a source of supply. Coking coal, which is predominantly imports that we have been doing from Australia and otherwise. And the third element is limestone, which again, we are a little import dependent on the Middle East, okay, some of the countries. Keeping these things in mind, if we look at the various challenges that we are probably going to face, let's take up one by one. And I will try and wrap it up in next 5 to 10 minutes. Kindly bear with me. If you look at the overall iron ore production in the country, we produced around 260 odd million ton in FY23, where Odisha alone had around 140 odd million ton in the overall mix. As I said, around 60% or so, Odisha is not just in terms of resources and reserves, but also in terms of production volume that Odisha has been producing. And Odisha is going to have that significant chunk of supply, and mainly 2 districts, Sundargarh and Keonjhar. They have to cater to these needs of the demand, not only of the state, but for the larger country. And whatever then delta additional export potential, opportunities, opportunistically that we can cater to, to the likes of China or otherwise, we will be producing around 360 odd million ton, okay, by FY 2030, around 5% CAGR growth that we need to have. Now, production is one of the things that we need to make. And by deployment of MDOs or MOs in the iron ore mines, probably the production is not going to be a challenge. But it is the logistics or evacuation of such volume of iron ore to take out iron ore from the mines of Sundargarh and Keonjhar, the key districts of the country, and take it to other parts within the state or to the other parts of the country is the significant challenge that is ahead of us, even if we are in a position to produce that volume of iron ore. So that is one of the core challenges that we need to keep in mind. The second, of course, is known to us is about coking coal. We are heavily import dependent. We are not producing enough from wherever we have the resources in BCCL or CCL, that only 2 subsidiaries which are endowed with some good quality or medium grade quality coking coal, which we can make best use of. Unfortunately, we haven't been, whatever the fire issue or other issues that we have faced over the years, we have not been able to bring out any new mines or added any significantly new coking coal washery capacity within us to add to the percentage of domestic source of supply to the needs of the steel industry. That's the reality. So how we can reduce that dependence going forward is going to be another significant challenge. Now, if we look at scrap as a potential source of replacement for bringing down the iron ore demand, okay, to the extent possible, the projection is that India is probably going to have around 45 to 50 million ton of scrap that is going to be available, which will be a combination of home scrap, new scrap, and the old scrap. I'm not getting into the definition. I'm sure it is known to all of us. But primarily, the target will be the old scrap, that how do we recycle the old scrap from recycling of vehicles, the ships, or other white goods that are available in the marketplace, and bring it ready to the steel plants for usage. Of course, scrap has its own challenge as well, not just the ecosystem creation. There are some good quality scrap, but which are usually used with coatings, maybe zinc coatings or other coatings are there. So how do you process the scrap and then make it ready as a good feed for the steel plants is another challenge. Yes, there are plants that have been established by the likes of Tata Steel in Haryana, Punjab region, and there are other plants that are going to be picked up. But I think the scalability of establishment of such plants or aggregators as ecosystem within so-called highly within the states which have been the high consumers of steel over the years, where such scrap is going to be available, is going to be one of the key asks as we move forward. Steel scrap policy is definitely one of the good things that is there on the table, but how do we implement that policy is at a district administration level, and whether the state government can adequately incentivize to create that ecosystem is another thing that need to be considered. As far as limestone is concerned, we know we are a net importer of good steel grade limestone, in spite of having some large reserves. And there the problem is about having the right kind of exploration focus, by the respective DMGs of the states, okay, and bringing out new blocks on the auction table so that limestones can be made available to the steel players, and our dependency on imports can be reduced, to the extent that we can. This is one of the key enablers that the state government can play a critical role in ensuring raw material security as far as limestone is concerned. Other aspect is how do we make best use of the iron ore that we are producing today, especially the fines, because in the morning session also we heard that iron ore we have, but the good quality iron ore, okay? Because the quality of high grade iron ore is going to be critical if we are focusing the shift in technology, okay? That is the need. And we are not endowed with very, very high quality iron ore everywhere. It is in some parts of Chhattisgarh where NMDC has the assets as good quality. Some parts where Tata Steel is having the mines in Odisha is having good quality, which is blue dust or 65% plus and all that. But not just the Fe percentage, it is also the silica, it is also the alumina. At the end of the day, when you look at the TCO of the usage of iron ore, which has an impact on a cost basis to produce 1 ton of steel or the iron making process, it is not just the Fe content, the other constituents also play a significant role. So that is one aspect. The second aspect, that we are producing huge quantum of fines, and a significant chunk of those fines are in subgrade, less than 58% Fe grade. So in order to make best use of our resources, what kind of technologies we can bring in to beneficiate our ore and take it to 62% plus and make best use of that. Currently, Dr. Biswal is there. He is an expert on this particular area. But whatever knowledge we have on the table currently, that beneficiation as a standalone business is not a economically viable proposition today. So nobody wants to invest in iron ore beneficiation unless it is also integrated with the downstream of pelletization or sinterization. So more and more R&D, more money need to be put in order to bring out that right technology, so that what is the right kind of technology for beneficiation for our type of iron ore that we are having today is the need of the hour. We are having around 100 million tons, 80 to 100 million tons that we need to make best use of. What kind of technology is going to help us to make a better yield and make it more economically viable for us, and it may so happen we require a little bit of incentivization from the government in order to get money into this particular business segment, so that people take interest in iron ore beneficiation. So technology, R&D and innovation plus incentivization may be the way forward in this regard. In terms of logistics, now don't get to the headings that I'm not suggesting everywhere slurry pipeline is possible. I understand the challenge around the water availability for that. I understand the challenge around the right of way. That is going to be a bit of a challenge. But slurry pipeline should definitely be considered as one of the good options, especially not a standalone slurry pipeline for your own mine to your own plant. Maybe government can play a pivotal role in terms of anchoring the initiatives of the requirements of the likes of JSW, AMNS, Tata Steel all put together, and can create a common slurry pipeline that is possible. Okay. Of course, the first mile and the last mile need to be different, but otherwise the main, trunk way, okay, from a particular point to a particular point, okay, that can be a common slew of slurry pipeline that can be created. That way, the zigzag patterns of slurry pipeline creation, multiple right of ways, multiple local pushback from people and managing that ecosystem, that difficulty can be avoided. That can be considered. Coastal shipping is definitely one. Good part is that many of the new proposed steel plants are going to be located near some ports, be it Paradip, be it the other ports that we have in the country. And hopefully that will reduce the dependency on rail, as ecosystem. That is another thing that we need to keep in mind. Cost-wise also it is beneficial, we all know that. Now, this is not bits and pieces of solutions that need to be thought of. And I know for a fact, because luckily I've been part of that exercise, that Odisha government in particular has prepared a strategic roadmap looking at the demand of iron and steel in the state and the larger country, okay, especially for Sundargarh and Keonjhar, that what kind of evacuation infrastructure augmentation that is required for road, rail, slurry pipeline, coastal shipping, etc., keeping in mind the demand that is going to come in 2030, 2040, and even 2050. So similar kind of strategy plan that need to be created for the key states like Jharkhand, Karnataka, Goa. Goa is luckily is having, I mean, from logistic point of view, is not that much of a challenge, and it is low grade iron ore. But especially Odisha, Jharkhand and Chhattisgarh and Karnataka need to come out their own strategic roadmap for resolving this evacuation challenges. And then, of course, have a kind of a mission level PMU kind of an approach in order to implement those projects by working closely with the NHAI, with the state PWD, with the respective the regional railways and the other ecosystem players. Then only these things can be resolved. Otherwise, everybody will have to find their own solutions, which is definitely not going to be optimal. Last slide for me, but I think very, very important slide. Don't look at the slide, it's quite busy. But the key point that I wanted to bring, that in order to establish 1 million ton of steel capacity, we know it takes around $1 billion, some 7,000 crores of rupees, okay, at a mota level. Now, if we are adding, let's say, another 100 million ton, okay, over the next 8 years, that requires 100 multiplied by 7,000 crores of rupees. Now, applying a 30-70 debt equity ratio, like we apply for infrastructure projects, you calculate how much of debt that you will be needing from banks and other financial institutions. Whereas steel, iron and steel as an industry is currently sitting at a debt level of around 3 lakh crores of rupees. So whether the likes of SBI or the other banks and financial institutions are in a position to give that much of additional debt to the steel industry to finance this capacity expansion that we saw on the other slide is a significant challenge. So I think it is important for government to agree that we will be happy to bring in foreign investments in this in this particular industry segments, and there should be other financing options. It should be clearly opened up for other kind of financing. Then only it is going to be possible. Otherwise, it is going to be more of a dream rather than a vision to add that much of a capacity in reality within the time frame that we are targeting. So that is another significant challenge that we should keep in mind and prepare for it. So at an overall level, if I may just summarize of all the points that we discussed over the last 15 minutes, we have to keep focusing on reduction in our reliance on imports to the extent we can for coking coal, but definitely we can significantly reduce our import dependency on limestone. That is point number one. Second, in terms of improving the quality of iron ore and also decreasing a little bit of iron ore requirement from scrap point of view, we need to focus on scrap ecosystem creation with the right kind of policy guidelines, and the government ecosystem should work together. Debottlenecking the logistic constraints in terms of strategy roadmap creation and implementation of the projects. Reduction in cost of financing by opening it up for foreign investments and otherwise. And expanding our geographical footprint. I think the individual companies are anyway trying to explore that whether they can get good quality assets outside of India, so that on a blended level they can use the raw material to the best as a best feed to their plants. That is another focus. But lastly, but not the least, I would agree with what Mr. Mohanty, both Dr. Mohanty and Mr. S.S. Mohanty was saying in the morning session, that not just on the decarbonization space, but it is probably also true for other R&D needs of the sector, like beneficiation. it is not the problem of only the CSIR labs. It is not only the problems of Dr. Viswal. The industry and academia need to join hands, maybe in similar line to the that we have seen in Australia, like CRC mining as a platform. It is there. It needs to be a collaborative platform of R&D and innovation. Your investments behind R&D as an individual company will reduce actually, and the upsides is much more. The speed of getting to the solutions by doing R&D is going to be much more. So I think this is high time that we create such a collaborative platform at whatever level that is possible, not just by the, maybe the World Steel Association, where the larger players are anyway having good stake in terms of their voices. Maybe the Indian Steel Association, where Tata Steel, JSW, MNS, JSP, everyone is present there. Okay, SAIL, etc. So they should bring the issues on the table together, and then the funding can be done by the industry participants, whosoever want to participate with their problem statement in that particular platform, and then give it to the likes of CSIR labs, give it to the likes of IITs to find out solutions to specific problems that we are facing today. That will be a more optimal way of investing in R&D and finding out solutions for the sector. That is the another important point that I wanted to leave my thoughts with. Thank you for your patient hearing.
Thank you, Mr. Chakravarti, for a nice talk within time and briefly explaining. I think I need not have to elaborate the gist. He has in the last slide has already given the nutshell, the 5 themes that he has given the talk. So the raw materials session began with his talk, and he has explained beautifully how we can procure raw material of good quality, both in grade wise and size wise, which is a problem and the challenge. Then in the raw material, as he has described, iron ore, lump-fine ratio, limestone, that is for flax, and coal, particularly coking coal, and the development of the research program. So on the whole, the time-bound description covers all the aspects of his talk in the raw material. I think that is the burning challenge now for India to keep pace with the world production in the steel that we are targeting for. And I think we have to develop that parameters at home in India. Thank you. Next speaker. Now, I'm going to introduce the next speaker. Our next speaker is at the end, I think, yeah, last. Yeah. After the session altogether, the questions answer can be given. Now, I shall invite our next speaker, Dr. S.K. Vishal. In nutshell, I'm just introducing him. He's a very known figure here. Dr. Vishal obtained BTech in chemical engineering from NIT Rourkela. He was awarded PhD in chemical engineering from IIT Kharagpur. He was working as the chief scientist and head of mineral processing in IMMT CSIR Bhubaneswar. He has more than 36 years of experience.
Since there is a display.
Just, yeah. He had many pilot projects he has taken up, which has been transformed to the actually pilot plants and other things execution. And he has many awards in his credits, as has been described here. He was also members of several committees of the Government of India in research and development. And at the present, he is working as a serving managing director and CEO of MS International Panagraph Mintech Research Center, that is IGMRC, Bhubaneswar. Thank you, Dr. Vishal. Please deliver your talk.
Good afternoon to all of you. My topic, the technological challenges on Indian low-grade iron ore and beneficiation and pelletization. Morning, a lot of talks has been happened regarding the decarbonization and sustainability. I will touch both the sustainability and decarbonization with respect to the beneficiation and pelletization. Yeah. But today, if you look after the already morning, our chief guest and other people, they have told the demand of the steel is increasing day by day in not only India, in all over the world. And the production of steel is increasing, and as well as also the cost of iron ore is also increasing. And if you look after the Indian scenario, according to the national steel policy in 2017, we are targeting to produce 300 million tons of the steel. Out of that, 250 million ton will be produced through the BF route, BF and DRI route, and 50 million ton they will be produced from the scrap recycling. And we are targeting to produce CO2 emission in 2030 from today's production of 2.6 to 1.75 by adopting the new to improve the raw material from the steel production. And we are making the net zero in 2070. Now also recently the Minister of Steel also targeting, already Mr. Chakraborty has shown, 2050 we are going to 500 million tons of the steel. And replacement of fossil fuel by blue and green energy, though many people are talking about the hydrogen, but I always prefer, because we have the lot of coal deposits in India, if you can produce the syngas, partly you can able to reduce the CO2 emission. And because of the limited resources of the iron ore, the high grade iron ore is decreasing day by day. If you take the 100 tons of the ore, almost 30 tons is coming the high grade, both calibrated ore and high grade fines, but almost 50% material we are calling the subgrade ores. At present, we are dumping at the mine site, or we are blending with the high grade ores. And this is the challenges, how to utilize lean and lower grade iron resources. Lean grade means the BHQ, BSJ, and BGQ, and the lower grades, mostly we are talking about below 50-80% Fe. If you look after the mineral phases in our hematite ore, because at present we are mostly more than 98% we are using the hematite iron ore, and that is the our mineral phases is coming magnetite, martite, hematite. Along with that, impurity and vitreous goethite, ochreous goethite, along with the impurities, gibbsite, quartzite, and kaolite. If you look after our iron ore, we have categorized. One is the BMQ. At present, only BMQ operation is going on in Rajasthan by the Jindal Saw to producing around 2 million ton concentrate. But mostly we are depending on the hematite ore. We have categorized high grade ore, which is the 62.5% Fe, medium grade ore, and low grade has been classified 3 parts up to 45 because our cutoff is now 45. And lean grade resources, lot of slimes are there for a long time. Those are making the washing. And earlier also those beneficiation plant was there, like a Kirandul and other places, which having the tailings is more than 45% Fe. And lower grade ore BHQ and BHJ and BGQ. BGQ is a banded goethite quartzite that is only available along with the magnetite in Rajasthan. And we are mostly now emphasizing how to utilize 55 to 58% Fe, 45 to 55%, and slimes and lean grade ores. And if you look after the characterization of our ore in all over India, we have a that is called divided by 2 parts. One is called ferruginous, another called siliceous. And ferruginous ore is Odisha, Jharkhand belt, and Durg, Bastar belt, and Bellary, particularly Karnataka belt, and siliceous ore only Goa and Maharashtra. If you look after the beneficiation response in Odisha, moderate response, Durg also respond well, and Bellary moderate response, and Maharashtra and Goa it well response. At present practice, once you are getting the mines, we are taking out the BHQ, BHJ on the top of the resources. And after crossing and screening, we are taking the high grade iron ore fines for the center purpose. And those are the 58 plus. We are going to iron ore beneficiaries and present practice, they are doing it. But below 55%, we are simple dumping. And after beneficiation or washing, you may generate the slimes or tailings and getting the high grade fines to produce the pellets. And the production of iron ore in India in 2023, at present 255 million tons. Out of 255 million tons, 60% Odisha is contributing. And we have the beneficiation plant, existing beneficiation plant, they can take around 100 million tons of the capacity. It is beneficiation plant is there, both magnetite and hematite. Apart from that, particular for Tata Steel having the 30 million ton capacity of the washing plants. And only the BMQ is operating at the Jindal Saw. And recently one of the plant is coming up 1.2 million ton concentrate in Jhansi in Madhya Pradesh. And the remaining thing we are beneficiating, that is the mostly the hematite ore. And we are producing about 61 to 67% depending upon the mineralogy of the ore, and to making mostly the pellet making. And at present, whatever beneficial plant around 100 million tons is there, they are not running with the rated capacity because the day to day, the mineralogy of the ore is changing. Second, also the cost is variable. Those are the merchant mines. They also stop the plant sometimes when the cost of the ore is more. These are the beneficiation plant in all over India, having the different capacities, mostly in Odisha. I am giving the example of ArcelorMittal, which is the beneficiation plant of Kirandul. It has been established to beneficiate. The feed was 63, 64 in that time to produce 66, 67% Fe. Okay, this is the 8 million ton capacity plant has been built up. But gradually, because when the mineralogy was changed, we have done the that is called the optimization study. After optimization study, we have again to change the process flow sheet. Whatever the red pictures I have given, that is the additional equipment we have added to improve the productivity as well as the quality. Then later on, when it was declared, because earlier it was the 52% was the, sorry, 58% was the cutoff. That time the telling was 52%. That's why we are not worried for that. But when the cutoff has come down from 52 to 45, then we have added the additional equipments, the magnetic separation, which you have seen the slow on AGMS3, so that to further recovery of the iron values, to reduce the Fe content in the tailing to below 45%. Now they are facing the another problem, because the whatever the NMDC earlier was giving 63, 64, now it has come down to 61, 62% Fe. Now again we have done the optimization study to how to improve the without compromising the productivity and quality. You can see the recently we have modified the process flow sheet so that they can able to, without compromising the productivity as well as the quality, the additional equipment we are going to add. Why I am showing to this, because once you are putting the beneficiation plant, they're not necessary, because always it will give the your required quality or productivity, because it depends upon the mineralogy of the ore. If mineralogy ore changes, automatically it will be, you have to prepare to modify your process flow sheet. This is the ArcelorMittal, that the Kirandul plant. Similarly, when I was at IMT, my colleague is there, Dr. Das is here. We have given the process to the JSPL. This is the first plant we call the integrated beneficiation plant. It can be produced BF grade, it can produce the DRI grade and sinter grade and pellet grade. That basis the plant has been put up because of the today it is not running because of the other issue, legal issue of the JSPL. But it was the first integrated plant, not only in India, in the whole world. And we have also put up the ArcelorMittal plant in Damuna. This is the process flow sheet. But now same way, the mineralogy of the ore is changing. Now we are putting the additional facility to recover the iron values, because at present the tailings is around 52, 53% is coming. We are putting the magnet separation followed by the reverse flotation to achieve the quality, because the target is to produce more than 66% Fe. Because if you go for the, because nowadays you are talking of the green steel, now also we are talking of the green iron ore. The green iron ore means the Brazil people already declared. The green iron ore means if there is 67% Fe and alumina silica less than 2%, and Chinese people also declared minimum 66% Fe and alumina silica together within 2.5%. By addition of the magnetic separation and reverse flotation, we can able to improve the Fe content in the concentrate, which will give the mostly benefit for the downstream, particular for steel making, because 1% alumina or 1% silica will reduce a lot of co-consumption can be reduced in the blast furnace. This is the Damuna plant of the ArcelorMittal at present. And now Mr. Chakravarti told that the transportation of the ore, logistic problem. Now when the Bhushan Steel was there, now it is taken by Tata Steel. That time they have planned to making the satellite beneficiation plant. The satellite plant means the ore they can transport by the pipeline up to the beneficiation plant, and from the beneficiation plant they can utilize the concentrate for the pellet making. This is the plant, it has been designed, and today though Bhushan is no more, is now Tata Steel, but other people like the Cimetallic and MSP and Ardent, they are planning to taking the material from the OMC by the pipeline to their beneficiation plant. They see the beneficiation plant that. Now if you see the overall, because our mineralogy of the ore is Fe is going down, earlier we were putting the single stage of magnetic separation to get the concentrate, because that time the cutoff was not 45, it was 58. But now you have to bring down to the Fe content in the tailings to below 45, either you can do the log cycle migrant separation, roughing, scavenging, and cleaning. And this is the washing plant and on simple calibrated plan, screening and classification by different plants are there, around 172 million ton capacity all over the India. What is the challenges is there? Because the iron ore beneficiation, if you look after the decarbonization, 70% energy goes for the grinding. Okay, either primary grinding along with the secondary grinding, that is the big issue. And to reduce the energy consumption, the following step you can take it, because if you take the Odisha ore, because though we call the hematite ore, it is associated with the goethite. And once it is associated with the goethite, it is fragile in nature. Because Odisha ore, we give the importance how to control the grinding. But other cases, if you go to another country, how to grind, that is the main objective. But here is because of the ore is a fragile nature, if you cannot control, then ultra fine generation will be happened. And once ultra fine generation, the separation difficulty, either do migrant separation or flotation below 5 micron recovery is not easy. Okay. And our ore, if you do the particle size analysis, if you take the below 10 mm fines, around below 100 micron, up to 40% is there. So better to classify at the beginning, so that that thing is not necessary to go for the grinding circuit. To unnecessary you are increasing, and second thing also recovering is difficult. So that the beginning the scrubbing technology should be there. Whatever fines is associated, that can be taken out. Not only taking the fines, because if you look after the mineralogical analysis, the kaolite is the major, whatever the alumina silica in the present in the iron ore, the mostly in the kaolite form. And kaolite has the swelling properties. And once his swelling properties, when you go for wet beneficiation, the viscosity of the slurry goes up, which give the negative impact, both grinding, separation, settling, as well as filtration. That's why you take out the beginning of the below 100 micron particle, you treat separately. You not to throw, you have to treat separately by migrant separation already 100 micron. And it is the natural fines, the liberation is the better compared to the grinding fines. That is the we have given. And hematite is a fragile nature. It should be grind by closed circuit grinding. Many people who are doing the primary circuit, primary ball mill is open circuit, it is a wrong concept. You do the always closed circuit grinding, either using the screen or hydrocyclone or high frequency screen by closed circuit grinding. That's why we are telling primary ball mill should be closed circuit. Secondary ball mill, you should do by the combination of the Derrick screen and as well as hydrocyclone. Already the Derrick screen is giving the good result already. AMNS, Mr. Raju is here. They have given the good result because earlier they are facing a lot of problem for pelletization. Now they are able to control the size distribution, but to decrease the energy, all these things, first we put the hydrocyclone, the underflow of the hydrocyclone should go to the Derrick screen, so that the ultra fine material was coming, the cyclone underflow should not be repeated to the secondary ball mill. By that way, you can able to reduce the energy. And second is to control the particle size distribution, because in pelletization plant require the 2000, around 2000 blend number. And now the high pressure grinding roll is there, but high pressure grinding roll, the negative part is the more than 7% moisture, it cannot be used. If you have the drying system in the plant, that is no problem. But particular for the bended material, BHQ, BHJ, BGQ, the fine grinding, fine crushing, the high HPGR can be utilized, which saves around 40% of the energy. And coming to the slurry transportation, already 3 slurry transportation are available in India, one both in the ArcelorMittal, both Vizag as well as Paradip. And another is the BRPL 3 plant, but already 13 pipeline are going to set up. One is in the Nagpur by Lloyds, and remaining thing in Odisha. Okay. And also from starting from the small plant to the bigger plants. And the No, the slurry transportation not only to make the transportation cost reduction, but as well as also the power for the carbon footprint more than 80% you can able to reduce. And to improve, because our ore is containing, even after beneficiations of the kaolite, the rheology has to be properly studied, because nowadays lot of chemicals has been developed by the different countries to reduce the viscosity. Once you reduce the viscosity, automatically whatever pressure is needed to transport from one place to another place, you can able to reduce. Once pressure will reduce, automatically energy save will be there. That's why I told to our IMT, my colleagues, to develop the chemical additives, so that it should not be, because we are putting the lime, but another polymer base you can develop which can be reduce the pressure development. And now the disposal of tailing is the big issue. Many plants are facing the problem because the tailing pond, the Ministry of Environment is not allowing, or available the land for tailing pond is another issue. That's why the filtration you can do, because now earlier whatever the commercial filter press was there, it is only taking to 14 bar, but now Metso has also developed up to 25 bar. Another, this is the indigenous company. In Gujarat, they have developed 25 bar, and we can able to filtrate the cake up to the moisture content is 15 to 16%, which can be stacked, and you can make the greenery to generate the artificial forest. Okay. This is the you can make it. Okay. Now I'm coming to those are low grade ore below 55%, which does not feasible by the conventional beneficiation things, because below 55%, why it is not responding? The reason is it is containing the mostly the goethite, and mostly in aqueous goethite type, so that it does, because goethite needs 18,000 gauge more than that and should be liberated. That is the reason we are going the reduction roasting process. We have done a lot of work in reduction roasting process to utilize this low grade iron ores and slimes and BHQ. And you can see the lot of BHQ low grade ores of the one of the mines of ArcelorMittal. It is this is the pictures. You can see it is lying in the site. Okay. What will happen in reduction roasting? The objective of reduction roasting to changing over the hematite and goethite to magnetite, because once you convert to magnetite, it is easily beneficiated by low intensity magnetic separators. Okay, and you can see the pictures. Hematite, once it's changing, the color is changing, and after grinding, and you can get the magnetic product. And we are using the reductant is non-coking coal. Here coking coal is not required. That is the one advantages. And if you are using the gas, either syngas or natural gas or hydrogen gas, that reductant the vertical clean. Otherwise, if it is the coarse particle, it is the rotary clean can use it. Okay. Then after conversion to magnetite, you have to grind it and to below 100 micron and do the limbs. These are the and it needs the reduction roasting kinetic depend upon the temperature. Three variable. One is the temperature, another is the reductant, another is the residence time. This is the process flow sheet, and these are the chemical reaction takes place during the reduction roasting. And I'm just giving the some of the example of the reduction roasting of the BHQ. And this is the case study. This is the low grade ore having the 55% of ore. And after desliming of that ore, this is the results. And this is the chemical 55%. This is the from Karnataka. And based on this result, 100 tons per hour capacity plant is going to build up, and this is the December, it will be commissioned. This is the first plant is coming in India. And these are the different types of low grade ore for Rairangpur we have taken. This is the all results. The time is not there. I will not go details. Sorry. This is the overall process flow sheet of reduction roasting. Okay. And these are the advantages: increasing 30 to 35% extra yield compared to conventional process, increase the grade of the concentrate, reduce the grinding energy, because once you heated, automatically lot of crack happened, 30% energy goes down, maximize the recovery of process water by filtration for both concentrate and tailing. Handling the rejects is easy because it does not require tailing pond. Productivity of the process will be better because there is no clay effect. Transportation also easy to make pellet to reduce 20 to 30% energy consumption, improve the pellet quality, and improve the conservation of the change in iron ore industry. And I have done the energy balance, and that is the time is not there. It is the required 1 ton of the ore, around 162 kg of the coal, of non-coking coal, having the 40%, you may take it. And we have calculated that the process cost is coming 1,651. And if you take the ore, that's why recently the Ministry of Steel has put up the task force, though I am also one of the member, and many steel plant people are also member. We are asking to give some incentive, those are going to beneficiation by this process. If you take 1,000 rupees, $15 months, and cash to EP the 1,500 rupees also within the 3 years, you are getting back. And recently also we have done also 62.5 to make the 100% DRI grade. Even taking also 4,000 rupees, even then we are getting within the 10 years, you are getting back your money. This is the 1.2 million ton capacity I have shown, that was the 4 million ton. The same way, this is the study. And I have just 2 slides there for regarding the pelletization, because our pelletization problem is the kaolite, quartzite, and gibbsite, creating the problem. And once the goethite is more, our LOI is more, kaolite, goethite, both are responsible for LOI. And because of the fragile nature, our ore is high blend number is coming up. You can see the magnetite pellet and synthesized magnetite pellet, hematite pellet. You can see the how much CCS. If it is magnetite, within the 850 to 900 degrees centigrade, you can get the CCS 50, and within the 1100 to 1200, you can get the 250 CCS of the pellet. But if you look after the hematite ore, it is required more time, 1100 centigrade for preheating temperature. Getting 250, you can go to 1300 degree temperatures. And that's why, because our ore is different type of the mineralogical difference, because whatever pot grade test we do, but to make the perfect designing of the, with respect to our ore, we are making the continuous type pot grade test. And Dr. Khotoi and Mr. Ganaman, they are there. They are making the construction for us. This is the 15 cars together. You can do the study of each zone. That is the, and we have done the relation between the, making the relation between the pellets with the mineralogy. We can see the, this is the kaolite and goethite. We have made the, what is the size distribution of the pellets. And also we have done the temperature and residence time, all these things, mathematical correlation we have made it. Okay. My conclusion is, to meet the demand of steel industries, beneficiation of low grade ore is in need of hour. Based on the mineralogical characteristics of ore, proper decision is needed to adopt physical beneficiation or reduction roasting process. The energy consumption in the beneficiation process should be reduced using advanced beneficiation technology. The tailing should be stacked and make artificial forest to save the environmental of the surrounding of the mines. Decarbonization should be start from mining onwards using non-conventional energy, particularly solar energy. If the high quality iron ore concentrate is used in form of pellet for steel making, energy consumption can be reduced. Proper R&D study is needed for both iron ore beneficiation and pelletization, looking towards mineralized composition of the ore. Thank you.
Thank you, Dr. Vishal. Now I am going to introduce Dr. P.K. Banerjee, the outstanding scientist and scientist in charge of CIMFR Dhanbad. He is obtained the BTech honors and PhD in chemical engineering from IIT Kharagpur. And earlier he has worked in many CSIR, CMPR projects and CTO of Hindalco Industry. And he has also credit of 25 patents in the R&D works. So I request Dr. Banerjee to deliver his lecture. Thank you.
Thank you, sir, for those kind words. A very good afternoon. First of all, I'd like to thank SGAT for giving me this opportunity to share some of my thoughts on the topic. I'll say the topic or the subject is very much central to the theme of this seminar, the sustainability of steel industries. When I say something so important for sustainability of industry, I must justify that those three factors which leads to sustainability is addressed. You know the three P's, you know the people, planet, and profit. These are the three factors. When I say people, I mean the societal. When I say planet, I was talking about environment, and profit, of course, the economy. And you just see, here is a commodity we are talking about. Here is a subject we are talking about. The coal has so much of impact in all these three factors. Let me quickly tell you those three factors. We are talking about the people, of course. Coal mining, the entire value chain, has so much of impact on the society, whether it's a job creations or the livelihood or the development, many things. But the most important is the other two factors, the cost. Cost, 40 to 50% of hot metal cost is coal. 40 to 50% cost of hot metal is coal. When it comes to environment, almost most of the greenhouse gas emissions we are talking about is coming from coal. So you can't ignore coal, rather you have to address the issues. So what are the challenges? What are the issues we need to do it? I'll just take you through quickly. I know there is a shortage of time. I'll try to restrict myself in 15 minutes. So I'll take you through the broad three areas, starting with beneficiation, and I'll talk a little bit on the coke part, and then, of course, the cleaner fuels from coal, the gasifications and hydrogen route. So that will be broadly my coverage. I am skipping all these things, but these are all the background has already been discussed throughout the morning, all the factors, and especially if you look into that when we are targeting 300 million tons, see the requirement, almost 300 million tons of coal will be needed with 161 million tons of coking coals. But the fact remains, dependency on coal will continue at least few decades. But we have to do sustainably. We have to address those three factors I was talking about, the three P's. We need to balance those. We just can't say that, we have to stop one component. That's not possible. We have to address all three together. Of course, the best scenario is that, is there an alternative to coal which addresses these three? It's more kind of having it's a better or cleaner material, or has economically cheaper, or has a great impact on society. Fantastic. That's the scenario is what we are looking for long run. But in short run, we need to address those issues which we are facing around coal. So that is where we need to focus currently. So let's start with scenarios of coking coal. I was talking about India has a lot of coal, you have seen in the previous slide, but we do not have very good coking coal. We have coking coal, but we do not have very good coking coal in the sense the coking properties or the impurities present and all that sense, it's not really a good picture. But again, we need to see that our dependency on imports has to be addressed. So what best we can do? We have We do have coking coal, but that's of low grade. Now, my today's presentation, I'll only talk about one particular variety of coal, which is present in great amount. That's the low volatile coal, which is there in Jharia coalfield in lower seams. This is almost 50% of the coking coal basket. Of course, it's weakly coking. It's not very good coking, but that's where we need to target. So what is this coal? If you see, it's a little busy slide, but I will not be able to talk you in details. But if you see on the right side, if you see the distribution, the coal, the low VM coal, the distribution in different densities is more or less uniform. So in other words, it's talking about that beneficiation is not going to be easy. It's going to be extremely, extremely difficult. What we are doing today with this coal, we are sending to power plants. We are sending these coals to power plants. You see 8 to 10 million tons from Jharia and 6 to 8 million tons from S. Bokaro, which is currently going to power station, and a little bit used in the beehive ovens. So very little quantity. But this is definitely some coal needs to be addressed. It's a potential source of future coking coal in India. When we talk about that, our dependency on imports, it has to come down from 85% today to 65% by 2030. That means 56 million tons of coking coal is needed by 2030. You can't have any other route than to exploit this kind of thing. So therefore, it is extremely important that we address this coal and find out what is available. And fortunately, a lot of work has been done at CSIR Simfar. I'm just sharing one particular set of results. You can see that the beneficiation of such coal is possible. Yes, you won't get a very high yield. You can get roughly 23% kind of yield with a 17% as is feasible after doing a series of beneficiations with kind of a jigging, cyclones, rotations. There are varieties of combinations. The flow sheet, you can see it. The most important part you see on the right side, that the coal which you are recovering, roughly 23% from these low volatile coals, very, very I'll say good in the sense it has improved its coking properties. The CSN has improved from 1 to 3.5. This is one important parameter to tell whether coal is coking or not, or even LTGK type coke type is C to G, which is rather going towards the medium coking kind of coal varieties. So this possibility is there. The good part is that it also has a good plastic and other properties. So certainly this is a coal can go into the coking blends. I'll not spend much time on beneficiation, the conventional beneficiation. There are plenty of opportunity to improve the performance of the current coal washing practices, going for new washeries. I'm not talking about that. That in any case, extremely important and we need to focus. So a lot of opportunities around, but these are the new thing, the new resource which can put into the basket of the useful coking coal. That's what we need to look into. Not only that, non-coking coal also another area we need to look into. There are patches, there are certain areas where low as non-coking coals are there in the country. Can we beneficiate that and bring down to a level, let's say 10 to 12% as which can go for injection? So that's also possibilities there, especially ECL kind of belt. There are certain patches and we have examined some of the resources. This kind of possibility will evolve. Now let's move to the second set of my discussions is the coke making around. So once you have the coal part, then we talk about the coking part. Now, again, this is an area where the CSIR Simfar is, I'll say, one of the best organization having the expertise in this field. And you can see we have our indigenous technology, coke making technology, heat recovery technology with stamping facilities, which has been commercial right now. The commercial plant is being built at Kudremukh iron ore plant with a 0.18 million ton capacity. It's quite a big one. And we are further working on this technology to improve further. First of all, this technology itself is good to accommodate a lot of non-coking, weakly coking coal in coke making. But then on the top of that, our next level of research is going on hot stamping, not just simple stamping. If you can do hot stamping, then you can even accommodate more of non-coking coal, weakly coking coal in the blends. Then you may ask why, this hot stamping, it's basically a pre-carbonization, it's preheating. Because if you can do before stamping, then you bring the plasticity, you bring that kind of improvement in the bulk density so that the good quality coke can be produced. So that's the line of thought why we are looking into this technology. We have done a lot of experiments in the lab scale. You can clearly see that with different type of coals like A, B, C, D are varieties of coals. A is of course the very high quality coking coal, imported coking coal and all other domestic. So you can clearly see in each case, moving from top to stamp to hot stamping, there is an improvement. When CRI improvement coming down is improvement. And when we talk about CSR, it is going up is the improvement. So that's the way in each case, you will say there is a significant improvement. And then we tested with blend, because at the end, we need to try with the different blends. So we tested little again, little busy slide, but what I want to say that different blends we did experiments, and we found that yes, by hot stamping, we can actually accommodate a lot of non-coking coal. And particularly, I was talking about LBC coal. I think the blend 3, if you see, here we are using coal F, which is that LBC coal. So not only we tested that beneficiation possible, demonstrated flow sheet, we use the coal in blend. And it is equivalent to a medium coking coal. That's very fantastic results, because that's the future. If you can do a beneficiation and go for a coke making, you can open up varieties of, I'll say, a large quantity of coking coal resource in the country. That possibility is opening up. Okay, third part is now talking about the cleaner fuels we are talking about. Let's talk quickly about the ultimate objective, that why not we go for the cleaner fuels? That means synthetic gas, rich with hydrogen or even hydrogen itself from coal. We are talking about green hydrogen from water splitting and green electricity and all. We are talking, no, let's have hydrogen from coal. Because at the end, the green hydrogen will be limited. And you have seen since morning, there are so many challenges and we don't have so much of green hydrogen. But if we can get from a coal, it will be much cheaper. Of course, you have to be blue hydrogen. It's not the green. You have to take the CO2 out. So let's focus on that green part. But then in that journey, CSR is extremely busy, is working in that path. We are working on the gasifications and then purifications, then water gas shift reactions to make it hydrogen rich. And now we are going into the hydrogen path. So our journey was started from here. It is a pressurized fluidized bed gasification technology, PFBG. You have heard about the technologies are there. Gasification technologies are already there. The entrained bed or the fixed bed technology is already there. But the issue is that Indian coals, all this technology has the limitations because of high gas. Because each of these technologies will be asking for, especially entrant for, will ask for less than 20% as. Where is our coal with 20%? That's not available. Then if you talk about fixed bed, again, it can go maximum 30% and all. So therefore, you have to, in any case, get clean coal and blend it and all that route is there. Then there are environment challenges with the moving bed and all. So we need a technology will fit with our coal. That's the pressurized fluidized bed technology, which is the technology we are working. And some of our other organizations, BHEL is working in that, IIT Delhi is working. We are all working towards that direction to develop the technology. And right now, and you see, we started with air blown, and you have seen from the results that we got syngas with 15 to 20% CO, 15 to 20% hydrogen. So that's the results we got it when it was air blown. Then we move further into the pilot level with the improved technology, which is oxy-blown pressurized fluidized bed technology. Now, in this technology, you can see what we are doing. We have moved to oxygen blowing rather than air. And that's the intention is that whatever the syngas we generate will be richer in hydrogen and CO. 25 to 30% hydrogen, 25 to 30% CO. So that's the level of straightway in one single process we can produce a syngas. And this technology right now we are running at 1.5 TPD pilot plant is running. Our next objective is to scale it up further. We want a partner with whom we can work towards a kind of 100 TPD plant. And that's the future for Indian highest coal. This is the technology you have to work. This is the technology where collaborations is needed. We must have our own technology will fit into Indian coals. So overall, if you see what process we are talking about for sustainable steel making, we have to start with the highest Indian coals, then gasification, syngas, and then there will be a water gas shift reaction to enrich hydrogen. And of course, in the path, you have to take CO2 out so that you get a hydrogen-rich syngas. So here, hydrogen-rich syngas means I'm talking about it's roughly 55 to 60% hydrogen, 55 to 60% hydrogen. We have demonstrated already in our lab level that's possible. We can produce up to 55 to 60%. So from there, either you can go to methanol route or you can separate hydrogen and use a the blue hydrogen for subsequent applications for blast furnace injections. So this is very much potential route. This needs a lot of attention. I think Simper is very much well positioned to take it to the next level, because first part is piloted. The next phase, we are going for piloting. And membrane, of course, the kind of research, we are still in the lab scale, because there is a pressure swing absorption technologies there, but we need a technology which is cheaper and more reliable and really a good solutions. So we are right now working on the membrane technology where you can preferentially have the hydrogen going through this and you get a clean hydrogen. So there our material is something where we are working. We also discuss in the morning, it is not that hydrogen production, its transportation and storage is extremely important. So that's also a place where we are working very closely. We are working with the material for making the pressure vessels high pressure, because compressed hydrogen needs 700 bar, that kind of thing. And the problem is that India even do not have a facility for testing this kind of. We have to send this material to outside for testing. That's the kind of scenario we have. Such facility is going to be built in India, and right now we have come up with piloting this. We are going for testing this. I just adding that because when we talk about hydrogen solution, these are the issues has to be addressed. I think I have come to the concluding remarks. I have mentioned about this thing. Only I'll just reiterate there are three things. Coal is going to play the critical role for the steel industry in India. Bound to happen, but we have to do very sensibly and we have to address the issues. We can't, just avoid the issues. Starting with beneficiation itself, get the right quality coking coal, right amount of coking coal. Second is that converting that coal into right kind of coke. And finally, the route of blast furnace injection. So if you can do injection route or DRI in that route from coal rather than green hydrogen we're talking about, that's definitely is very potential area for you. I think that's all from my side. Thank you very much.
Thank you, Dr. P. K. Petrucci, for your highly informative talk and for the hope that you have generated in the area of coal, where we are trying to get away from. Now, we have come to the end of the first session. There has been, we have actually exceeded the time schedule. We'll be breaking for lunch now at 1:45. And then by, our next session is session 2, steelmaking, where we have got the speaker from World Steel Association, and he'll be speaking online, and he has been scheduled to speak at 2:30. But then we have to make some arrangement with him also. We are trying to get it because he is in Belgium. He'll be speaking from Belgium. And so we need to be present also, because he must see that there are some listeners. So that is why I request you to please come back here by 2:15. I think that is a bit too much, but then I'm sorry, but this is a compulsion. So next is one minute. Acha, we will complete those formalities. Yeah. Let us break for lunch. Okay. Thank you.
use of high strength steels or ultra high strength steels. But we are trying to find out how you will sequence. Originally, it was planned that I would speak first, Dr. Rizwan would speak next. But if he is on the line from Brussels, he might as well speak. I have no objection. So, Rizwan, are you able to hear me? Dr. Rizwan, good afternoon. Hello. Dr. Rizwan, are you able to hear me?
Yes, I can hear you.
You can hear me.
Yes.
Have I heard you correct? I am already there in the hall. So, and I'm told that you have joined. If you have joined, then I have no objection in you speaking first. And you can speak for about half an hour, 25 minutes to half an hour. Dr. Farooq, about half an hour he speaks. So you can start with your talk and then I'll follow you so that you would be free to go immediately after you finish your talk.
No, fine. If you can, if you would like to start, I would be perfectly happy to listen.
Okay.
Yeah.
I'll be most privileged. Okay.
Yeah.
In that case, I'll do that. Okay. So he wants me to start first and then you will be treated to Dr. Rizwan.
Thank you so much.
Yeah.
In fact, in this session, I am the moderator. I'm Dr. Mar Mohanty. I'm a retired scientist from atomic energy, and he is my co-moderator. Mr. Edargil, please.
My name is Sudhakar Adhikari. I'm for 40 odd years associated with the steel industry. Fortunately, I have two relationships with Professor Mohanty. He was my teacher in IIT Kharagpur. Then we became colleague, and then Dr. Mohanty in the morning said that he had worked as R&D chief in Tata Steel for 10 years. I had worked in R&D, raw material R&D of Tata Steel for 5 years. So we have multifaceted relationship. So with that, I give it to my co-convener, Dr. Mohanty.
I'm also alumnus from the same institute. Anyway, so this 2 hour, our session is 2 hours. We have two speakers, and this session is very core to the theme of the seminar. Nonetheless, the earlier one has set the ball rolling, but this session is actually the talk of the steel making. So how a projection is being made, etc. And we are in fact privileged and honored to have Professor Dr. Rizwan. I'm sorry, Dr. Rizwan Janzua from Brussels. He is there on the line. And now in the process, first speaker will be Professor Mohanty. I will just, just customary about his introduction. I don't think none of us need an introduction of Professor Mohanty because of his tremendous association, and probably every one of us knows him. If anyone doesn't know him, that is our mistake, not his mistake. Just basically for a 2 minutes introduction, he is BTech, MTech from IIT Kharagpur, and then had his PhD from Karlsruhe, Germany. Then he became professor of IIT Kharagpur, National Metallurgical Laboratory. He was become director in the research wing. And then subsequently, after his post-superannuation, he became vice chancellor of Biju Patnaik Institute of University of Technology. And then a lot of, I think probably is a countless achievements, and it is there in the display of his achievements ultimately. And the greatest of his achievement probably I consider is he has got 17 patents, which normally are very difficult to achieve either by a professor or a scientist. 17 patents. But even then he doesn't take rest. He is now the director of RSB Metal Group in RSB Group. He's continuing still. So I invite Professor Mohanty to please give his talk. And Professor Dr. Rizwan, probably you will be listening to him from Brussels. Thank you. So welcome, sir.
Thank you.
Good afternoon, everyone. And good afternoon, Dr. Rizwan. Thank you for joining from Brussels from the World Steel Association. Am I audible?
Yes.
No.
Sir, you color mic.
They said something. So, but it's not working, or is it? It's working. Okay. If it's working, then it's fine. Thank you very much. So good afternoon, everyone. Hopefully my talk doesn't put you into sleep after the lunch. and hopefully all of you have taken a good lunch. So my talk has a slightly different tenor compared to what you have been listening to. You have been listening to steel making, raw material. These are all extremely important. So I thought I would talk about the new generation steel and the sustainability, so that it will give you a different perspective on, in addition to making the right route of the steel. Incidentally, in the morning, let me give some one or two general. Oh yeah. It on hold. That's all right. Huh?
It was the other way.
No. Other way. That's it. So I'm going to speak on this is the scope of presentation, but you know the reason why I showed that. এটা কাম করনি আগে পাচ্ছে হউনি স্যার এটা আগোটা এটা হউনি ব্রা হউনি not working nahi there's some problem
What
here.
I have seen. No, what I have seen.
No, do it. If you think it's working, you have switched off. No, I think this is not working. So I have to tell you first slide first. Okay, the first one. No, the very first slide. This slide I wanted back essentially because Dr. Rizwan, you might recall that World Steel Association, along with the Auto and Steel Partnership, you had also talked about the new generation automotives. And this is an E-motive level 5 autonomous vehicle conceptually. As a matter of fact, the kind of concepts which or designs which are here, I'm not getting into the intricacies of the designs, but suffice it to say that this is the fully conceptual autonomous vehicle. And the level 5 autonomous essentially tells you that absolutely without any intervention of the human beings, this will run well. And the entire thing is steel. Next. So when we talk of steel and automotive and the sustainability, all of you may be thinking that why is it suddenly from the steel I come to automotive? And so the connectivity I will be sharing, and the sustainability in the context of steel and automotive, and use of steels, etc., etc. So new generation steel in that context comes. So the new generation steel in that context it will come. Yeah. Okay, thank you. So before I come to the, before I proceed, the economic drivers of steels are very important. In the morning, I was talking about the $5 billion economy as far as India is concerned. And in this $5 billion economy, or for that matter, any advanced countries, you'll find out that we have issues in which there's an emphasis on the new energy production systems, conventional, renewable, whatever you talk of. There is a plenty of steel in that. In the morning, if Mr. S.S. Manti would have been here, I would have said the old adage of the Steel Authority of India Limited was, just as in Tata Steel, we had that we make roads, we make buildings, etc., dot steels. Long back, that was our motto. SAIL always used to put that there is always a bit of steel in everybody. Then they started saying it slightly differently. There is a bit of SAIL in everybody. So anyway, so that's not important. Important is the production of new oil, natural gas reserves, you name it. It's all there. So therefore, all of them would require a tremendous amount of steel. So there is no escape from that. So growth in wind industry. We have been talking in the morning about the alternative energy, renewable energy, and so on. So all of them would actually require steel. As a matter of fact, we will talk about the wind energy. That can be a full length seminar. Although today it's all composite material blades, but the main structure will again be steel. So in the automotive area, the need to produce lighter weight, 20 minutes about. Yes. Okay. More fuel efficient, etc. They are very important. Now, in the morning, I touched upon two of the myths. I want to go through that in 30 seconds time, that it is a mature industry. There is no further change taking place. It's a dying industry or sunset industry. And university research cannot be performed jointly with steel. It is not amenable to that. But actually, a huge amount of research today is going on with universities. Now, the automobile industry is a growth engine for any country, and certainly for India. If you are talking of India's manufacturing GDP, 49% to India's manufacturing, what is it like in the US? It is more than 40%. I'm not talking of just auto per se, but it is all related to automotive. So you are talking of the glass, you are talking of the rubber, you are talking of the roads, you are talking of the insurance even. So a lot of connections between the advanced industries and automotive. So but at the same time, as we had said, that there is so much of steel which is required, but we had also expressed concerns about the carbon dioxide which is emitted from the steel. Similarly, so much of automotive which are required, but we have problems with the greenhouse gas emissions. It is not just the CO2, it is the CO2, it is the CO, nitrous oxide, and the whole of the greenhouse emissions. So if you are talking of these, then the road transportation actually accounts for the maximum amount of steel within the maximum amount of emissions within the sector of automotive. Now I come to the concept, objective, and so on. So material, the concept, space frame or unibody. This is an important concept. I'm not getting into that. Suffice it to say that in the space frame design, actually even the chassis also participates in the design. So we don't have time actually to talk about it. The unibody is the entire structure takes part. So the material, the forming assembly, and so on. Now, if you talk of auto body, before that, I must tell you that why auto body is so important. Why advanced steels are always talked about in the context of auto body. Essentially because the so-called body in white accounts for about 36%, which is the maximum. The engine, others, drivetrain, and chassis, they also account for that. But the body is quite important there for the auto body. And there are so many properties which are required, or characteristics. But most important thing is, many of these characteristics are mutually conflicting. For example, the common man's belief is that if you are talking of strength, stiffness, etc., and if you are talking of formability, they don't go together. This is what was the conventional kind of approach. But today we know, I'm quite sure Rajiv ji will start producing very high strength steel soon from Kalinganagar, where the high strength will not be opposite to, or will not be conflicting with, or run contrary to the formability. That's the point. How does it happen? And environmental safety, that's of course quite important. So engine efficiency, combustion, transmission, these are all important, but we are talking of only the steel part. If you are talking of the weight part, weight reduction is considered to be the most potent when it comes to the greenhouse reduction or the environmental improvement. So weight reduction, remember that. We will proceed now. When we talk of weight reduction, there is a cost. You will say that we will make everything out of aluminum or anything else, composite materials. As a matter of fact, we are working today with TCS. I'm working with composite materials, and with Debasis also, myself and Debasis, we are working on carbon fibers. Until we realize that carbon fiber in India, no chance at the moment, because you have to import most of the carbon fibers. But glass fiber, yes. So you will find that in the case of aluminum, the cost will go up, while the body weight you can reduce. This is another slide of the same kind, so I can skip this. I want to now go back to at least 20 years. when Rajiv ji had just joined or not joined, I don't remember. And the year was around 1999. And I was in Tata Steel, and I was representing Tata Steel in the ultralight steel automotive program. 33 steel companies, they joined, and we had this consortium. So the whole story begins from there, which is why I thought I'll connect with that old story. And Porsche Engineering Services, and many the English speaking country says Porsche, but actually it's Porsche in Stuttgart. Now, this is the ultimate, this is the, after the filtering of the whole information, this is what happens. What I'm trying to show here is trussal rigidity, static bending, each of these properties, you forget about it. Let's come to the mass and the crash resistance, which is the safety and the cost. So when 33 steel companies from France, from Germany, from US, from Japan and Korea, and from India, it was only the Tata Steel and nobody else. And so initially, for 5 years, we were the only company who were a part of the OLSAB. And the weight reduction was as much as 25%. And there is no cost penalty. This is the significant part of it. So without cost penalty, how do you achieve it? And in that, in the safety, the crash analysis, many of you or some of you who are interested in the crash, there are standard crash tests. One has to go through these crash tests. So I've just mentioned that. So the crash resistance was higher, torsal resistance was higher. There was no cost penalty. How did it happen? It happened essentially because there are laser welded tailor blanks. I'm coming to that. Hydroform tubes. For the first time in the world, the Germans in Stuttgart and in Frankfurt, they started showing to us whether it is possible to have the hydroforming. I would like to show that. So this is about the laser welded tailor blanks. Today, laser welded tailor blanks are available also with some of the companies in Pune. And in the laser welded tailor blanks, all these blue lines, they would talk about the welding line. And this is a dual phase steel, 700 yield, 1000 megapascal tensile. But look at the next part. The next part is only 260 with break hardenable, and 370 is the tensile. Why is it that necessary? Because this requires a lot of forming. This is where the petrol goes in. It requires a lot of forming, which is why lower strength is there. So the very low strength and high strength, they are together. And the most important thing is, how do you have no cost penalty? This is the important part. In the automotive industry, about 40 to 45% cost is the tooling of the forming. The sheet metal, the tooling of the tooling cost itself is about 40%. So if you do part by part tooling and then weld, instead of that, for the first time in the world, we started doing laser welded tailor blanks. Just as you have a collar here, pocket here, and so on, similarly, you have a tailor blank. In the tailor blank, what you do is you are not doing the welding after forming. You are first of all welding all the sheets. They are of different thicknesses. They are of different strengths. You laser weld them, and then you start forming together. That's not so easy, because when you start forming, then look at here. This is a low strength. This is a high strength. The line will not remain as straight as I am showing. I will not get into that. One of the problems is that it is like playing badminton in the windy afternoon. If you want to go send your shuttle to the right, you actually start to the left. Similarly, also they started doing it. Christian people started helping us in the finite element analysis of this. So this is the hydroforming I was talking about. The hydroforming was going on, as a matter of fact, in Jamshedpur also, in the tube company. You have two tubes, and the forming takes place from inside. You put a liquid actually from inside. That's why it is called hydroforming. And then the tool is outside, and you start pressurizing it from inside, and it takes the form. And you can start also laser welding also taking place here. So therefore, in the body side outer, from the front to the back, and the load transfer can take place if you put one tube. So it's a single tube, but normally you would have welded at 3, 4, 5 different places. It's a single tube which is formed differently as a result of the hydroforming. And I still remember around 2001 when we completed the OLSAB, then the French and German big companies, they were fighting, or rather competing against each other about whether we should allow the OLSAB to go ahead or not. Another 5-6 minutes. And okay, take it. So then I remember it was in the Paris meeting when we said, should we or should we not take this consortium forward? It was 2001. We decided yes. But if you say yes, should it have a connection with the previous name or should not? So the previous name was ALSAB. So we said, let ALSAB be there and put a hyphen and put AVC standing for Advanced Vehicle Concept. So it is ultra light steel auto body, but advanced vehicle concept. And why advanced vehicle concept? You'll see that the program actually talked of the PNGV class, the US partnership for the new generation vehicles, and in the European situation, it was UCAR and so on. These were the key objectives, anticipated crash and so on and so forth. And now this is not a problem with my slide. It is deliberately shown. The car has turned turtle in the real life situation. And now you want to see that the car saves your life, that you are not crushed, which is why it is called roof crash test, etc. Now, this slide I like very much. We picked it up from the Japanese. They always believe in simplifying the things. You'll find here, you talk of surface rigidity, dentability, and so on and so forth. Today, Tata Steel does a lot of work on dentability, welding, and so on. But we started doing some simple equations here, materials factor. For example, I will put you dentability. In Calcutta, if you park a car in Kolkata today, then if you come back, there will be a street urchin who will come to you and will say, sir, humko 2 rupees de dijiye. In Bengali, of course, he will say. They will say, aapko kyon deo? He said, I didn't put a dent on your car. So, which is why you should pay me. So, actually, we make the car body dent resistant. So, how do you measure the dent resistance? Is it by the street urchin coming and throwing a stone at it, or there are tests? Yes, there are tests. So, dentability test is done. But when you use a higher strength steel, how do you know how much of higher strength you want to use and how much of dent resistance will you bring? Look at this expression. So, we started telling Tata Motors from Tata Steel that, look here, when we increase the strength from 450 to 650, then I can reduce the the thickness by so much. Then, because the equation is there, it's very simple. From 0.8 millimeters, if I come to 0.6 millimeters, then I have to say my strength has to go up by 64 by 36 or 64 by 49. So that's the kind of ratio you do. You have something to work at. The problem here is that if you start reducing the weight and reducing the thickness and go for a higher and higher strength, then Tata Motors went on telling us that increase the strength, which is what is happening today. Today, Rajiv will say, I will give you 650, 800 or 850, 1000. This is what Kalinganagar will start manufacturing. But then the problem is, if you start reducing the thickness, it is no more just the dent resistance. Then comes the NVH, noise, vibration, harshness, etc. So there are other problems. Affordability is an extremely important point. So these are the hybrid vehicles where the electric motors will come. Also was somewhere here. So the cost and manufacturing cost, as well as this is actually the affordability comparison. So it was always affordable, etc. And I will now go to the grades of car bodies, the steels. So the transformation induced plasticity, interstitial free grades, bake hardening grades, dual phase grades, some of these were advanced steels of the first generation only. So the conventional, the high strength steels are here, advanced high strength steels are here. This used to be called a banana diagram internationally previously. Today, we call it by a different name slightly. This is just to explain to you, when we increase the strain hardening coefficient of a material, and if the material starts bending over here, then suddenly the strain rate is quite high here. So, but the strain hardening coefficient of the material being high, it will resist. If it resists, the point of bending will shift from here to here. Again, some strain will take place, it will resist, it will go to the next one. So look at what is happening. A simple sheet can be conceptually, it can work as a spring. And that's how, with a higher strain hardening coefficient material behavior, this is by simple unstable plastic buckling. If there is no such thing, this is stable axial collapse. So these are some of the concepts which we started putting in the trip assisted multi-phase steels. Dr. Monideepa Mukherjee, she is now in Tata Steel Jamshedpur, maybe you have come across. This was her work with me when she was working for her PhD. We started working on the trip steels. Trip is the transformation induced plasticity. Transformation induced plasticity essentially tells you that we put a particular phase called retined austenite in the steel. And when the crash takes place or the forming is taking place at high strain rates, then the transformation takes place. So energy goes towards the transformation rather than creating new surface, meaning fracture point. That's the point. That's the whole important thing. So in the US requirement, the CAFE, the corporate average fuel economy, I will not get into details, but how the crash takes place. Incidentally, people will ask, when we are talking of the transformation induced plasticity, how do you know when the transformation takes place? So this is just one example. We started using NML, National Metallurgical Laboratories facilities, where I had put actually an acoustic emission. In IIT Kharagpur, I had one. In NML also we had one. But in Tata Steel, when Monideepa was working, we went for a transducer and started looking at some of the signals that come out. And the signals will tell us, it will be a telltale story where the transformation takes place. So at a different strain rate we put, and we found how the signals are coming. From that we know that so this is the general observation for the acoustic emission study. As a matter of fact, today acoustic emission is used for various other purposes. For welding penetration, it is used. For phase transformation, it is used. So current scenario, roof cross, I have already showed to you. This is an interesting slide. With listening to all that, you will ask me how much of the advanced high strength steels actually are used in the US or somewhere. 2020, this is actually a figure. Our collaborators were in Colorado School of Mines, in the Advanced Products and Process Research Institute, Professor Dave Matlock and John Deere. So they have most of the data. Incidentally, John is now credited with the fact that he is the innovator of maximum number of patents on the quench partitioning steels in Colorado. But in spite of all that, the total amount of high strength steels which you use in the automotive is 15%. In European situation, slightly higher. So the first generation steel are only these. These are high strength because you're talking of 800, 900, but the elongation is slightly lower. This is what we are talking about. Now, what I want to tell you was, in the second generation, the stainless steel comes and the twin induced plasticity, but they contain high amount of manganese. Please bear that in mind, higher amount of manganese. Manganese is one which is lighter than iron. So this is where actually one of the future developments can take place. We can have actually higher manganese steels in the norm. I'm not talking of the stainless steels. Next door you have the general stainless people. They have the maximum amount of manganese in the stainless, where the nickel is very costly in India. So therefore, instead of 8 and 8, 8% nickel, they will put 2% nickel. Balance is by the manganese. And with manganese, it is not too bad because the weight is slightly lower with manganese. Now, this is an interesting point which has come up in the past 10 years or so. Even in Bangalore and in Pune now, we have some press hardening steels today. So what you are doing here is, you are doing the pressing inside the press, and in the press there are millions of small perforations, and through these perforations, as soon as the pressing is over at high temperature, through the perforations the water will flow and it will immediately quench. So you call it press hardening. You are pressing and immediately hardening also. So with the press hardening, a lot of other properties, I'm not going into that. What I'm trying to tell you is, the tensile properties don't tell you the whole story. In other words, elongation, increasing the elongation or not reducing the elongation doesn't tell you the whole story, because there are other formability characteristics. We'll talk about it in a minute's time. So the whole expansion, for example, those of you who know about the wheel of a vehicle, on the wheel of a vehicle, a small portion comes out like that, and that is connected with other things. Even in these the air conditioners, previously when I was young, we used to see a lot of crackings very early actually, because the copper tube which is connected, it used to crack there. The expansion properties of copper and the steel, they're so different. So they used to crack inside because the welding or brazing was not taking place properly. With a hole expansion test, if I put another sheet which has high flangeability, it means you push a rod and you have a small flange coming out, a hole and then a flange, and you weld actually the copper tube with the flange. If you do that, then the failure doesn't take place. That's what happened. So the whole expansion test, etc. So sheet steels, you have to do welding, joining, formability, spring back. This is one of the problems. In the spring back, if you're press forming it, and then You take it out of the press, again there will be spring back. So that spring back is something which the automotive man doesn't like. So he takes the steel, high strength steel, all right, and now how will you design? And not only that, to make the situation very complex, the spring back, 2 minutes?
20 minutes gone.
Gone. So 2 minutes. He's not telling that in 2 minutes you close. Thank you very much. No. Okay, thank you. Then 2 minutes I'm actually. So press hardening is taking place. Now, in the high strength steels, I just want to show this slide, which is really looking like the 2023 slide. It is ICME approach to the third generation. ICME is the integrated computerized or computational materials engineering. Integrated computational materials engineering, which means that you can have the molecular model to the automotive. The scale is very, very different from the nano to from the molecular to nano to meso and then the large scale. So that you can combine. So now I think the last 2-3 slides. All steel makers of today, the high strength steels that we are talking about, we are joining hands with automotive. And now that Dr. Janjua, you are listening, so therefore the Auto Steel Partnership Program is actually taking place through the World Steel Organization, World Steel Association. So they have it's a full organization by itself, and not just that, they have started offering courses now. Auto Steel Partnership Program, they have O-level courses, T-level courses, because designers and the steel makers, I repeat, designers and steel makers will have to come together so that the component can be produced. This is the point I want to make. So therefore, this was the future opportunity 2 years back. Today we already have the third generation AHSS. You'll see here that in the third generation steel, we have actually the steels which are quench partitioned, and that quench partitioning tells you even higher properties it will give. The zinc coated materials, there is a possibility, this is another concern, that there is can anybody tell me what is LME? This is a liquid metal embrittlement. So if you have zinc coating, the zinc actually, or if you have copper, then it will become melting, it will be melting at higher temperature, and it can go through the gun boundaries, make it brittle. So the Auto Steel Partnership Program, which is basically supported by the World Steel Association, and Dr. Janjua will be speaking to us very soon. This is summarizing the whole thing, Auto Steel Partnership Program. This is quite a busy slide, but I will not venture into all the details. Suffice it to say that this is Industry 4.0, sustainability, standardization. So this time is now, and this one is later. This is what we are talking about. So we are talking about the materials, we are talking about the modeling, we are talking about joining. So welding is very important, forming, and other properties. So finally, if you have that, then the automotive will come. And benefits of Taylor blanks. This is actual Taylor blanks in various components of automotive. You have smaller components. They are produced from the smaller parts. Another important thing is today, the World Steel Association and the Auto Steel, we are talking of high strain rate testings. These are not available everywhere in this country or in many places. So therefore, high strain rate is very important. Why is that important? Because we want to form a steel at high strain rate is one, and a high strain rate also simulates the crash positions. We don't know the property of a steel at high strain rate. If you don't know, you will not be able to predict and design. It's a very important thing, which is what the World Steel Association is facilitating today for the rest of the steel companies. So high strain rate properties are important. So these are the kinds of things. So the Auto Steel Partnership Technology Roadmap is actually stamping, tooling, joining. Unless these are done, you can't sell your steel, high strength steel. This is all that I wanted to say. So I will not go through this. So this is the summary. And steel continues, of course, to the most dominant material, holds a fascination for use in this, and newer high performance steels for third generation steels on site. So if you start using these ultra high strength steels with concurrent properties of the ductility and formability, then only it will make sense. This is all that I want to say. Thank you very much.
Thank you, sir, very much. In fact, you have finished at right times. I have only 23 minutes. That is wonderful, sir.
Thank
and
you.
since our this is a very important section. We have our very important speaker, Dr. Ridwan Zanzua. He's speaking from Brussels. He will be, so we will plan this way that the question answer session is also 10 minutes. I think both the speakers after finishing, we will take question answer sessions of 10 minutes. There after that, our co-moderator will sum it up. So my request is that those who have had some questions, please pass it on to us. Pass it on to us so that we can put it in our last 10 minutes questions. Or you can obviously a small crowd, one can raise hands and speak. So now we will go listen to Dr. Ridwan, but we are privileged and very honored to have Dr. Ridwan with us from Brussels. To those of you, those of us who do not know him, he is a very important person in the world. Presently, he is head of technology at World Steel Association and is responsible for leading World Steel's activities in the field of technology. So basically, Dr. Zanzua holds a Master Science in Mechanical Engineering from University of Dalarna in Sweden and PhD in Material Sciences from TU Bergen Academy, Frisbee, Germany. Our previous speakers also he had his PhD from Germany. Dr. Zanzua joined the steel industry in 2002, just 20 years back, and has been involved in process technology, energy, recycling, process yield, and maintenance and reliability. So he is the secretary also to the World Steel Technology Committee. There is a carbon dioxide breakthrough program, whatever we discussed in the morning, and leads the Step Up program, which is aimed at improvements in mill operations to efficiency level of commensurates with all this. His CV is there with us. He led the flagship project, premature wear of copper staves in blast furnaces, etc. And he has represented the steel industry in technical discussions on energy and climate change in IEA, IRNA, and OECD, and reviewed several technical papers. So with welcome to Dr. Zanzua, please. So can you please, Dr. Zanzua, can you start your presentation now?
Thank you very much. Can you hear me?
Yes. Thank you.
Thanks.
Yeah.
Yes, thanks a lot. Thanks a lot, dear colleagues, for inviting me. I feel a bit overwhelmed. Sitting among the giants, I will do my best to try to really highlight some of those issues that are knocking on our doors. So with that, let me begin my presentation here. So I'll just go through a few of the CO2 mitigation targets. We will have a look on the steelmaking landscape. So we all talk about the targets of 2030, 2040, 2050. So we will see how the steelmaking looks like. And of course, nobody knows the future. We can only make a few projections, and then we'll see how it looks like. And then we'll talk about a few of those strategies or technologies that the steel industry is working on. And then what's the status, where we are standing there. And we'll just conclude the presentation right afterwards. So you might be familiar with the International Energy Agency, which is based in Paris. And the International Energy Agency, shortened as IEA, works with the government agencies as well as the several industrial sectors. So their steel technology roadmap came out in 2020, and that included some of those targets that are meant for the steel industry to lower its carbon emissions. So if we stand at, let's say, 2019 and look forward how it looks like all those CO2 emissions that need to reduce by 2050. So there are two scenarios that the IEA has been working with. One of those are based on all the pledges that the governments have made internationally. So according to that scenario, the steel industry emissions need to go down to roughly 1.1 ton of CO2 per ton of crude steel. So it is already a large enough target for the steel industry. But there is another scenario that they have worked with, which will involve quite dramatic or drastic measures taken up by the steel industry involving a lot of carbon capture and storage and use of breakthrough technologies. And that will lower the CO2 emissions to 0.6 ton of CO2 per ton of crude steel. So that means that, yeah, that dramatic reduction looks roughly 50% by 2050 compared to 2019. And if we look at the energy side, and of course, energy is an important component. You need energy to reduce iron ore and to melt scrap, but that can be only lowered to a certain extent. So that is not going to dramatically change there, but still we need to become much more efficient in our use of energy. So that is also another important challenge that, yeah, we need to have a bearing on. So how do we go about making those, how do we go about meeting those challenges? So IEA has come up with quite a handful of measures that are likely to be taken up by different geographies around the world. And of course, Mother Nature has not blessed everybody with the same conditions. So we will see that changes taking place around the world in a different fashion. So the first measure that IEA emphasizes on is the material efficiency. And that means by the more effective use of steel, as Professor Mohanty was highlighting there, one of those things is that, yeah, we use less steel with a higher performance. And we use it over a longer period of time. We try to make sure that, yeah, we are not overusing steel, but we rather either reuse it or recycle it and try to prolong its life cycle. The next measure is the technology performance. So that means that, yeah, we try to use the technologies to the best level of their performance. I am going to highlight that component a bit further in my presentation. The next measure is the electrification, for example, using more and more of scrap in the EAF furnaces. And of course, that depends on the provision of electrical energy, which is envisioned to be more and more green in the future. And then we are heading towards the breakthrough component of those transformations, and that means the hydrogen-based reduction. We're going to see where we are further down the presentation there. And then we are talking about the use of bioenergy, biofuels, and then shifting the fuels from coal to natural gas and eventually to hydrogen. And then, of course, any shortfall in energy would need to be met by carbon capture and storage or reuse. So let's see how the steelmaking landscape looks like by 2050. So right now we stand roughly on a global level, 72% of the iron and steel making taking place using the primary route. So that's the most dominant one. And 28% is the EAF. By 2050, that flips on its head. So we have got more of steel coming out of the electric arc furnace route and less from the BOF. So that same transformation we should be able to see if the technology stays the same in terms of the share of metallics in the steel industry. But that figure does not accurately represent the situation in 2050. So there we see that there is quite a bit of steel coming out of the EF in comparison to the BOF or the primary route, but quite a lot of that iron making component is going to go via the arc furnace route. So that means there's going to be a tremendous amount of increase in the direct reduction. And that is going to become the third route in iron and steel making. So here is the slide that I'm going to spend a bit of time on, and I would request your attention on, that if we look at the transformation that is taking place in the steel industry, going from the current status quo into the future, the vision of that future is that we are going to make more and more sustainable steel. So the first stage is the optimization stage, where we use the current technology, try to use it in the best possible way. You might be familiar with, at least those people who are from Tata Steel or from JSW, that we have started a program, we call it Step Up Program, where we try to emphasize the role of beneficiation of raw materials, process improvement, yield loss reduction in the upstream part, energy saving, and all these measures can still give us a bit of CO2 reduction, 5 to 10% for every steelmaking site. So this has been tried and tested, and we have covered roughly over 25 sites around the world. So this program is open to all World Steel members. They can join in, and then we try to promote best practices. So whatever we learn from one side, we try to shift the focus on such kind of measures that can really make that difference there. So every site has that possibility. We can try to squeeze a tiny bit of more and more efficiency from the existing assets and existing technologies. So that optimization can only take us so far until we hit the ceiling. So what are we limited by then? It is, in fact, when we reach that level, then we realize that the existing raw material or the technologies that we have at our disposal, they can only make so much change. So in order to make further change, we are talking into the transition phase, which is the second phase, where we still use current technology, but we retrofit, for example, blast furnaces or even the arc furnaces with carbon capture and storage. We try to capture carbon and then try to keep it in a closed loop as long as possible, calling it carbon recycling. It has been tried in Japan and in India. We try to inject hydrogen, try to further reduce the use of coal by using more PCI and hydrogen in blast furnaces or with biomass. So you can squeeze a bit further efficiency from the existing technology. But again, we will reach another situation where we have exploited everything that was possible there using the current base of our assets. So these stages will probably take a bit longer in trying to realize that potential, at least in the regions which have got a younger fleet of blast furnaces, and that means China and India. So in both the stages, I have highlighted there, actually, the quality of raw materials is the one that is going to just make us realize that, yeah, we have reached that level there, when we cannot squeeze further possibilities out of the existing assets. And now we reach the third one, which is the use of breakthrough technologies. We are working on those breakthrough technologies, trying to develop the hydrogen reduction on a pilot scale. We know that, yeah, it is taking place in Europe, but we have not reached that level of maturity which can really deliver those iron and steel making at a large scale, at an economical rate there. So what are those barriers there? Again, we are going to touch upon that in the further slides there. What we are trying to do is that we use hydrogen instead of carbon to reduce iron ores. But that makes only sense if the hydrogen is made using renewable energies. So there are some bottlenecks there which we have to overcome. But when we look at those current technologies, they are all targeting high quality iron ore. And there is only so much of that around the world. So those technologies, they are not targeting the medium quality ore or the lower quality iron ore, which is far more prevalent around the world. So again, in all of those stages, we see that raw material quality is going to play an important part as the limiting factor, how quickly we can shift from one stage to the next one. So looking at the direct reduction, how do we see that in the future? As I said, that direct reduction is going to become the third most important component in iron and steel making routes. Right now, we have got roughly 5% of the iron and steel made using that route, which is equivalent to around 100 million tons. By 2050, that is going to grow roughly 4.5 to 5 times, and that means around 500 million tons. And that means that there is going to be quite a large expansion in the direct reduction. And that means that, yeah, we need to start developing at least one DR unit every few months until 2050. So it's quite a tall order. And that also makes a strong case for us to start working on technologies which are not only targeted at the higher grade iron ores, but to the medium and the lower quality iron ores. As I said, that it is realistic to envisage that not all the industry will have access to clean energy or the renewable energy. And of course, when the clean energy or the renewable energy comes at a price also, so everybody around the world will have to pay a certain price there. So not everybody has got access to such amount of funds there. So how do we make up for the shortfall if we have to deliver deep carbonization? So we have to start working on carbon capture and storage. It's a proven technology, but there are some certain barriers there. For example, the public perception. How do we make sure that, yeah, we can work on a cluster model of different industries working together using the sharing the pipeline? We need to find the right deposits or the sites where we can deposit the captured carbon. So again, we stand at a very, very small share of carbon capture and storage. There is a demonstration plant working in the UAE. So if we look at that size and the expected share of carbon capture and storage that is going to be required, so we are talking about roughly 500 million tons of carbon that needs to be captured and stored. So that means that, yeah, we need to start building such kind of sites every few weeks until 2030. So this is something worth considering for the steel industry. So now let's spend a bit of time on hydrogen-based reduction. How does that look like? As I said earlier, most of those technologies that are being worked on, they target the high quality iron ore, and there is only so much of that to go around the world. Most of the steel grade, most of the ore grades are lower and medium quality. And of course, the choice of technology is determined by the mineralogy, the granulometry, and the chemical composition. How easily we can isolate gangue, silica, alumina using, let's say, hydrogen. So there are certain barriers in the technology that we need to overcome. Most of those technologies, as I was saying there, if we look at the left-hand side of this chart, are targeted at the high-grade iron ore. So they are getting quite mature. They are at the technology readiness level 5 to 8. So this is a terminology used by NASA. 9 is the top grade when it means that the technology has achieved the commercial scale. All of those technologies, they are at a demonstration level and they still have to achieve the commercial scale. But again, there will be a certain price for hydrogen that the steel will be made at. And right now, all of those talks about the availability of such steels and their customers, they are automotive, which are able to pay a higher premium for those green steels. But if we have to expand that, we have to start working on the other iron ore grades also. So that's the fact that, I would really like to highlight here, that we have to target the low to medium grade iron ores as well. As Professor Mohanty and other colleagues have highlighted, that I am secretary to the World Steel Technology Committee. And together with that, I have run an expert group on the CO2 breakthrough programs. We carried out a survey recently. And in that survey, we found out some challenges and the bottlenecks that really are preventing the progression of the hydrogen-based iron and steel making. And those challenges, namely, are large-scale hydrogen storage. In the next slides, I will tell you what I mean with that. There's a lack of know-how in hydrogen metallurgy. There is high energy consumption. And again, when we are talking about the energy use, we are talking about the use of renewable energy. So if it is already scarce, we do not want to waste any of the energy. There's a lack of know-how in the specialist handling and safety of hydrogen. The oil and gas industry has been using hydrogen for a very long time, but that use has been very, very low pressures. So we are talking about pressures of over 800 bars. And that's a phenomenal amount of pressure. The other bottlenecks are scale up. The large volumes will be required there. We simply do not have enough renewable energy as yet. Most of those technologies are targeted at high quality grades. So we do not have any solution for low grade to medium grade ores. So if we look at those challenges, they are common to all of those technologies. So that means the direct reduction and the smelting reduction, it doesn't matter whatever grades they target there. So hydrogen handling and storage is one large component there. Utilization of hydrogen and recuperation is also one among them. Having spoken to all those experts who are working in these programs, you will understand that in one cycle or one pass of hydrogen use, not all of that hydrogen is reacted. So roughly 50 to 60% of the hydrogen in the first pass goes unreacted. Because it is expensive, you do not want to let it out in the air. First, it is considered a greenhouse gas. You have to burn it. So why would you burn an expensive gas? So you want to make sure that whatever is not reacted, you capture it and you reuse that in the process as long as possible. The other thing is that in areas where you have got already scarcity of water, when you make hydrogen-based steel, the off gas is water vapor. You do not want to let it out in the air. There might be microclimates around the steelworks. So you have to capture that water, condense it, try to extract sensible heat from that. So we don't have those solutions as yet. Melting and refining of high gangue DRI, again, when we work with the lower quality iron ores, we will have that come across that solution, that problem there. We don't know yet what type of slags we are going to get. Are they going to be of the comparable quality like we get from blast furnaces? Where we have got solutions that you can start using it in the construction industry or paving of roads. But those slags coming out of the hydrogen reduction, we don't know. So all of these are unsolved questions there. We are trying to create a proposal for the global steel industry that they can really join forces and then try to find the solution, the answer to these solutions, irrespective of whatever technology we are developing. So these are the stumbling blocks on the road. So if we can find the solution, we can actually accelerate the pace of development for the progression of hydrogen-based metallurgy. So that proposal is being worked on, and we are going to discuss that with the World Steel executives, and then I'm very hopeful that we are going to come up with another program, the like of World Auto Steel and then other opt-in programs that we have. So let me give you an example of the challenges in the hydrogen storage. So if we take a site of 5 million tons capacity, how much hydrogen will be required? That site will consume 44 tons of hydrogen in 1 hour. If we have a medium-sized electrolyzer, let's say 10 megawatt, that electrolyzer will need 1 week to produce that amount of hydrogen. So consider that for a second. So how much hydrogen will be required in a year? So over 385,000 tons. And because we are working with the intermittent renewable energy, the sun doesn't always shine, the wind always doesn't blow. So we want to have kind of a safety buffer. So we need to have at least 1 week of storage of hydrogen. And that is roughly over 7,000 tons at site. Why do we need to store hydrogen at a pressure? So if we look at the different densities, methane is a comparable gas because we already use it in the direct reduction. It has got a certain density, but if we compare that density with hydrogen, it is 500 times more dense than methane. So that means in 1 cubic meter at a standard temperature and pressure, we can get only 90 grams of hydrogen. So we want to pressurize it, bring it to more or less the same density as methane. But for that, we have to pressurize it to roughly 800 bars. And even 1 bar is quite a tremendous amount of pressure there. So we want to have kind of a storage which is safe enough. Those of you who might have had the chance to have a look at the pilot facility which is being built or is working in Sweden, that facility is working at roughly 200 bars. They have tried to play it safe, but in order to still be on the safe side, they have gone 100 meters in the ground, and it's a rock cavern. It's a very, very hard rock. I think it is either basalt or it is granite. So going 100 meters down, building a vessel there, and then covering the hole at the top with concrete. So how much storage will be required there? We are talking about roughly 5 tankers, standard size. So that's the amount of hydrogen you want to store at the site. And right now, nobody is comfortable to have that much hydrogen at that much pressure on the site, because the way the steelworks were built is that you build the steelworks away from the community, and now we have got most of them as brownfield sites, and the cities have sprung up around them. So we have to answer some of those safety questions that will be asked by the regulators, that do you know what you're working with? So I hope I have not taken too much of the time. I will just conclude that the steel industry is a large part of the large ecosystem. So we are not working in isolation. Whatever happens in the society, we are affected by that as well. So the society at large is thinking about decarbonization. We are equally serious. So whatever problems are there faced by the society, we are faced with them as well. And because we stand at the beginning of a very large processing chain, so we get that information and the requirement from the end customers and all of those questions that need to be answered. Automotive is one of those industries which is asking more and more of green steels. So we have to start working on those. The climate change mitigation cannot be realized because of these 2 factors by the steel industry alone. So I've got a feeling that, all of those answers will be realized by the industries in conjunction with the rest of the society. But we cannot underestimate the role of technology, because the humans are extremely resilient, and innovation cannot be hampered by the lack of resources. It always sits in the mind. The more we are starved of resources, the more innovative humans become. But in order to really go forward, we have to have kind of an open dialogue with each other and the spirit of working together. And that is the only way forward for the industry. So with that, I thank you very much for your attention. I hope you have not been bored too much, but if there are any questions, I think we will be taking them shortly. Thank you very much for your attention.
Thank you, Dr. Rajwan. It was a wonderful lecture, and I think all of us enjoy it too keenly, because both the speakers in this session, they talk of tomorrow, what is going to happen, the steel making the real core issue. And the challenges are definitely huge, but until unless you dream it, you cannot achieve it. So therefore, tomorrow will be a fantastic world for us as far as the steel making is concerned. But now with this, we'll have open to the question and answer session. Yes, those who have any, both the speakers as well as after these two speakers, probably previous session also we missed it. So we can presently, if everybody agrees, the 10 minutes for the presentation, the question and answer, and then followed by the other speakers. So questions, please, anyone?
I have
Any?
a question at Rijwan.
Yeah.
Dr. Jinjua, this is Omkar Mohanty. Good afternoon. You showed about the future paths, indicated about how from BOF route, one should actually be migrating more towards the electric furnace route. I wanted to bring to your notice, as you would be knowing better than most of us, in India, that is already the case. In India, the ratio is 45 to 55, 45 being the BOF, and the 55 is 26 plus 29. That is the electric arc furnace is 25 and 26, pardon me, and 29 is the electric induction furnace. So do you think this is a kind of optimum that we have struck in India, which is a kind of model for the other countries to follow?
Yeah, thanks, Dr. Mohanty. As I was highlighting there, that situation might be slightly different around the world. If you have got access to surplus or sufficient amount of ferrous scrap, you would be able to utilize that. And of course, it makes a compelling case. The governments are also going to use the carrot and stick methodology. They are going to incentivize or they are going to penalize, depending on that. Yeah, if there is a lot of scrap there, then they will try to force the industry to start using more and more. Yes, such kind of model can work depending on how mature the economy is in a given area. We have got some similar kind of expectations on China as well, that yeah, after 2030, we will start more and more use of scrap there, and the EFs are going to become quite prominent. So it will be like that as any economy becomes more and more mature.
With your permission, there is a connection which I might also ask. Another allied question with this is that in India, the induction furnace which we use, it is not a smelting furnace. It is only a melting furnace. As a result, in the induction furnaces, we really cannot do the dephosphorylation. So some of our induction furnace manufacturers or steel makers, they have started actually innovating by pouring in slag into the system. And that is how they would expect with the right amount of slag and the temperature, you would have some dephosphorylation taking place. I might also tell our people who have gathered here, about 5 years back, Government of India, Ministry of Steel actually came out with a circular that particularly for big embankments, if you are using thick TMT rebars, do not use the electric induction furnace route. And that caused a lot of furor in India. And they came out with applications and so on against this order, essentially because of the phosphorus part. So therefore, in China, I don't think the phosphorus, sorry, the induction furnace is as much used as in India. So this is one of the major things which I wanted to tell you about the induction furnace, but that gave us a lot of flexibility. When the other countries were suffering, India was able to go through the COVID period and the other periods also because of the routes that we have followed. So now I think the induction furnace in India, they have come of age. We have started learning how to use induction furnace also for making cleaner steels, and maybe it can become a route if we can teach them or we learn ourselves from that route. Thank you.
Yeah, it depends really. You talked about China. They had quite a significant portion of induction furnaces, but they started crack down on those furnaces because of the environmental concerns, because the sector was not regulated. It was very fragmented, and they didn't know what to do about that. So they started the regulation on a federal level, and then it percolated to the provincial level. But I think more or less they got a handle on the arc furnaces, on the induction furnaces. In comparison to the mini mills, I think they're called, those sites are called micro sites. In India, I do not know the situation there, how the environmental regulation is, and how nicely it is regulated. The induction steelmaking sites, they don't need to be necessarily polluting. Depending on how nicely you can really control the emissions, it might be a way. So I'm really not able to comment on that. I know that there are some OEMs which are promoting the use of this technology also, and they boast about the environmental friendliness of the induction steelmaking. So it's really hard for me to comment on this.
One of the things that will also characterize the Indian steelmaking process is how do we actually start using our effluents, particularly all the solid effluents from the steelmaking slag and the arc furnace slag also. So therefore, that slag which contains high phosphorus, we were talking during the lunch hour with some of the steel makers, including Tata Steel's chief here, that how does one use these slag, the steel making slag, because that is being used only for the land refill or actually for road making and the low end use of that. The high end use of that for making it cement itself, because it contains very high amount of calcium, and we have not started using them for a high value product. And that's, to my mind, a very important area where if we know how to use that, will give us double advantage. I wanted to make that point.
Sure.
Thank you so much. Let's give him a round of applause.
Thank you.
And yeah, please. Dr. Rizwan, please stay back.
Dr. Rizwan, good afternoon. I'm Dr.
Please
Khotoi.
introduce yourself.
Yeah, I'm Dr. Khotoi. Basically, you mentioned about hydrogen reduction. What is an endothermic reaction where it requires additional heat? Point 1, point 2, you say that 50% goes out without circulation. So you have to recapture and again reuse. So where from we give the heat when you go 100% with only hydrogen reduction, because hydrogen plus CO, when we put in the gas vertical shaft kilns, it is working. But along with only hydrogen, how do we give heat and from which source? Thank you.
That's a very interesting question. And then if you want to quantify that in terms of how much of the heat is required, hydrogen is an excellent coolant. That's the reason why it is used as a coolant in the turbines in power plants. So you need to provide the reaction energy, and that is roughly constitutes 20% of the overall energy requirement for the reaction. So this large amount of energy. Right now in the pilot projects, they provide it using electrical energy by using electric heaters, and some outlandish claims also that, yeah, oh, that is not a problem there. We can use extra hydrogen. We burn hydrogen, get the extra, we burn extra hydrogen, and we get the reaction heat, which is, in my opinion, not a very good solution. So we need to find how we can add the chemical energy to the reaction, but we don't have a very viable or workable solution to that as yet.
Thank you. Thank you very much.
Thank you so much. And before now, there is any more questions from the crowd? So therefore, we thank profusely Dr. Rizwan very much. And in the next visit to India, probably, I don't think have you attended any seminar from organized in India yet?
I have unfortunately not yet.
So we claim the credit of having organized with you the first time in India, and probably we look for more interaction, particularly World Steel Association. And with this, I'll request my co-moderator to sum it up within 1 minute. What has happened?
Thank you very much, Dr. Mohanty. I feel it really a great honor and a privilege, and at the same time, I feel humbled to summarize a presentation made by my own teacher, who is a towering personality in metallurgy and material science technology, and Dr. Rizwan, who is in world authority. Nevertheless, duties have to be performed. So friends, we have been discussing steel making. We have been making sustainable steel making from the morning. And therefore, as we all know, steel making today are facing three-phased pressures. The pressure of making it more and more eco-friendly and therefore sustainable. At the same time, steel making also is meeting a great pressure on specific specifications and demands of the sectorial customers, which Professor Mohanty elaborated a lot. And also, steel making is facing pressure from competitors, substitutes like composites coming from aluminum, titanium, and so forth. So in this scenario, we couldn't have probably had a better situation than the two stalwarts who presented their lifetime's experience in Professor Mohanty and Dr. Rizwan. Professor Mohanty, in his presentation, told us, you see, even if 50% of the entire steel production is used in construction sector, and out of that, 12% is used in auto sector, only 15% out of that, which makes about 2% of the total steel production, makes of special steel. Nevertheless, that becomes an important area, and that's the growth area in future steel making in technology. And therefore, he also let the House know that for the last 3 decades, the maximum of attention of the R&D in steel making, newer steel, better steel, is in this sector. We also heard from Dr. Rizwan a global scenario about the different aspects of making sustainable steel making. He emphasized the facets of steel making landscape, the carbon capture, hydrogen-based reductions, bioenergy, fuel shifting, and he also suggested that we need to look at it as a composite model, as a part of a large ecosystem, instead of looking at an individual or compartmentalized ecosystem. Friends, I don't think we need any further elaboration than the lucid presentation that both of these stalwarts made to us. And with this sum up, I think we can once again give a big hand to both our speakers. And thank you very much, Dr. Rizwan and Professor Mohanty. Thank you very much.
Thank you very much. And now our
Thank you very much.
session ends. And third session begins, but I request Dr. Rizwan, he can continue to listen to us other speakers as well if he likes. And now over to our convener, Dr. Farooq, please. Thank you all.
Hello. Thank you, Dr. Rajgopal Mahanti and Mr. Adhikari for coordinating this session. Now we enter the final and third session on logistics. I request, we have got three presentations, three speakers, and Mr. G.P. Mahapatra, former Additional Director General of Geological Survey of India, will be taking over as moderator with Mr. Anup Kumar Raut. Mr. Anup Kumar Raut, please, as co-moderator. Mr. Mahapatra, please take over.
Good afternoon, sir, everybody. So I think 40 minutes we have already lagged behind. So our allotment time is 1 hour, 15 minutes. Probably I think all the speakers, they will be very judicious in distributing the time. Sir, may I have, I think Anup be there. The technical session, we are going directly to minimize the time, sir. First is port infrastructure. It will be given by Santosh Kumar, Sri Santosh Kumar Mahapatra, ex-CEO, Dhamra. And I will give a brief introduction about this one, whatever I am having, sir. So, yeah, that is there, sir, but let me have mine also. It may be adding or it may be lesser than. So he is former IAS Gujarat cadre from 1976 batch, served in senior positions in government and public sectors. He was Secretary Industries, Government of Gujarat, CEO, Gujarat Infrastructure Development Board, MD Sardar Sarovar Narmada Nigam Limited, Chairman Paradip Port Trust, CEO Dhamra Port Company Limited, and Director and CEO of Adani Vizhinjam Port Limited. Sir, I don't know what is the pronunciation of that one. Yeah, whatever it is there, I think he can correct me if it is like that. So that is his, just a brief one. Other things are there. So may I request the pleasure of Sri Santosh Kumar Mahapatra to present on the port infrastructure. Sure, please.
Esteemed members of the Society of Geoscientists and esteemed participants from a very heavily technical subject like steel making, we would be talking about more mundane and less technical, but perhaps highly essential aspect of steel making called logistics. I'd be, of course, more comfortable with the presentation. Is it going to take a little time? Okay. I thought, we must know what exactly our objectives are. So for today's discussion, I adopted the objectives. Okay, thank you so much. The objectives set out in the National Steel Policy of 1917. Which says that by 2030, we should be able to produce 300 million tons of steel in the country. And the per capita consumption should go up to 160 tons from the present 70 tons. Although I have never really understood why we should have something called an objective of per capita consumption of steel. There used to be per capita consumption of power, per capita consumption of steel, rather old-fashioned indicators of economic development. I mean, it's not like a human being needs steel like he needs protein or nutrition or anything. We need steel for infrastructure. We need steel for machinery, equipments, construction. And it's possible that the same amount of infrastructure in a sparsely populated country serves a lesser number of people than in another country which is more densely populated. Therefore, the per capita consumption of steel is rather a very outdated objective. And But that's not the subject I'm here to talk about. I wanted to go ahead with the presentation. Yeah. I'd be also looking at that. Can I change it by any? This. Okay. Okay, right. So these are the objectives of the national steel policy I was talking about. But as I said, we are more concerned with the production of 300 million tons of steel, which in turn would require raw materials of something like more than 800 million tons, which would include iron ore, coking coal, non-coking coal, of two types: natural gas, manganese, chromite, limestone, and scrap, ferroalloys and scrap. From the logistics point of view and from the port point of view, those in blue are the ones that need to move by ports either fully or partially. You may say iron ore is a domestically available. Tons of iron ore and another 4 million tons of pellets to other parts of India for steel making. So ports also imported through ports almost. Although one of the objectives of this policy is to reduce the dependence on imported coking coal from 85% to 65%. And non-coking coal PCI also is almost fully imported. The other non-coking coal is partly domestic and partly imported. Limestone is almost fully imported. I mean, large part, at least 2/3 of it is imported. And scrap, yes. Now, where do I show it actually? The machine must be somewhere else, no? Okay. Okay, but the policy also mentions about logistics as being very important for the steel industry. And and the points which are relevant to us that the government should invest heavily in evacuation infrastructure, and we should have port-led development of steel clusters, and we should enhance the capacity of coking coal importing ports and develop coastal transport and inland waterways. The total volume to be moved in that sense would become, including the finished steel, about 1,155 million tons. So to produce 300 million tons, we will be involved in transportation of a total of 11. To 8, and we are 16 to 17. Earlier I had read somewhere it is 8 and 12, but in any case in India, the share of logistics as a part of, as a percentage of cost of production is almost twice that of the rest of the world. And if we look at it in another way, about of the cost disadvantages that Indian steelmaking suffers from, logistics is next only to cost of finance. If you look at it as US dollar per ton, if we are spending $30 to $35 more, of course, this is again a dynamic situation. The rate of interest in many other countries have gone up. But if we spend about $30 US, we are spending more in India per ton towards the interest rate or cost of finance. Similarly, we are spending something like $25 per ton extra or additional for producing each ton of steel, which means that we are less competitive compared to others because of this, and because steel is a very very basic raw material for other products. This would in turn affect the competitiveness of other products which are made of steel. One of the reasons could be the share of road, rail, and waterway. If we compare India, China, and US, as much as 47% in China and 12% in US goes through the waterway, which is almost a quarter of the cost by road and half of the cost by rail. This could be one of the reasons why the cost is high. The game changers in terms of logistics cost could be perhaps one location of the steel plant near the port. A port can come near the mine, it can come near the port, or it can come in between. But experience shows that those that are nearest to the port perhaps have the least logistics cost, partly because the imported raw materials like limestone and coal doesn't require transportation on land. And if you have something like a slurry pipeline bringing the iron ore from the mine to the location, then you are almost independent of the Indian railway system, which is as good as freedom. It's another kind of freedom for any industry. Waterway, of course, again, can be a game changer. And fast evacuation and efficient discharge. In fact, I've mentioned these 5, and at one stage, these were merely kind of aspirations. Today, it's a reality. 2 of the largest steel plants in Odisha, as you read from media, are coming near the ports and with their own captive ports. Slurry pipelines, I'll show you another slide released from Government of Odisha. So there are at least 9 or 10 projects of slurry pipeline going on in the state right now. Waterway, the biggest and perhaps the happiest news during the last few months is that the National Waterway has finally sanctioned together with Coal India. It's a pity the steel industry didn't rise to the occasion. It's finally the coal industry, keeping the unblocking and the evacuation of the coal blocks in Talcher in mind, have come forward to spend a substantial share of the 12,000 crore that would be required to develop the fairway of the inland waterway from Talcher to Dhamra and Paradev through Brahmani and the allied river system, which will be a real game changer in terms of evacuation of the 2 ports, as well as cost of transportation inside or on land of not only coal from Talcher, but also for coking coal from the ports to the steel industry in Kalinganagar and in Angul region. And I don't know in how many more ways the industry will be able to take advantage of the waterway. First evacuation is quite a reality. I remember when I joined port in Paradeep, it was hardly 10,000 tons a day. Today, we guarantee 35,000 tons in Dhamra, although we achieve 45 to 50,000 tons a day in Dhamra. Efficient discharge. I mean, I'm not talking about evacuation. I talked of discharge. Evacuation is still a problem. Yeah. In spite of the privatization of the ownership of wagons and rakes, there are times when we do have a problem of evacuation. This is the list of pipeline projects in Odisha. This is a map of the inland waterway. I have already discussed it. This can be a real game changer. So the other objective is to increase capacity, as I said, cost, capacity, and the sustainability. Even if we reduce the imported coking coal from 85% to 65%, we'll still need to handle about 104 million ton of coking coal, then 86 limestone and 18 iron ore by coastal transport and steel. These figures are uncertain, but some volume will be there. I don't think handling 104 million tons of coking coal will be a problem by the ports per se. As it is in the last year, Dhamra handled about 13 million ton, which makes Dhamra the #1 port in India in handling coking coal. And I feel very proud because I was involved in building this port. And Paradip is handling 9, Haldia 11, Visakhapatnam about 8, and Gangavaram about. These are the main ports which handle coking coal. There are other ports also. But it seems like we are already handling 50 million ton. And all these ports are having surplus capacity right now and are also planning to expand their capacity. What is not figuring here, but can be a great boon to the steel industry, is a port at Subarnarekha by a company which is now owned by the Tata Steel. Majority share is held by the Tata Steel. And the location of Subarnarekha, which is further north of Dhamra, is just ideal to end the woes of what is now 11 million ton of coking coal being imported through Kolkata, Haldia, with all the limitations of drafts, which in turn leads to size of ship, and which in turn leads to the per day discharge rate, etc. So I don't think there is a problem with the capacity of the port, but the capacity of the port is actually dependent on the capacity of evacuation. I remember we had promised a capacity of 12 million ton of per berth in Dhamra, and when we started my board, the promoters, they started attacking me that the present capacity is not even exceeding 5 million ton. So when I fought with railways and they gave me just 2 more rakes a day from 5 to 7, we found that the capacity of the port went up from 5 million to 9 million ton. But I mean, the more the evacuation, the capacity of the port increases at a rate which is even higher than the rate at which you increase the evacuation. It's a kind of relationship. And evacuation is dependent on rake availability, as I just now said, track capacity, and also stacking capacity. But there's a limit to which the port can stack. I have seen situations in which the port user doesn't lift, and we say that why not, because I'm not getting the rakes. And then when we further inquire from the railways, we find that although they have indented for the rakes, they are not pursuing it. That's because back in their plant, the stackers are full and they're not very keen to lift it from the port. And that kind of situation can be very painful for the port and very harmful for the economy at large, because the port capacity is a very rare, precious capacity, which is being limited on account of overstacking. In the limited stack, it's no more open yard port like it used to be. Once you want a rate of 35,000 plus for discharging, it has to be through belts and stackers and reclaimers, which means that the stackers are also very limited plots to which all these machines can reach. And therefore, maybe for a 10 million ton capacity, you can have 3 to 4 million tons of stacking, not more than that. And if that is filled, the ships may be waiting in spite of the fact that the berth is ready and the machines, cranes are ready, but the ship cannot start functioning because there's no room where it can unload. Fortunately, now I come to the last point. I believe time is limited. The sustainability. Fortunately, the game changers for cost are the same as the game changers of sustainability. I have tried to give how the road is the highest polluting and the costliest method compared to rail, which is more costly and more polluting than waterway. And I do not have a full comparison with the pipeline. I followed the Wikipedia method that if I don't have a fact, I leave it blank, somebody else will fill it in. If somebody, I know pipeline would have a capital cost, but on the whole, it will be cheaper per ton. So I don't know whether it will be more than waterway or less than waterway, but it is certainly less than rail. So the more we move towards waterway and pipeline, the more we judiciously locate the steel plant, I suppose we can decrease the carbon footprint on a part-time basis. So that's all I wanted to say. Thank you very much.
Thank you, sir. Exactly, sir. Accurate time only you have taken, sir. We are very much thankful to you so that you have completed within the time and very well presented. We are very much obliged to you. Sir, I think without wasting further time, sir, we will go, sir. Go ahead with this one. Second talk. Sir, this is by Sri U.S. Ramchandran Raju, Vice President Operation AMNS. Topic is from mines to iron making, the environment friendly and cost effective transportation of raw material to finished good. Sir Raju, sir. Dr. Raju, sir, I think before you go there, sir, I will just have my introduction. Yeah, you please go there. He is the present Vice President of Head of Operation, Slurry Pipeline Pellet Plant, AMNS Port, Odisha Asset. And he has vast experience in mining, beneficiation, slurry pipeline, pelletization, and port operation. So all the logistic supports are you are having. Also associated with the tailing dam, construction and management. So this is your brief introduction from my side. Other things I think everybody who is interested, they can see from that one. So now to Dr. Raju, sir, it is handed over to you for your topic. Please go ahead.
Thank you, sir. Good afternoon to all. So today I'll be covering, as my previous said, whatever is there, game changer. So we are having in our facility. I would like to go through that. So from mines to iron making, this environmental friendly, cost effective transportation of raw material to the finished goods. So the basic idea behind this is, like sir said, is a strategic location of the plants are important. Then connecting by the cost effective transportation so that steel we can make economical and we can make a better steel. If you see now, we are having a mining, our own captive mines are there. Now we started building the grinding plant there itself so that we can avoid transportation from the mining to our beneficiation plant at Dabuna. So Dabuna is surrounded by many mines are there surrounded. So previously we were shifting from Sagasai, Tokarani, our captive mines by trucks to beneficiation plant. And that area is being congested. We have a lot of issues. Consistency is not there. Now we have started laying a pipeline. Already Sagasai we are connecting with pipeline. So we have a grinding system in mining itself so that after ground material will pump to beneficiation plant. From there we pump from Dabuna to Paradip. That is the pellet plant which is at Paradip. So 254-kilometer length pipeline is there. So we will be pumping from there to Paradip. Then in Paradip we make a pellet. After making the pellet, we have our own stockpile in the plant and we have a dedicated berth in port, Paradip port. So we have a conveyor system which conveys the pellet directly from plant to the port into the ship directly. There is no double handling. So we start our reclaimers in our plant and the vessel comes and we directly load through the ship loader into the ship. So there is no double handling there also. That is how it is connected. From there, through the vessel, the metal goes to Hazira where our steel plant is there. So our metal goes there. That's how it is. We have two plants in the Vizag 1 and Paradip. That is 8 million capacity of the same route. And Paradip also Odisha we're having in the same route to supply material to steel making at Hazira. Now you can see because of selection, we have made like blast furnace where we use lump ore and all. Now it is completely converted to pellet and center only we are using in the blast furnace. So that is how we economize and completely pellets are being used where we can use fines into pellets and pellets to BOF we are using. In Corex also, we have completely avoided lump ore and fine. There are also 100% pellets we are using now. And direct reduction, DRI also we are using 100% pellets. And scrap, we are using 10% on EAF. That is how, because of having pipeline and own mines, we are using the fines to convert into pellet. And we are using almost in all the areas 100% pellet in steel making. This is the advantage of hydro transportation, a sustainable and economic solution. You can see which all material can be transported to the pipeline. And this is a dynamic metal markets. Cost competitiveness is a major aspect of sustained operation. Slurry pipelines have aesthetic advantage over other modes of solid transportation by rail or road. The line which you have laid from Kirandul to Vizag, that is laid almost 20 years back. And within 2 years, we have gone by aerial survey. We could not find our pipeline because it is become already greenery again. The path cannot be traced. That is the advantage here. We are not disturbing the this one, nothing is affecting with the pipeline because we are laying the pipeline just below 1 meter the ground level. And wherever we are doing railway crossing, road crossing, river crossing, it is a horizontal drilling we are doing, horizontal direction drilling. So there is no disturbance in the land and everybody can use the path like normal. And after 2 years, it will be normal again. And people are using agriculture, everything they're doing on the pipeline area now. So we have only right of way, but people can use it. That's how it is. And minimum land is required for laying. It is like 500 or 600 only open pit we make and bury our pipeline. And slurry pipelines are environmental desirable as they do not cause noise, dust pollution, and negative visual impacts. And the cost of transportation for slurry pipeline is almost 1/10 of the by wagons by railways. So if you see from Kirandul to Vizag, we are transporting per ton, it is only 70 rupees per ton. At Odisha, from Dobna to Paradip, we are pumping at only 35 rupees per ton. I'll show you in detail how it is happening. So per kilometer, 254 kilometers, again we have to divide by that. It comes very low, sir. It's 254 kilometer length. And the low maintenance cost and higher availability because the type of pipe selection and the pumps what we are using there, that is the maintenance cost is less. And one more thing is there is no wastage at all, zero wastage because no spoolage, no double handling on the way. And we are transferring from beneficiation plant slurry tank to plant slurry tank at Paradip. It is only through pipeline. Now you can see 8 MMTPA slurry pipeline Kirandul to Vizag. Here you can see this is our plant and we have the plant here. No, this is the other one. We have to travel, suppose from the Baladella to Vishakhapatnam. This is the only route available and the railway track available, that is 440 kilometers. But with the help of the pipeline, we could lay straight from Baladella to directly to Vishakhapatnam. So that is the difference. So we start at 613 meters and we go down to almost like 185 mean sea level. Then again it goes to 865 MSL. Then it comes down to 4 MSL at Vishakhapatnam. And we have 4 stations, like one pumping station here, and we have a booster station here, and next to a wall station at Narsipatnam, and Vishakhapatnam, we are having the terminal station where pellet plant is there. Sir, here, this is the most difficult terrain what we have come across, and we are operating this pipeline last 19 years. So this has started from here PS1. This is called pumping station 1. It goes down like as I said 185. Then it comes up to 577. Then it goes down to 396. From here, it goes up to 879. That is the next peak when we are crossing the Eastern Ghat area. So we require a second pumping station to pump. That is called a booster pumping station. It is pumping to the second peak. Then it falls suddenly to Narsipatnam area. Wall station is there. And beauty in this pipeline is it is all 16-inch pipeline up to here. From here to here, it is only 14-inch to give a back pressure so that material should not rush and damage the pipeline. Then it goes normal to Vishakhapatnam. That is around 3 to 4 meter mean sea level. And here we are running from 19 years. We never had any problem, no choking, because we are maintaining water, almost 66% of solids and 34% water is there. And normally as per design, we should neither with water or slurry keep on pumping. We cannot park it. Suppose we have to park, we have to fill with water, then we have to park the material, so water there. But right now what we are doing with our experience, we are able to hold the material up to 8 hours also inside the pipeline without pumping. Because when there is a plant shutdown, we are not putting water in the pipeline. Now our pipeline is full with slurry or parking we are doing. We are not putting water at all. Even at Vizag, even at Odisha also now. And this is 12 MMTPA, Dobna to Paradip. Here advantage is the pipeline is parallel to the state highway and national highway. That is the advantage here. And we have only a single pumping station. Then we have a wall station at Paradeep. There's no other stations in between. And we have only monitoring stations, 5 monitoring stations are there, and the choke station at terminal station itself. So that is the advantage of this profile from Dabna to Paradeep. Here it starts at 504 MSL, then it goes down, next height is only 498 MSL, then comes down to 4 MSL. So it is all completely gravity, and this angle is also pipeline throughout, it is maintaining 8 degree. So advantage is we don't have any booster pump requirement and only single pump we are pumping. That is why the cost is less at Orissa. It is almost half the cost of Kirandul to Vizag. And if you see here, one more is next. Beauty of these pumps. I was telling you the maintenance of the pump is also less here. Like the advantage of this pump, these are non-contact slurry pump. So non-contact is whatever reciprocating pumps are there, this crosshead moves the piston. The piston moves the only oil which is there here, and oils, and there's a diaphragm which is there in between the slurry and the oil. So that this diaphragm moves forward, this chamber gets pressurized, this non-return valve gets opened and go to the main line. And when it moves back, this piston goes back, this oil pushes back the diaphragm, and from the suction line, slurry enters here. So in the whole pump concept, the pump, wherever the rotating parts are there, it is within the oil, and slurry, wherever it is moving, only 2 NRVs and 1 diaphragm is there. Here also per ton, the cost is coming only 11 rupees per ton, the maintenance of the pump. So this is called non-contact slurry pumps. Here, after getting slurry here in pellet plant, we are making pellets. The pellets are, as I said, from stockpile, we are directly conveying through the conveyors by crossing IFCO plant. Then it goes to port, Paradeep port, where we have dedicated berth CQ3. We are loading pellets directly into the vessel. So there is no storage requirement at Paradeep port. So it directly goes into the vessel. So normally whenever a vessel comes here, we start our conveyors and start our reclaimer, directly goes from here to there. And this cost comes to only 37 rupees per ton. We are consuming only 1.7 kilowatt per ton, sir. We are conveying from 9.3 kilometers. 9.3 kilometer pipeline. So it is consuming only 1.7 kilowatt per ton. And as I said, pipeline also, we are consuming only 3 kilowatt per ton, sir. So it is 17 rupees per ton per cost per power. And how our plant was made, because we have plant in Surat, and idea is from Paradeep and from Vizag. We have another pipeline from there. The vessels will sail from here. It takes 6 to 7 days to reach Hazira, and they produce steel at Hazira. That is how it was made. The advantage in the whole setup, as I said, layout and all, we are getting good reach over from Baladilla, which is almost 65. Initially we are getting, now 64, 63 we are getting. That goes from here. And from our plant, we send almost 63 Fe pellets. So when it goes there, they mix in the ratio, whatever required, depending on the Fe, alumina, they mix and they use in the plant. So Sar has already covered. This is what the road we have made with our slag from the BOF, including CSIR and CRRI. So just to show the road can be made with the slag. The first time we have done in India. And way forward is the synergetic actions, sustainable development, innovation and technology to reinforce the global commitments for a clear and greener and more inclusive future. So why I put this is, now future we can have a common pipeline where 2-3 parties together can start using a pipeline, because every plant putting one pipeline, that between the pipeline we have to leave 500 mm gap. So it is taking more corridor to reduce and make optimize. We can have a bigger pipe so that 2-3 companies can use the pipeline and we can distribute the slurry whoever required. So batching can be done accordingly. So thank you, sir.
Thank you, sir, very much. And you are also very much time bound, sir. Only thing, sir, I could not understand the Odisha is getting everything cheaper. But why your pipeline to Hazira is going through 6-7 days from here to Hazira? That also you can lay down pipe and hydro ways for transportation, sir. No, sheep goes to this one, then similarly you can pay the pipeline also. Yeah, sir, you can have that pipeline which is Odisha cheaper and everything. Okay.
That also we have tried. When we are putting the Paradip plant, we have surveyed from Vizag and Paradip also to, instead of bringing Dobna material to Paradip, we want to take it to Hazira. The problem is the terrain is not suitable. It is coming a longer distance. So that type of pumps and all not feasible. The cost and all is not economical. Then we have put the plant here. It was worked out. Actually, survey is done. So directly from Dobna to Surat.
Thank you, sir. For gas, we are getting it from Hazira to Orissa. Everything we are getting it for gas, but not for yourself. Anyway, sir, thank you very much.
I have got a question. I have got a question to Mr. Raju. Regarding the reducing the diameter of slurry pipeline in between from in between Vizag and
it is a logistic management key to realizing Vision 2030 for sustainable steel production. Sri Sanjay Kumar Patnaik, sir, I don't need that. I think I have to introduce you, sir. So you are very much well within the SGAT fold, but still let me have the privilege, sir. I think to tell something about you. Sir, Director Project Affairs and Business Development with ISAR Minmet, sir. He is a mining engineer with management program, mining engineering from Osmania University, and followed by the management from CEDP in France. And mostly Tata Steel, he was associated with for 37 years, either the Tata Steel or some associate company. And also all through, I think he is a very helping hand he has given to SGAT. So we are very much thankful to Tata. Managing Director now, Tata Steel Long Product. That was, sir, once upon a time. So now he was also Vice President Utkal Chamber of Commerce and President FRIMI. So that was your introduction briefly, sir. Anything more, sir? Thank you very much, sir. Dr. Sanjay Patnaik, I think you please go ahead with your topic. Thank you, sir. Please go ahead.
Mr. Mahapatra for that very generous introduction.
You know, there is a huge disadvantage when you are the last speaker of the day, because whole day we have some very high quality presentations, and we have been hearing to many reputed speakers and all that, and whatever little bit I wanted to say, all that has already been covered, not once but several times. So therefore, if there is some repetition and all that, please pardon me for that. Well, ladies and gentlemen, I must first of all acknowledge the very presence of eminent industry leaders amongst us. We have Mr. Bimlendra Jha, the Managing Director of JSPL, a very dear colleague of mine from Tata Steel, and we have Mr. Rajiv Kumar, the Vice President of Tata Steel, Mr. Santosh Mahapatra, one of very well-known, I should say, a bureaucrat, a friendly bureaucrat, and then thereafter in his role as a corporate executive, everybody knows him. Okay, Dr. Onkar Mahanti, our president, and the local from the local industry, we have Mr. Prabodh Mahanti, we have Mr. Pankaj Mahanti, to local entrepreneurs. Both managing directors, and Pankaj is this chairman and managing director of his company, doing extremely well. So we are really sort of honored with the presence of all these eminent people and very distinguished members of SGAT. Dr. Mahanti, I must also thank him for the way he and many of Mr. Mahapatra, Mr. Dr. Farooq have been very meticulously working on this seminar and all that. And finally, the day has come, and I think it has fairly well represented and fairly good project topics and all that. So my topic, I would talk about the logistics management. This is the way this one is working. এটা কাম করছে এটা আগুকো না এটা এটা আসলে হওনি তো ওটা এইটা না I think there is some problem. এটা পাচ্ছিল এটা পাচ্ছিল ওকে এটা পাচ্ছিল না না okay right. So I would talk about mostly the two issues about logistics, which Mahapatra sir has very well covered. The point is, we are all talking about India producing 300 million tons of steel by 2030. And today morning, when Vidyut spoke about, when in his presentation, he said, with a 6.5 CAGR, maybe by 2030, we may not reach 300 million tons, we would be reaching about 188, 200 million tons. So if you look at it, each ton of steel, including the finished product and the raw material, requires about 4 tons of transportation and all that. So we are talking about something like 800, even if at a modest and realistic 188 million tons or 200 million tons of steel by 2030, we are talking about 800 million tons of movement of cargo and finished product. Just to give you a sense of number, all of you might be knowing, last year, Indian Railways, with its vast network, Indian Railways carried about 1,500 million tons of freight. So we are talking about 800 million tons of movement. So that itself is a Herculean task. And the way, if the planning, the infrastructure development are not there, then this will really be remain a dream and all that. We will not be able to achieve that kind of steel production. And if we are talking about 300 million tons, then we are talking about 1,200 million tons of freight. For that, you know, we have to have, as Mahapatra Sahib has already listed, we ought to have different multimodal transport, be it waterways, be it railways, waterways, and of course, the pipeline transportation. Because of the poor infrastructure or because of the inadequate infrastructure, we have the steel plants have been suffering. I was in charge of Tata Sponge, which later became Tata Steel Long Product. The Tata Sponge, which is a small plant in Joda. And I have the experience wherein, because of lack of adequate wagon supply from Paradip, which is about 200 kilometers, 250 kilometers, we have to cart coal all the way. Dr. Mahanti was in the board, cart coal all the way from Krishnapatnam port, which is about maybe 1,300 kilometers away. So these kind of infrastructure cost actually is a huge burden on the steel plants. And if it is a small plant where I face so much of a problem, Imagine large plants which Mr. Bimlendra Jha is running, which Mr. Rajiv Kumar is running and all that. What would be the challenges that they would be facing in movement of cargo to these big steel plants? So this particular slide talks about that around currently 71% of our movement is by road, and road is not a very efficient mode of transport and all that. It incurs high costs, pollution, accidents, and long road lead sometimes, it's not advantage for bulk movement. Whereas as Mahapatra Sahib has said, so this leads to about 14% additional cost. Indian logistics cost is about 14%, whereas the world average is about 8 to 10%. Implication of this is that in a steel plant, the maximum spend is for purchase for coal. After coal, it is logistics. That's the second most expensive spend and all. Other point where in this slide I wanted to talk about the low efficiency in our this thing, about the GVR, that is the gross volume weight, the gross volume weight registered is about 80 tons in India, whereas in US and other advanced countries 130 tons and all that. The average train length is about 700 meters, whereas in US or advanced countries 2000 meters and all that. So therefore we are all talking about that because of this inadequate and inefficient, let's not so efficient logistics, the steel plants are forced to keep long inventory, therefore incurring more inventory carrying cost. In this slide, I talk about the, in India, there are 4 clusters of iron ore. And the first 3 clusters, that the Orissa, Jharkhand, Bellary, Orissa, Jharkhand, Durg, Bastar, and Bellary, Chitradurga, Chikmagalur, Bellary Hospital, Chitradurga, Chikmagalur, Tumkur cluster, and the Maharashtra Goa cluster. The first 3 clusters are actually the major supplier of iron ore and all that, and iron ore to our steel plants. And these clusters, while the steel plants in the eastern region are closer to the mines comparative to the southern plants and all, but the finished product, the distance, traveling distance for shipping out the finished product for the eastern plant increases. Maybe the raw material is closer, but the finished product increases and all that. So therefore, again, there is a expense here. But thankfully, Government of India has taken some steps. Gati Shakti initiative is a very good step, and I suspect that the way it is moving and all that, it could realize the benefits to our plant. And here we are talking about number of departments under Gati Shakti has been integrated and all that. So therefore, there is a seamless kind of planning and all, which Government of India has started. So holistic planning of infrastructure projects, the initiatives for rail infrastructure under the Bharatmala project and also the Sagarmala project. These are very futuristic initiatives that government has taken, which ultimately will lead to once this fructifies, will ultimately lead to reduction in the logistics cost and all that. Several, I will not go into the details. Several, road network has been planned, rail network has been planned, and even the last mile connectivity of railway network to the port terminals, that has been planned. In this particular picture, the map that you are saying for better connectivity across the state.
No, not that one. The another pointer.
Is that this the one?
The pointer which is.
No, sir, pointer is here. No?
Here we are not able to see. It's too big. Another one is there, red one.
इसमें रेड वन कहाँ है? Oh.
You see.
So you have to have both. Acha. Okay, right. So this one is the pink color. This is what is the area of influence. So ultimately, when all these materializes, I think we are talking about the whole of India having fairly good multimodal transport and fairly good logistics issues. The logistics issues addressed. These are the ports and all that. The railway corridor, the eastern corridor, the western corridor, and there are many more. This is the Delhi Mathura industrial corridor, the other industrial corridor. So all this is being shown. So this is what has been planned and it's going on, but we need to expedite. A good beginning has been made, but I think and huge plan outlay, the expenditure investment have been sort of announced. If these materializes and all that, then India is going to be more competitive in its movement of cargo and finished goods. This is the same one we are talking about, Gati Shakti, and Gati Shakti, several integrated fracture, and then this integrated digital platform that I am talking about. Right now, we would not be knowing if you ship your material in railways, you would not be knowing the exact location of the cargo. You would not be knowing where, when it will reach and all that. But with this integrated digital system, not only the forecast, not only the real-time movement of cargo, one would come to know, it would also increase the various clearances and all that, which various clearances and certificates which now takes time can also be issued quickly and all that. So Gati Shakti again is integrated end-to-end logistics, and we are quite hopeful that if this happens, then the costs will come down, and which will make Indian industries quite competitive. The other challenge is, while we are all talking about the movement of cargo, we are talking about improvement in logistics, but the challenge, since we are talking about sustainability, and we have been hearing about sustainability encompassing decarbonization, circularity, energy transition, carbon capture, all that we have been talking about. So when we talk about the movement, when we are planning all this, then all these logistics will also focus on the emissions. How do we do it on this? How do we address the sustainability aspect of it? In this one, we are wanting, I'm wanting to point out that right now, scope 1 and scope 2 emissions are being captured. Scope 3, I think the industry is not capturing and all that. Going forward, the industry needs to capture scope 3. And while reduction in scope 1 and scope 2 is planned, but scope 3 the industry needs to capture. Here I wanted to show the what Saudi Aramco. This is just a depiction of what they are doing and all. This also we are talking about scope 1, scope 2 we are doing, but scope 3 needs to be also integrated, and the industry needs to be more responsive and capturing scope 3. And accordingly plan the movement, the logistics management. So primarily these are the things, these are the various companies that this thing, and World Economic Forum has also said it's time for companies to take on scope 3 emissions to tackle the full climate impact of their products. Futuristic age logistics. Tube trailers, pipeline, liquid tankers, all these are futuristic things. So first we need to kind of reach that stage and then move ahead and all that. So these are also thought processes which we need to address right now. We heard about slurry pipeline, so I don't want to Mr. Raju had already spoken about slurry pipeline. It's definitely one of the very cost effective and environment friendly and very smooth transportation. But then the challenge is that everyone wants to build, which Mr. Raju has also spoken some. If it can be a large network of slurry pipeline which can be shared by several players, then that would also be a good thing. So that is all which I wanted to talk about. Primarily, we are talking about that our logistics planning to meet the aspirational goal of 300 million tons or even a more realistic of 200 million tons, the logistic planning needs to be done. Indian steel industry is in a sweet spot in the global Indian steel industry probably in the global scenario, it's in a sweet spot, having registered some more than 7% growth, while the world is growing at maybe 2%, 2.5% and all. So therefore, as we are growing, as we aspire to become a developed nation, we need to address the logistics planning, otherwise this remains a dream. And since we are talking about sustainability, which is our future and all that, so while we are doing the logistic planning, sustainability needs to be interwoven into our planning process. Thank you very much. Thanks for your.
Thank you, sir. I think you have completed also very much time, sir. All, sir, three of us, we have completed well within the time. And see.
Logistics.
Yeah, all logistics should be like that only, sir. Sir, only thing I could not get it is that why West Coast is having so many ports, but East Coast is not having very limited ports. I think the figure which you have shown it, West Coast means so many arrows are there. Everywhere there is, sir, there is a port. Sir, Odisha, sir, only 2 ports or 3 ports are there.
Sir will answer. Port expert. Sir, written in.
I think Gujarat alone has perhaps
this is in your port.
Oh.
I cannot record.
and East Coast has less ports.
Thank you very much. Thanks.
That is because the building port is mainly three things. Yes. Mainly two things. Now, in eastern coast, both are expensive. But tranquility, you have to build a breakwater. By today's depth, you have to build a channel. Channels, if your ship needs 18 meters, you have to build a channel which takes you to where the sea is naturally 18 meters deep. Now that can be only 10 kilometers in Gopalpur, that can be 20 kilometers in Dhamra, that can be 100 kilometers for Haldia, right? In West Coast, especially the Northwest Coast, the tidal difference itself is 7 meters. Meaning every day you have 2 windows when the ship becomes 7 meters deeper. So, and ships don't come every hour. Ships come, the ships can very easily come twice a day. So in Gujarat coast, if you have a 5 meter deep sea somewhere, you can add 7 and say that I can bring a 60,000 tonner during high tide. And it can leave during low tide. Or if it's empty, it can come even during low tide, right? Now, as you know, the tranquility can be natural or artificial. In West Coast, you have 2 what you call, straits, the Gulf Straits and the Khambat Straits. Straits is where the 2 land lines join, making the water in between completely tranquil without any artificial help. So you have hundreds of kilometers alongside the Kutch Strait and hundreds of kilometers alongside the Khambat Strait where you don't need to build a breakwater, and you can that is why in Gujarat I used to get application as industry secretary. Some plant, sir, I may be permitted to build a jetty for my ship to come. They don't build a port, they build a jetty straight away. And a port comes maybe only twice a month and unloads the raw material and goes away. So you can build a port to start with a few 100 crores. Here to build a port, you need thousands of crores. And I remember the kind of problem Mr. Jha gave me to release that money when I was building the port. Because it's either you spend a whole lot of money and have a business plan of handling 20, 30 million tons to start with to make the whole thing viable. There you can build a port with only 5 million ton of cargo in horizon and make a profit out of it and organically grow into a big port like Mundra has grown. Mundra started with 5 million ton. I have seen it only with 2 berths. You can't have that kind of port here. You have to spend thousands of crores.
Yeah, very good, sir. Sir, anyone is having any question or something like that? Otherwise, we are going for the next validatory function for that.
Slurry pipeline, the material, whatever you have, from our experience in Haldia, Morigram. In the Haldia Morigram system, for example, in the case of crude oil, the corrosion becomes a problem. So the maintenance of the pipe itself is a problem. And the second one is load, no load. So there is a fluctuating load also. So there is a fatigue and the corrosion fatigue. Do you really face all these problems, or I only teach those? You never face those?
Sir, in slurry application, especially slurry, we make pH around 10. We have to maintain with a hydrated lime. So when we pump slurry, pH 10 is maintained, so there will be no corrosion. And corrosion
Takes place there.
here, polyethylene 3 coats will be there on the pipeline, and we give induced cathodic protection like 0.2 volt will be there always throughout the pipeline. So any rupture in the top coating, there will be no cathode anode, current will not pass through that. So there will be no rusting on the outside. Yes. No, not drums, sir. We have every 30 kilometers we have put one cathodic station, which induces current all along the pipeline. So if you see in the first pipeline, we have 9 cathodic stations. So that will take care of the outside there, sir.
And you should announce in the villages that don't touch it because
No, it is only point. It is only ground voltage, sir. 0.2 volt. Sir, and one more thing, this pipeline is designed for 25 years. Each year, 0.1 is erosion with the slurry. So we have 2.5 mm. This is normally API 5L, sir. Indian pipe, our own pipeline. It is made in Surat and we laid the lines.
But how can you share the same pipeline without avoiding mixing up?
Sir, what we do in the now existing pipe also, we pump low grade, we pump high grade also in that. Now we are making DR grade pellet, we are making BF pellet in Paradeep. So what we do is, it doesn't mix in the pipeline because it is continuous operation. As I said, I'm parking now. Suppose if I'm parking, then I'm putting 1 or 2 hours of water in between. So that will not get mixed, sir.
Nothing remains in the pipeline.
It will remain in the pipeline. Our pipeline full load is 6.
How do you clean it before sending another?
No, not required, sir. It will. That is why I said by weight. If you see, it is 66% is I don't know. By volume, it is only 33%. So volume will have only 33 occupied in the pipeline always. Still 67 volume is there for water pushing to clear the material which is at 33%. So that is the advantage. Whenever we stop after 8 hours when we start, within half an hour it will become steady state. If I pump at 1500 meter cube, Paradeep will be receiving at 1500 only within half an hour.
By itself, how you start sharing the pipeline, like you start sharing the information line.
Thank you, sir. Sir, we have completed our technical sessions. So all the 3 speakers, they have spoken very well. So I think they deserve a clapping from our audience. Sir, now it is handed over to our convener, Dr. B.M. Farooq, for the next session. That is the concluding one, I believe.
Thank you, Mr. Gurjama Patra, for handling this session very efficiently. Thank you, Mr. Anup Kumar Raut. Mr. Anup Kumar Raut is retired Director of Geology, Government of Orissa. I forgot to mention that in the beginning. Thank you, both of you. Thank both of you. Now we are into the valedictory session. Give us just 2 minutes. We have to get the, chairs onto the dais. Yeah. Mahanti, please come to the. Mr. Bimlendra Jha, MD, Jindal Steel and Power Limited. May I kindly take the chair? We have another guest of honor, Mr. Rajiv Kumar, Vice President, Tata Steel, Kalinganagar. Dr. Dr. Owen Mahanti to kindly initiate the discussion or valedictory session.
Good evening, friends. Mr. Bimlendra Jha, the Managing Director of Jindal Steel and Power Limited, and Mr. Rajiv Kumar, the Vice President Operations of Tata Steel Kalinganagar plant. And friends, I can see only hardly 10% of what we started with, and that's actually somewhat depressing. But at the same time, I must tell you how pleased we are to have both Mr. Bimlendra Jha and Mr. Rajiv Kumar in our midst. This is essentially to tell both our guests that this is only an introduction to this organization, which is the SGAT, Society of Geoscientists and Allied Technologists. And in the morning, as was told by Dr. Farooq about the SGAT, I had sent to both of you also the flyer and whatever is happening here. The most important thing that is happening is in the state of Odisha. SGAT is the organization of the geologists, geoscientists, mining engineers, mineral processing engineers, metallurgists. What we try to do is create an awareness also amongst the college students and school students. This is happening for the past 35 years, not just 1 or 2 years. And there are very large number of schools and colleges of Odisha, of Jharkhand, of Chhattisgarh. Where else? I think those are the ones who participate. Yes, BHU participates, IIT Kharagpur, ISM Dhanbad. So a number of institutions also participate. So SGAT has been doing that kind of thing. In addition to that, you will also find that every 4 years we publish a fairly comprehensive book, which is called the Geology and Mineral Resources of Odisha. And the Geology and Mineral Resources of Odisha, this time it covers 31 chapters, and particularly all minerals and geological resources. It's a price publication of 1,800 rupees. So today we have been selling it at a discounted price. So one is book part. Then every 3 months we publish one bulletin, which is called the SGAT Bulletin, which will be there every 6 months. And it will be there in the kit which you are giving to both our guests. Hopefully the bag has been given to him. You'll find the SGAT Bulletin. So these are the kinds of things which SGAT does. We have a museum also at the ground floor. And what we incidentally intend to do in this session is, we have gone through 3 sessions. The first session was the raw material session. And in the raw material session, Dr. Banerjee has left. I don't know whether he's here. He's there, Dr. P.K. Banerjee. Oh, you are there. Yeah, Dr. P.K. Banerjee was with us in Tata Steel in the R&D. Is there, and he drove all the night while coming to Bhubaneswar because he missed his flight from Dhanbad. He was coming. And in addition to that, we also had, along with him, Dr. Who are the other people? You have the... Yes, Dr. S.K. Biswal is there. Dr. Biswal is the Bhishma of what you call pelletizing and the mineral beneficiation, slurry transportation. Now, this I am trying to tell because in the morning, whatever we had, as far as the raw material is concerned, in spite of the fact that we are number 2 as far as steel production is concerned. When it comes to pellets, and as was shown by our ArcelorMittal people, that yours, I think your pellet plus sinter, it's only 2-component system, which is very rare in this country, but that is what we have to do eventually. But interestingly, while we require so much of pellet, India is number 4 or number 5 in pellet production. In pelletizing, we are only about number 4 or number 5, which means we have to go a long distance. Most of the blast furnaces in India, we didn't now learn to use more than the size door plus sinter. And the pellets come much later. 15 years back, the pellets came. And now, therefore, that's one point which we learned, that the pellets will have to be very high, the proportion of pellet. So we have to go up. And then we had, apart from the raw material, then we had the steel making. In the steel making session, we had Dr. Rijwan speaking to us from, I think you were a part, no, you didn't listen to him. He was from World Steel Association, the head of the steel part. And I myself dealt with the high strength steels in the automotive and why it contributes to the sustainability. So these are the things which we did in the steel session, and in the session relating to logistics, you have listened to most of the papers. So with that, I think more or less we completed the whole gamut of activities, because in a matter of just one day, it is impossible to deal with and dwell on all aspects of the green steel making to green hydrogen making to sustainability, and make money out of the whole thing. As Devashish was there in the inaugural session, we had Dr. Devashish Bhattacharya and also the ED of projects of ArcelorMittal and Nippon Steel, Mr. Rajiv Kumar Bhatnagar. And and Devashish gave a very comprehensive view of the world problems with challenges. And Mr. Rajiv Kumar dealt with, again, their international operation as far as ArcelorMittal and Nippon Steel is concerned. And in Odisha, as we know, they are expanding now. They're expanding. And the last one, the logistic one, I found exceptionally good, because I myself, I learned a lot from you all, from Mr. Mahapatra ji also, about the ports, about the logistic. And so Mr. Sanjay Patnaik's presentation also is very, very revealing, because we all always hear about how these railway lines and so on, but the corridors only for dealing with raw materials, the railway corridor I'm referring to, has not become a reality yet. So etc. etc. So all in all, I think for an organization, professional organization like SGAT, it has been a sheer pleasure, absolute pleasure, having people from the industry, having people from CSR Research Lab. We also had the director of the CSR Institute for Minerals and Materials Technology, Dr. Narayan Ramanujan. He was also through the proceedings. And I'm particularly grateful also to Mr. Rajiv Kumar, who sat through the morning till the afternoon session. Thank you very much. Probably we made you captive because you are 58 kilometers away. You couldn't have gone and come back. No, but that's apart. Your presence itself lent a great amount of solemnity to the whole occasion. So with that, I now would request both our guests, starting with Mr. Bimalendra Jha, to share some of the opinions or your views or insights on the topic per se. You have anything to present?
No, I don't have any.
No, you can speak from here. Yes.
Yeah, but I can see people better.
Yes, they can see you.
Yeah. Does this work? Yeah, okay. Good evening and thank you for inviting me here. Dr. Mohanty has been like a guru over there in Tata Steel to us. And Rajiv is, of course, my batchmate. From GT90 batch, we still remain connected on the WhatsApp group. And Sanjay also met me last time, and Mr. Mahapatra, we were on the same board that built the Dhamra project. He was the one who was building, and we were the ones who were telling him that what mistakes he's making. So there is that's how the relationship went on. But it was a fantastic session that what I heard just now with, over there. And of course, ArcelorMittal has taken a lead in making these slurry pipelines successful. We are at JSP only putting up a 200-kilometer pipeline, and we know what a nightmare it is. It is unfortunately, despite being the most sustainable way of transporting material, the cheapest way of transporting material, not troubling the tribals, not troubling people, and yet it is the one that is most difficult, resisted by the people who are unfortunately negatively affected by the mining activities in the country. So there is a lot more education, lot more understanding that is needed to be developed. But since the topic is that of sustainable steel making, I actually, after more than 3 decades in the steel industry, I have never been as hopeful as I am now. Because I didn't believe even 3 years ago that we are so close to that breakthrough, which has been for millions of years, not or thousands of years. Let's not talk millions, millennia. So thousands of years, ever since steel making started in practically in this country. Damascus sword itself was made from the steel made in India. It is after thousands of years that carbon as a reductant is changing to potentially hydrogen as a reductant at scale. And that hydrogen can potentially be produced completely without spending any carbon. That means it is nothing short of a revolution. It is after thousands of years that this has become possible. It's a different matter that hydrogen-based reduction has actually been happening. After all, those who use gas-based DRI, there is hydrogen in it. And if you really look at it at a larger scale, then JSP, for example, for the last 10 years, using coal gasification, it uses a substantial portion of that syngas that has got hydrogen in it. It has got approximately 52% hydrogen. And then because of additional availability of methane, another 10-12% gets added. So almost 60-65% of reduction reaction is actually happening using hydrogen. So I don't know why I myself was so skeptical in the past. But what happened in Norway actually changed my mind. What happened in Norway with H2 green steel was that right from the beginning to the end of the cycle, they produced an automotive grade steel and they supplied it to Volvo.
In Sweden?
Yes. And this was, this I didn't think was possible for another decade. And that shocked me out of my slumber on the potential of the technology that exists. Of course, Sweden, despite being an oil-rich country, took the lead to start using the water resources, the hydropower as a source of energy, which is obviously green. And then using electric arc furnaces, they further melted scrap. But that's not the solution, because if the whole world was to produce steel from scrap, there is just not enough scrap available in the world. And therefore, we don't have a choice but to use hydrogen as a reductant for the raw material that is removing oxygen from the ore. Now, this part fortunately puts steel industry very, very differently compared to any other alternative choice of material. So the number one resource that the world consumes is, of course, water. But the artificially produced material that is not naturally occurring, that is used by the world, is cement. That's the largest. And then comes steel. Now, interestingly, it is, we are called as hard to abate industry. But how the world is changing before us, let's look at that. Let's look at the fact that cement actually has no hope. Because CaCO3, you have to split to make it CaO, and CO2 by definition gets released. You can't avoid that reaction. And imagine a future if there was no blast furnace, then there is no slag to mix. If the power plants are no longer using coal, there is no fly ash to mix. So the carbon footprint of cement in future will only go up. It can't come down unless there is another alternative that is found to fly ash and slag. Imagine that future. So what is the only material of choice that can fully substitute cement? It is not aluminium, because the carbon footprint of aluminium is going to be always higher. It is only steel. And that is why steel has such a future. And fortunately, India, 75% of the country is yet to be built. That means we are at the cusp of that revolution where the new future of India is completely based on a sustainable green steel. It is possible, technically possible, because 75% of our country is yet to be built. Now, this particular aspect makes me even more hopeful that most of the technological development for the whole world will actually be led by India in hydrogen-based DRI. Now, whether or not we are able to produce hydrogen in a sustainable manner at a cheap enough rate so that this reaction can be aided by the economics of making steel available without having to pinch the pockets of the people, that is something which is a challenge. But let's look at the other alternatives. Our problem has been that the society does not know how to deal with this carbon emissions. Even it doesn't even have a right capability to define what is green steel. If you look for definition, there are definitions of near zero steel. There is green steel. Somebody calls it if you produce only 500 kg per ton of steel, you emit only 500 kg of CO2, then it is called a green steel. So there are many of such kind of definitions which are coming. And yet the world doesn't yet have one common definition for what is going to be green steel. When you have such a confusion, even greater confusion is that what you should be measuring. So you would have heard of biomass can be used as a source of hydrogen. Now, when you use biomass as a source of hydrogen, there is no technical difference between coal as a source of hydrogen versus biomass as a source of hydrogen. In fact, coal will give you more hydrogen than biomass will give. And yet, biomass is being treated as a source of green energy, green hydrogen. It's completely ridiculous. Why? Because the mathematics is that during the lifetime of that biomass, when it was a live plant, it has generated enough oxygen, so we will net it off. Then why did we criticize the poor fellow in the villages for using all this gobar, kanda and all that stuff? That was biomass as a source of fuel. We have been criticizing all along that these guys are polluting the environment. Let's not do that. Why? In that case, mathematics does not work. Only if the industry uses it and produces carbon dioxide, I will count the oxygen generated by that plant before it was dead. This is ridiculous. Unfortunately, people don't think straight on these matters because there are a lot of vested interests. However, if you start looking at coal as a source of hydrogen, let me tell you, Odisha itself has a huge potential. Last time mining was, some mine blocks have been given by Odisha. No, there was no bidder. You know what are these mines? These are deep-seated coal mines. Anything which is 800 meters, 1 kilometer deeper coal seam for a thermal coal, nobody finds it economic enough, right? So this is unmonetizable asset. But if you look at the potential for underground coal gasification, what happens, there is hardly any structure on the surface. There are no trees to be felled. Actually, for underground coal gasification, you need more than 800 meters of overburden because you need that pressure. And then when you generate that coal gas in the ground, what comes out is the syngas together with carbon dioxide, which, by the way, you can have the rectisols and push it back into the same ground, which means without disturbing the environment, without disturbing any flora and fauna of that place, without having to relocate people from the places that their ancestors have been living in, you can actually have a far greater sustainable source of hydrogen. Just because the source is coal, unfortunately, this will still not be called a green hydrogen. It will be called, at best, a blue hydrogen. And this is what I call as nonsense, because it doesn't serve the purpose of many, many countries, but it does serve the purpose of India. And you know what the whole world is afraid of? Imagine a future. Imagine that India, today I was hearing some of these lectures where how much coal needs to be imported into India. Why? Because we are still thinking that we need blast furnaces for our future. Therefore, India already imports 90% of its coking coal requirement from outside. Hence, we must get so much of coking coal if we are going to produce 300 million tons of steel. Then there is even more coking coal to be imported. Now imagine a future when coal gasification is the route. Imagine a future where hydrogen, because of the renewable energy, the power that you can generate with a combination of solar, wind, and pump storage is created. 24/7, round the clock, you can have green power. You do not need any longer, not only that coal, which is imported, but India's largest import is actually in oil. And if source of energy is green, locally available in India, together with the thermal coal, with coal gasification, potentially other sources of carbon sequestration, usage, etc., this country does not any longer need the oil, which means what is the consequence on balance of payment for this country? The consequence on balance of payment is that this country actually does not need external currency, which means that the rupee will get upvalued. Of course, it will have a negative consequence on our export. But the most positive consequence will be that the money that we are sending out for capital, the equipment that we buy from outside, that will also become cheaper. So it's not just if any appreciating currency was always bad, then why do the central banks get worried in United States when the dollar starts falling? That's not the only reason. In fact, we have enough demographic dividend, and if this country does become developed, there is enough domestic consumption. We don't even have to worry about that. Others have to worry about that because they don't even have the population to consume. Beyond a point, how many cars you will keep in your house? So there is actually a future when the Prime Minister says that it is Amrit Kal, it is truly the time of India. It is truly the time when this country can shift gears from being treated as a third world country, not having hope, too many people, not having solution, not having enough resources, to a time when this country actually leads the way through green energy as a source of energy, through coal gasification as a source of hydrogen, producing the highest amount of steel that gets consumed with the downstream industry in India, that starts exporting to the world. Anyway, they are thinking of China plus policy, or what they are now calling as friend shoring, and India can be a friend to any democratic country in the world. There is a future, which is indeed an Amrit Kal. It is the unleashing of that future that was required. I think that unleashing process began in 1992 with the liberalization of the country. But in last 10 years, there were many, many enablers that were put in place, whether it was the GST, whether it was the UPI-based payments, financial inclusion of the masses, the simplification in the financial system, the bankruptcy code coming in where 52 different laws were annulled to just get one law in position. I think there has been a lot that has been done in India, and a lot more can be done in the times to come. We are living in an Amrit Kal where we can contribute with our knowledge, with our understanding, with all the things, by getting rid of our past notions of what cannot be done. This is the time of new possibilities. And thank you for inviting me over here, because this is the kind of sustainable steel making that I would like to see with the help of every scientist and engineer in this country. Thank you very much.
The reason I asked Mr. Bimalendra Jha to be there is that while listening to him, I was very, very much influenced by what you said, the insightful manner. Suddenly I recalled that sometime back, maybe about 2 or 3 years back, I was told you were the head of Tata Steel UK. And then in the British Parliament, Mr. Bimalendra Jha went and made some comments also. So it sounded very much like that. So I enjoyed that. But having said that, today is also the day when G20 is meeting in Delhi. And in addition to that, of course, there are 4 countries who are kind of claiming their connections with the British Prime Minister. So we are also one of them. Somebody through his wife, somebody through his parent, the father-in-law or whatever. So my question to you is that you were there, I know, on between 19th to 20th of April this year, only a few months back, in the FICCI Government of India conference on similar topic, very similar topic. And your name featured there, had seen that. What did you learn from there in order that the ideas that you threw today, actually the ideas are very, very important, very valuable, but we knew some of them. For example, the whole of Dhanbad area, underneath it's burning and burning, and there is a land subsistence that is taking place, and yet we are not able to retrieve power from there. Also. And then your own plant in Ongold, where the liquid to gas to liquid.
Coal gasification.
Yes,
no, it's
coal
not
gasification.
Coal to liquid, it is coal gasification.
Yes, coal gas. Now it is gasification, but initially the project was actually, essentially, it was the coal to liquid.
Sasol was involved, that is why people may have thought that, but
Yes.
right from the beginning it was conceptualized
Only
as
gas,
a coal
okay.
gasification.
So the coal gasification, which was institutionally being done over here, but nature was doing a similar kind of thing underneath, but we are not able to take power. So my question to you is, A, what did you voice, or what did you hear from with Government of India and the FICCI, that huge long conference that took place for 3 days, vis-a-vis we have a small conference over here. So what new things were done there? And some of the ideas that you just now prepared, how can you take it forward? You are an MD of a big company yourself. Can you invest money in Dhanbad area or some of the coal fields of Odisha?
First of all, I have already approached the government of Odisha for an experimental trial plant, because there is one plant in the world for last 50 years doing underground coal gasification. Now, there are challenges. It's not that that it is a proven technology, because if for last 50 years it has been there and it is a running plant, why is it that it can't be done more? So there are challenges, and those challenges have to be dealt with. Now, you mentioned Dhanbad area where there is spontaneous combustion taking place underground, and spontaneous combustion sometimes is taking place above the ground after mining the coal. In fact, I was at Southeastern Coalfield Limited only recently, and then I realized that they have mined coal which is burning now. And why is it burning? Because in my first year engineering, I studied spontaneous combustion, and there was a certain height that was told that if you go above this height, then spontaneous combustion will occur, particularly if the volatile matter is high, right? If you go to these coal fields, we are simply not following my first year of engineering lesson. And this is what I also learned when I landed up back from UK at Ambuja Cement. I went to the Muldwarka port, and I was told that when I asked about Indonesian coal, they said, no, this catches fire. And I asked them that what is the height that you keep it at? And they said 8 meters. I said, what do you expect? This will have spontaneous combustion. This was my very, very first visit. And I had not thought about the subject until then. since my first year of engineering. So it was, but somehow it came back to me that it is that simple, where when you spray water, it acts like fuel. Now, these basic things, when our scientists and engineers or our colleges, etc., are not able to emphasize, talk about them in the colleges, and thereafter we are not going there as engineers to solve these problems, the consequences are what we get. So in Dhanbad, if the coal is already burning, there is nothing new that I have to do. I have to just make sure that I put enough water inside, which comes back to me as hydrogen. Now that's what is required. Now, how do we do it? I don't know. I can't, but I know the kinetic reactions.
The science is known, the engineering.
So I think Oppenheimer movie is very famous right now, and many of you would have watched it. You see that there is a stage where Oppenheimer has a strength which is complemented by his friends who have complementary strengths. Oppenheimer is a thinker. He is a theorist, but you had a practical lab necessary sitting right next to him. And the guy tells him in that movie that I want it next to you because your ideas have to be eventually implemented. I think what we can do through this society is to put the thinkers and the practitioners together to bring this possibility to light that yes, the burning coal can be converted into a useful natural syngas.
The second part.
The second part is what did I learn from the Delhi conference? Delhi conference is a political conference. Okay. And as a scientist, how much politics do I want to learn? Maybe some of it may be useful at some stage if I was want. No, but I'll tell you, agenda is good.
Yes.
Agenda is good, and I'm happy that India is taking a leading way forward, particularly in making the world a better place to live. The concept of Vasudhaiva Kutumbakam, I think it is bang on target. It is time to collaborate. It is not time to compete. It is time to do things together and make the world a better place to live. And to that extent, India has the rightful place in the world, particularly as demonstrated during the COVID times, despite all the criticism, giving those vaccines to Africa, when the only intention of opposing forces was to make more money. I think it was a brilliant move. And that is why we have the moral right to lead to a win-win.
Thank you. Thank you.
Thank you.
We will request now Mr. Rajiv Kumar. Thank you.
I don't need the presentation. Thank you. Thank you. I don't need the presentation. I don't need the presentation.
So it's been a long day. Good evening. And being the last speaker is, I'm standing between you and the gate. After Bimal and that impressive speech. Good evening, everyone. Good evening, Dr. Mohanty and Bimal on the dais, and Dr. Farooqi and all the dignitaries of the dais. You heard Dr. DB. Much of it is what is Tata Steel stands on sustainable steel making. You know, in India, Tata Steel Jamshedpur is the best on CO2 at 2.1, 2.15. Endeavor is if you had heard Dr. Junaj from Jijuan, Dr. Jijuan, much of it is what we are also trying to do in the company. How do we improve the efficiency at whatever we have got today? And as you are aware, our announcements are all towards the blast furnace, much to the contrary of what Bimal is saying. We are going the traditional route. But what are the 2-3 things which is very important for us to take note of? One, if you have to make quality steel today, what you heard Dr. Owen Mohanty talk about, that entire presentation will not happen any other route today. That's the limitation of mankind. And if you have to serve auto industry in whatever
thing that he talked about in that presentation, it is still the blast furnace route. So you have to have that limitations as we go forward, at least for the next 10 years. That's what we are discussing within Tata Steel, that you need to put the blast furnace. Because the kind of steel which we are looking for today and what you heard Dr. Mohanty, it will only come from blast furnace. That's one guidance. The second guidance is, how do we make it superior from 2.1 or 2.2, right? And we have had discussions within. We have a plant in Bhushan, which is at about 2.8 tons of CO2 per ton of crude steel. So where Tata Steel Jamshedpur is at 2.2, 2.15, the other plant is at 2.8. I'm in between at 2.3, 2.35. So how do we come below 2? That's the first target. So going forward, it will take a lot of time, 5, 6, 7, 8, 10 years. I don't know, but it will take a lot of time. So what you heard the Belgium scientists talk about, the WSA scientists, the first thing is optimization, and right across Tata Steel, we are trying to improve the optimization bit of all the steel plants. And the plant that he was talking about, the LPL, it goes beyond 3, right? I didn't say, we have studied coal gasification, not trying to say anything against Bimal, but where do you take that DRI to the next step? Then it increases the CO2, right? So it is not fully, if the route is the same as of steel making, you need to change the route of steel making. Current steel making, it is working as an input. That's where it is going beyond 3. If you are to use coal gasification today as a value chain. It's important for India because what he said, thermal coal, but for overall value chain, it has some limitations. So what we are trying to do on the optimization piece is, I started to think about it, and what is the biggest learning of Kalinganagar when we came here as a greenfield. And to Dr. Owen Mohanty, I would have flipped the presentation on logistics, power, water. We didn't talk about water much here today. Steel plant is a guzzler of water. And to make it sustainable, you need to have, Odisha has water. The water table is very high. As all of us today here, the most important thing is to maintain that water table, not to destroy it. And you see Brahmani River, all our 3 plants, NINL, Kalinganagar, and Angul. All the 3 plants are on one river. It's a big challenge. So how do we be more sustainable on water? How do we reduce the water consumption? Can we go dry on many of the things which are wet today? Is a line of action, a very focused line of action with Dr. Devashish that he didn't talk about it, but water is something which is very important. Logistics. So I would have flipped this whole day today to start with him rather than start with raw material. That's the original thinking. How do we, the biggest learning of Kalinganagar was, you make the house, you don't know where the road is, where the water is, where the electricity is. So exactly what we are discussing today, and much of the presentation on logistics, the transportation bit was talked about. What about water? What about zero liquid discharge? What about zero emissions? None of the steel plants today have this, or very few have. And it requires a lot of effort to understand what is optimization that the WSA gentleman talked about. It's a subject by itself. It will require next 10 years of diligent work. So what is our step towards that? Draw out big units. So we are going for the largest blast furnace of the world, one of the largest. So that way you consume less. Flaring, if you were to look at today, nobody understands how much energy are we losing, because none of us know. Flaring is a word which you should go back and ask to your people immediately in any steel plant or any manufacturing. How much do you flare? And you would be astonished. It can run into a few hundred crores. So do you optimize on that? So big units, a zero thought process on emissions, discharge is itself 2-3 subjects that you can work on apart from talking about how do we reduce the CO2 intensity from 2.3, 2.5 to less than 2. So these are my 3-4 things on the pegging order. If we have to do that, for Tata Steel, we are still going through, as I said, the blast furnace route. The other thing I would want to leave, you have all seen that 35 million tons, 35 gigatons, what we emit today. Mankind needs 5 things. It's made of 5 things. Much of it was discussed. Transportation being one of the higher ones on that 36 million tons, 36 gigatons of, but transportation, if you see Tesla, if you see autonomous vehicles, electric vehicles. So what is the next way to do steel making? Why am I referring it to that is, do you have a view on electrical steel? How do you make electrical steel today? India doesn't have electrical steel. So the focus today going forward is work on electrical steel, because that's the future. Because if you go to Australia, if you go many places, autonomous driving, I was few days back in Australia. I saw with my own eyes. I was standing just next to a 500-tonner dumper. It was a giant equipment driven on its own. So if there is an autonomous vehicle already, do you need a B pillar, which Dr. Owen Mahanti talked about? Then can we go to electric arc furnace? Then do we need the blast furnace? Some of the things which Bimal was talking about. So can we do away with whatever Dr. Mahanti did in 1999, 2000, which he presented today? Can it be a thing of the past? Because of what Bimal alluded to. We are at the cusp, because we have been at the equilibrium for pretty long. Dr. Mahanti said in his initial speech, the myth, Bessemer, and then steel making is more or less done. He said that. But today, probably we didn't talk about digital today. Digital can be leveraged to attain sustainable steel making. Can autonomous, can robots be an answer in many ways to the steel makers? So it's all jumbling up today, what he said. And then there would be that S-curve we talked about. In 1900, if you see, you remember that New York street, it was all horse carriages, one Ford vehicle. And then in 13 years, one horse carriage, and the rest, you know, history. So the power of disruption, right? Today we are saying, why do we need to kill animals to get your protein? Somebody talked about it. Protein can be made by yeast in a chemical. Today, the world, whosoever is a chemical engineer, I feel, will be finding the answers to most of the problems of mankind. So food was the second one. Transportation, food. Where do you spend that 50 gigaton or 35 gigaton? Material, the hard to abate. Information. And I think information is going by bits, leaps and bounds. You are not talking of 5G. You have data at what you have today was one of the biggest computers once in 1970s. So I think technology, information is helping us in many ways. The digital journey that we all are taking, and he talked about the India stack and many other things, to see to it that it can come and help us in what we say is sustainable steel making. I am very thankful to all of you for listening. It was personally a great day for me. To Dr. Owen Mahanti, thank you for selecting all the 3 topics for the day today. Wonderful. Your coverage was very good. And I wish we can make, I didn't talk about the hydrogen part, because we at Tata Steel in Kalinganagar, as Dr. Devashish said, we are foraying into some projects. Chemical looping process is something which we are with the Ohio University working on it. We have started making 1 kg a day in Jamshedpur. That's the pilot. The next is 100 kgs as I speak in next 3 months, and some few tons in Kalinganagar after that. That's the journey we are taking, a very unique way of making hydrogen without any of the things that has been discussed in the day today, right? It's a Professor Lang who is in Ohio University, and we are having a patent with him. We're just trying it out. And if that is an answer, then you don't touch electrolysis. It's not electrolysis. It's just by its own way, a very green way, and anybody can make it, but it's still in infancy. And the many things on the CCU, just to tell you, I run a 8 million ton steel plant. On the energy, 8 million steel plant conventional way. And if I were to replace 1 million ton of that steel capacity with hydrogen, it will take similar amount of energy. So I need today 600 megawatt to run an 8 million ton plant. And just to make 80,000 tons of hydrogen, we need that kind of energy. So the cost of steel making today, it's not $40 CBAM, what is being discussed. It's in order of magnitude. So it has to come down. और एक चीज ध्यान रखिए, अगर $1 ₹50 किलो से कुछ भी चीज महंगा होता है, we all get excited. So hydrogen has to come to 50 rupees a kilo. Till then, it's a dream. Thank you very much. Thank you for doing this.
One question of you. Yeah. we have one question of you. You know, we just now read a few days back that Dofasco, ArcelorMittal Nippon Steel Dofasco, have taken a decision to go away from blast furnace BOF into DRI, a conscious decision. For all the discussion that we made throughout the day, what has been your discussion when you expanded in the blast furnace BOF days?
So the way it is, I had a very, and I think Dr. Devashish talked about it. I had a presentation, but I didn't show it because it was already getting late. So we need to transition from coal to natural gas, as he said, to hydrogen. That's the journey. And probably DRI would be an answer. But obviously the limitations that WSA gentleman said is a limitation because it will require a higher quality of raw material than a blast furnace pellet. So the pelletization is a limitation.
So
again.
This DRI is the hydrogen with
hydrogen.
hydrogen.
But if you are saying natural gas DRI, natural gas DRI, that's the route to go. But where is the natural gas? That's the discussion he might be having, my management is having with the government, that in the eastern part, there is no natural gas. So the limitation is there. That's why people are saying, can we go to Middle East? Right? There is a thought, can we do steel making in Middle East? Because there is a lot of natural gas. You don't have to transport natural gas. Thanks, Rajiv. But I just want to tell you, GSP is building its last blast furnace. So we will build another. We are already going to the board with the repeat. So it's a game.
I just want to tell you, Rajiv, I just wanted to inform you. That since you talked of water, at least in the past 3 years or 4 years, the CSIR laboratory in Bhavnagar, Gujarat, and in Chennai, the defense laboratories, now they have made about a liter of water with 60 paise, a liter with 60 paise, with both technologies, RO, as well as the low pressure, what you call the condensation of water. Both the technologies have gone into commercialization. So hopefully, if we can convert our seawater into water with 30 paise per liter, then I think we will have a great time as far as water is concerned. Thank you.
Which then hopefully we can make Gopalpur another steel plant.
That's good. So with that, we come to a close. Okay, 2 minutes more. Dr. Farooq. Yes, you have to formally bring it to a close. Yes, in a minute you will bring it. Today you have spent here.
I will hand over to Mr. Mahanta. Thank you. The Chairman, Dr. Mahanti, Mr. Rajiv Kumar, Vice President, Tata Steel, Mr. Bimlendra Jha, MD, for a very lively discussion. I tell you, whatever we have done, we have heard today, can be easily rated one of the finest deliberations on this subject. I'm afraid, I'm not from metallurgy. I'm not from mineral processing either, but then still to a geoscience person, members of the SGAT here, they have all benefited from the deliberation today. Thank you so much. We cannot thank you enough. With this, I ask, request, Mr. Oh, yeah. Yeah, that is also there. Memento. Huh. Yes. Yes, it was there. Yeah. Mr. Javed Yadav Das. In the meantime, when he is preparing for the presentation of mementos, I'm just reminded of one story that James P. Blair, one of the editors of National Geographic, he had written on Orissa, an article on Orissa in 1971. Yeah? Okay. Dr. P.K. Banerjee. Dr. P.K. Banerjee, please come here. Yeah. Dr. P. and our president, SGAT. Okay. Mr. Rajiv Kumar, Mr. Rajiv. No, it's okay. No. Dr. Biswal. Dr. Biswal is supposed to have retired, but he's retired now. Thank you. I would like to mention, in case of, I would like to mention here in the raw material session, all the speakers, the entire session was arranged or organized by Dr. P.K. Banerjee. Thank you, Dr. P.K. Banerjee, for that. Dr. Raju. Ramchandra Raju. Thank you so much. Thank you. So, Mr. We will do that. Yes. Thank you. Join us. Sanjay. Yeah, yes. Thank you. Thank you, sir. Mr. Rajiv Kumar, please. Thank you so much for being here. Very much. Thank you very much.
Thank you, sir.
Mr. Sanjay Patnaik, once again. He is. Mr. Sanjay Patnaik is also another invited speaker who has been behind the arrangement of this seminar today.
Sir, may I request Bimrendra Jha to present this memento to Dr. O.N. Mohanty, please.
Sir, one more. Yes, thank you, sir. We cannot thank him enough. We have been corresponding with all of you. I appreciate sir.
You all.
Sorry, sorry. Yes, sir. Yes, sir. थोड़ा social distance Yes, sir. Yes, sir. Thank you, sir. So you want to speak of Chinese now in Bhubaneswar.
Yes. Oh, we have been trying, but
Yeah, I request, please, it is not yet over. The most important part, ladies and gentlemen, please back to your seat. Just give us 2 minutes more. The most important part of this, the vote of thanks. Unless we thank the people who have helped us organizing this seminar, it cannot be complete. Thank you, Mr. Tilochan Mahanta, to conduct the vote of thanks.
Thank you, Dr. Farooq. Actually, I am standing in between the closure of the ceremony and before I do my duty, I have to make one declaration. I have got one key. It is Maruti Suzuki key with letter A. Okay. So thank you, sir, for asking me to offer the vote of thanks. This is the most thankless job, as I see. But one thing I will have to tell, that for the last 1 year and a half, almost that, we have been pondering over this issue, that whether we are going to conduct a seminar or not. And when we decided that we will be conducting a seminar, then there was the issue, what will be the topic and all that, and who will be the speakers. And of late, one organizing committee was formed in which Dr. P.K. Banerjee, he's just extended one helping hand. And in our Sanjay Patnaik also, he also extended a helping hand. And ultimately, for 9th September, this was fixed and the topic was also fixed. And in which, with the insistence of our President, Dr. Onkarnath Mohanty, Dr. Farooq looked over the entire thing. But regarding the fixing of the date and all that, actually, I am missing today two of my vice presidents who could not make it to this venue due to their illnesses. One has just been discharged from Apollo Hospital and has been advised 1 week's rest at home. And other has just this morning been affected by conjunctivitis. So he didn't thought it proper to come to this venue and to affect others. So I am missing both of them. So my thank goes to both of the vice presidents of SGATs. And in the coordinating committee, there are a lot of people. I should like to name them: Mr. A.K. Raut, M.D. Behra, Jain Das, G.C. Das, Chadwananda Das, Girja Mahapatra, Rajgopal Mohanty is here, Dr. Farooq is here. And actually, what happens to organize such a seminar? Actually, initially I was given the task of making an estimate. What will be the amount required to conduct such a seminar? So I had projected some figures, and accordingly, that to our rescue, our diamond sponsors, the Odisha Mining Corporation and Arsenal Mittal, Nippon Steel, they straight away came forward to help us in that regard, and they relieved us so much. And to add to them, we had with us our gold sponsors like Jindal Steel and Power, World Consultancy Services, MGM Minerals Limited, and Tata Steel. I have to make a special mention about Messrs. S.N. Mohanty, MGM Minerals, and Tata Steel for the sort of help they provided just 2 weeks ago. While we conducted the Mineral Development Awareness Program in Joda, Mr. Prabodh Mohanty is here. I express my deep gratitude to you, sir, because you were the first who extended help. Then came this MGM Minerals. They provided the T-shirts, the photograph that was being shown by Dr. Farooq, all those T-shirts owned by the participants of 30 institutes across the country. We had participants from Uttar Pradesh, we had participants from Madhya Pradesh, West Bengal, Chhattisgarh, Jharkhand, Telangana, and of course Odisha. So Tata Steel, they entirely sponsored the project, but not only they sponsored the project, but the willingness they had, the interest they showed in executing that program there, that is somehow impressed all the SGT staff who had been there. Miss Samikya, along with her geologist friends, she is here. I will thank all of you from Joda, particularly Tata Steel personnel who helped us in just 2 weeks back for conducting the Mineral Development Awareness Program there. And thereafter, now Tata Steel has also come out as a gold sponsor for this event. So my special thanks to all of them. And our co-sponsor was also again Jindal Steel Stainless Limited. So we have got 2 Jindals this time. In Joda, there was another Jindal, that was JSW, was also there. So that way, we thank all of you, because without your help, such a seminar with all these arrangements, these LED screens and all that, this could not have been possible. And apart from this, there are many other firms and industries whom I would like to thank. Amongst them is our Geo Image Systems Private Limited, and particularly the 2 persons, Ashok and Prabhakar. These are the 2 persons. At times we hesitate to ask them for support, but they do not hesitate to extend support to us. And in all our programs with us, we have got our only one person is there. He is Mr. Tapas Rath. Without him, nothing could have been arranged. So with that, I thank you all once again. Thanks.